Okay, so people from YouTube can hear us now. Hello, everybody. Hello, YouTube. Hello.
Good luck.
Hi, Mom. I'm on YouTube.
Woo! Dude, you're talking to a world famous Minecraft world record holder. Multiple.
Yeah, I mean, quite a few of us are part of that.
Yeah, indeed. Okay,
Yeah,
so for
I was there. I disconnected, but I was there.
Okay, wait. Give me a sec, guys. For the people on YouTube, you guys already know how long this will take. We don't. I have
I
no
mean,
clue how long this will
I'm
take.
betting around 5 hours if we
Yeah,
do
maybe
all
more, maybe
grasple
less. We'll
plus
see.
some past papers.
Yeah, so you guys can already see that in like the length of this video. We have no idea, so I might like have to put a lunch break and maybe even a dinner break in, but we'll see.
Sounds good.
I don't think we're gonna reach the break level, but
I don't
yeah.
think so. I don't hope so, at least.
We just might.
Yeah, we might, but I don't hope so. Okay, I'm gonna
I
share
would
my
not be
screen now.
surprised.
Never know.
Okay, so question: are we all doing together yours, or are we all doing at the same time ours for grasple?
Well, the plan was just doing it like we always do our past exams, or
Yeah, okay,
so
fair
that's
enough, that
just
makes
me
sense.
and everybody helps out. But
That
if you
makes
want, you
sense.
can join along as well. It's not that hard just to open up grasple and do your thing as well. So it's up to the people whether or not they want to. Okay, so first of all, I'm gonna start by explaining the DI method, the tabular method, or whatever. It has multiple names, and it's basically a really fast way to do integration by parts. So imagine we have this integral here, or let me actually change to an unbounded integral because I don't really care about this, like the bounded version. But imagine you have this integral. This is also why I asked for the random numbers. So
I can guess that.
to solve this, the easiest way would be integrating by parts like 3 or 4 times. I do not feel like doing that by hand. So basically,
the Almighty.
what we do is I'm gonna copy the integral over here. My integral will be integral sign will be very bad on here. So we had, let me check, 759. So that is.
Wait, quick question. Does it also work for definite integrals?
Yeah, definitely. Anything that works for indefinite integrals is just plug in the numbers afterwards and it works.
Okay.
7.
You just have to be careful with your limits if you do substitution, for example.
Yeah.
Okay.
Times e to the power x dx. Okay, so I call it the DI method because we take a very big D and we take a very big I. You see,
Differentiate, integrate.
it's kind of obvious why it's called DI at this point, I think. Then we have a plus, a minus, plus, minus. Okay, let me change the size a bit. Okay, so when you're doing integration by parts, you always want to differentiate one part and integrate another part. So the part I want to integrate in this case is 7x squared plus 5x plus 9, and that's purely because it's just way easier to integrate e to the x than it is to integrate that other thing. Let me move this over a bit. So my paint.net skills are unmatched, by the way. Anybody who says otherwise will be kicked. And we want to integrate I to the x. Okay, so if we differentiate this whole thing, we get 14x plus 5 and e to the power x. Well, this is doable. We can take it one step further, and we can differentiate this as well. This becomes 14, this becomes e to the x. And we can differentiate one step more, and we can this becomes 0, this becomes e to the x. Okay, and the thing about the tabular method or the DI method, or however you want to call it, is you can do this as many times as you want. And basically, for every time you've done it, you can say, okay, I want to take this thing. I want to add this thing. I want to add this thing. And then eventually, when you're done with like adding something outside of the integral, you can be like, okay, I'm done. Now I'm gonna add the integral of this thing. So the this thing would equate to 7x squared plus 5x plus 9 times e to the power x. That's the first one here. Minus 14x plus 5. Oh, 14x plus 5 times e to the power x plus, and then this one, 14e to the power x, and then minus, and then let me draw an integral sign real quick. That's a really bad integral sign, but I'm going to draw a lot of really bad integral signs anyway, so that's okay. 0 times e to the power x dx. Which, of course, in this case will, yeah, the integral of 0 will just equate to a constant. So this is equal to, let me do some quick math. So we have 7x squared plus, that is 19x plus 9 plus 5 is 14, 28 times e to the power x. That is not correct, and this is why I need other people as well, because like I am really bad with my minus signs. So we have minus 9x because plus 5x minus 14x, and then we do plus 18 times e to the power of x plus c. So we just differentiated by parts 4 times, and it took us what, less than 3 minutes?
Rip those who missed this and are gonna join in like 3 minutes.
Mhm.
Rip those who missed this and are gonna join now.
Yeah. Yeah, I'm gonna do it a lot, and like to be honest, this method is just, it's so simple that when you see it being done once, you probably already quite understand it. So whenever you see me do it for the first time, you'll kind of just understand. And if there are any questions about it, just let me know, because it is an interesting concept. I am, by the way, just literally
pretty
gonna
OP.
keep this as a template, because I'm not gonna like draw or anything on my paper, because you guys won't be able to see that. So I'm just gonna keep it like this. Okay. So in the end, yeah, in the end we figured this out pretty easily. Now I don't think there's anything else left other than just starting the speedrun.
Yeah. Nice split. Do we have different splits for different sections?
Absolutely not. I'm literally just gonna start a timer and stop it when we're done.
Nice.
Yeah.
Not even splits for the different lectures.
Nope. Because that would have required me to put in work beforehand, and I have not prepared anything other than the messages I sent in the group chat. Come on, there it is. I mean, I guess I can make this real quick. So
Don't want to record the timestamps.
so we have.
Have
Oh, I
right
still got my old one. So we have start lecture 1, lecture 2, lecture 3, lecture 4.
Up to lecture 10, I think.
Yep, insert below. Lecture 5, lecture 6.
This is the moment where you copy lecture so you don't have to type it every time.
No.
Pretty much.
And then do we add like first pass paper, second pass paper?
I mean, you don't really need to put the lecture 10 there, because that's basically the end.
Oh yeah, I guess, because it's like you're
And technically,
done with
you also
lecture.
don't need to start.
You mean don't need start?
No.
I guess.
Yeah, it's fine like this.
I think
Introduction.
we do need. I think we do need one more, and otherwise I'll just take the stuff for lecture 10. No, thank you very much, but I will not require my in-game time from Minecraft to be present in my speedrun for grasple.
Remember to save your layouts. Don't override it.
Yeah,
I have done that
I
myself.
think I have a
and you
Minecraft
will
layout.
also change the layout so it displays all the lectures. It's fun. I mean, it's personal preference, but
Yeah,
Put that in the top right corner. I think that's the best.
there you go.
Okay. So for the people who want to join along, when you go to let me show you. So when you go to calculus, oh, I didn't do my incentive code yet. And you go to literally any of the lectures. So I'll go to lecture 1, the graphical introduction. Oh, Brightspace is fast as ever. Love it.
That would have been the start.
Well, yes and no. You can click this one, and it will give you like a link to just an in-window grasple. And then you can click grasple, and you will be at the page where you can see like literally all the things. As you can see, I have not been very
Productive?
yeah,
Something like that.
I've been slacking a little bit. I've done like one thing on a substitution rule, and I finished it like very poorly. The goal at the start is going to be 100% run, but if that turns out to be too tiring or too long or whatever, I'm just going to change to an any percent. But hopefully we can manage a 100% run.
I mean, to get a 100%
green
run,
everything.
it's not actually a question of doing a lot. It's a question of doing good for the like 5 first, right? You
Yeah,
need a certain number of points.
It's getting
And
lucky, basically. Like, if there's one you cannot answer, just restart the quiz until you don't get that one, and then you still get the 100%. Or if you're gonna any percent, just enter and then you're done. Like, any percent is still zero,
Yeah.
right?
Just skip.
Yeah, because
Yeah,
like,
exactly.
to pass to the next step, you need a certain number of well-answered one. But for any you don't answer good, it's gonna be deducted from the points you get.
Yeah.
Let's just say learn percent, where we try to get through it, but we don't fucking spacebar it the entire time.
Just go for a
Right.
green check mark.
Yeah.
Green check mark, then it would be more like 100% anyway.
Yeah.
No,
Yeah,
you
green
can have
check
one or
mark, I
two wrong
think,
and
is
still get a
like-
green one.
You've got a couple questions you can mess up.
Oh, okay.
Yeah. Okay.
Let's just see if we can manage green.
Whatever. We'll see. Oh, and also in Paint.net, I am gonna real quick, because I have not learned any of the identities by heart, as in the ones for triangles. So I'm just literally gonna draw a triangle.
I mean, you are with like 15 people.
That's
It's
true.
likely someone knows them.
That is correct. That is probably true, but in case nobody does.
Honestly, right as soon as the exam begins, I'm gonna write down all of the triangles, like draw all of the triangles, write down all of the values and all the identities, because like I don't know them by heart, but I know how to get to them by heart.
Exactly.
And I'm just gonna do that right at the beginning and make myself a little table, and I don't have to memorize it.
Yeah, I
that's
probably
bad.
won't make a table, but like if I see something like this and I say, okay, I know this is 1, this is x, then I know that this is gonna be square root 1 squared over x squared. Stuff like that. But it depends on the question. Anyways, I say we're ready.
All right.
Before this becomes an official category on speedrun.com.
I'm gonna request category. No.
TU Delft Calculus CSC 1200.
Yeah, and not only that, but it's like a super specific category because it's like 1 to 10. So you have to create another category if you want to do.
This is the category midterm percent.
Yeah, okay.
Midterm percent. Yeah.
Midterm %, I can live with that.
You don't even get the same question, so the difficulty will be different for everyone.
Yeah,
RNG.
Speedrun will
I
only
mean,
count if you
it's
pass
like
the
it's like
midterm.
random seed, right?
Yeah, it's like
Yeah.
RNG. And it's also glitchless because we're not just saying. Okay,
I was about to say, how can you glitch this?
Yeah, we don't just go like, hey, select or document.select element by ID, checkmark dot color green. Okay, done.
Wait, I have a question. So actually, each one of us does it on his own in grasple, or we watch you and we do it, your questions we get.
I mean,
That is up to you. Like, most people will probably just watch me do them and help me out whenever they need to. But if you want to, you can do them on your own as well, because that will help you as well. It just depends how lazy you are.
I mean, I'm gonna do them. Like, I'm gonna be watching yours,
You're
so do
talking to a
yours.
bunch
Yeah.
of computer scientists.
Yeah, because there's no point in being here otherwise. Yeah.
Yeah, like if you're gonna do your own grasple, it's not gonna be the same questions. So
Exactly. That's
Yeah,
why.
exactly. All right.
So we have to watch. Yeah.
We'll do it with him.
Most likely. All right, and I'm gonna start at like lecture 1, by the way, because you know this. It's a lecture 1 to 10, not an introduction to 10.
Yep.
Okay, let's see. Well, I guess 3, 2, 1 time. No, what? Oh my god.
Time lost, reset.
Start
10
practicing.
second penalty.
Oh god. Oh no, I forgot this was a thing.
Arc sine root 3/2. That's That's 2 pi over 3.
2 pi over 3?
No, because it's
Pi.
between 0 and pi half.
Oh wait, okay, then pi over 3, that works as well.
Yeah.
I mean, you have
Oh,
the
yeah, you
symbol
have to-
pi, I think.
Yeah, you do.
It's on top right there.
Wait.
Yes, that works. That works.
Oh my god.
My god,
Let's
please
go!
don't do that.
Let's go.
Pi over 3, I told you.
That's not
Pi
You write
over
down pi-
3.
Oh yeah, you can't write down pi. You have to press the button. That's why.
Yeah.
Yeah.
When you write down pi, it doesn't take it.
Wait, you literally just
I mean,
wrote the
I'm
same
sorry.
thing.
But
that
wait, does
count
it
as
also work
glitches?
on the midterm?
We don't know, maybe.
I'm kind of wondering about that.
Perhaps,
Should that
yeah.
count as glitches?
What?
It's not a
Pi over
glitch.
4.
No, it's not a
Okay.
glitch. It's just it has a calculator. It's just that
It's
it
an
doesn't
exploit, but an exploit is not a glitch.
Right.
It says it
I'm-
right in the
So-
introduction. The box is also a calculator, and you can use that.
Yeah. I thought we could use this on the midterm. Yeah. Okay. But
Box
they
is a
won't give us
feature.
this.
over
Like this
4.
too easy, right? So
So that is.
Arca. That's pi over 4.
yeah, pi. No pi. Yeah, pi over 4.
Pi over 4, you say?
Yeah.
Yeah.
How do you
top.
calculate so fast?
I think if
Yeah, you
if
have
I do
to-
this, yeah.
I mean, it's
Yeah, you can do
basically
a
the
MATLAB.
sine cosine for pi over 6, pi over 4, and pi over 3 is half
Reversed.
square root 2 over 2 and square root 3 over 2. And it's reversed for cosine.
Exactly. And I
Yeah,
have this.
I
This is
just-
really simple method. You can
Just
just
need
have
the-
0, pi over 6, pi over 4, pi over 3, pi over 2, and it just goes 1, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2.
Basically.
Yeah, I usually
Which then
draw,
becomes
the,
a-
draw
yeah.
the circle out of my head, because I'm not used to doing that, it takes a long time.
Yeah,
Yeah.
unit circle. But
Okay,
it's
negatives.
like these are the hardest one, I think. Like for
I think the arctangent of a negative number is equal to the arctangent of the positive number, so you can just take the arctangent of
Yeah.
positive 1 over 3, 1 over square root of 3.
Yeah.
Yeah, that would be
And
pi
that
over
is-
6 then.
What do you say, pi over
That's-
6?
Yeah.
It's minus.
No.
Minus.
Minus?
Minus?
Oh yeah.
I like how we're guessing.
Negative number.
It
I mean,
is
there's
minus.
No, it's because
minus
it's
one
minus.
divided
So
by square root of
sorry.
On
3.
the midterm, we have only one chance, right?
Yeah.
Okay.
So,
Wait, then
there's-
why
okay,
wouldn't
guys,
that
this is just a
work?
warm-up, just a warm-up, no worries.
Oh no, it's because the difference. You can't just flip the sign. The difference is
Yeah, like you can do that with the cosine, but not with the sine, and because tangent is sine over cosine, one of the two signs get carried, the other one doesn't. So
yeah.
it the entire sign gets carried. I think this is just, yeah.
yeah.
3 over like the thing here is you have to remember that it has to be between I think it's pi and 0, or either
Depends.
that.
Yeah,
pi and
0 and
It
minus
pi.
depends for every function. So between for arc cosine, it's between 0 and pi. Yeah.
Yeah.
That's
Okay.
fine then.
Yeah, so 3 over
Yeah.
7, 3 over 7 times pi is fine here. And then the arctangent, that's the same reach as the cosine, right?
No. Yeah. No.
This is,
Arctangent is
minus.
between minus
This
pi
one is
half
out of
and pi half.
bounds.
Here wait. It's one cycle apart, so I think it'd be 2 over 7 pi.
Yeah, 2 over
So
7
we-
pi
I'm
sounds.
2
sure,
pi
but I-
every time, right? Do you add or subtract 2 pi
Right.
or?
For the tangent, it's only 1.
Yeah, for tangent it's only 1.
Okay, and the rest is 2 pi for cosines and
Yeah.
Yeah.
yeah. Okay.
The arc sine of negative. That's on the y-axis.
So it will be pi over 4, but it's
Yeah,
the negative,
but, yeah,
and
the
it's defined
negative.
between minus pi over. So it's minus pi over 4, because it's
Yeah.
symmetric over.
You
Careful,
need
your
to.
pi is not the good.
Yeah, your pi.
Yeah, negative pi over 4.
Honestly, for these things, I just have a graph that I drew out and the table, and I just can sort.
Yeah.
sort
At
that.
this point, I would draw the
Honestly, yeah. Make a table with all of the sine,
Yeah.
cosine, and tangent values, and then just
Yeah.
a small graph with like the sine function, the cosine, and the tangent. I think that it's super quick because I see,
Yeah.
for example, that tangent is reflected on the y-axis, and I know I only have to take the negative, for
Yeah.
example.
For me, the way I do it is like
Unit
oh,
circle.
that's a triangle. Yeah, a circle indeed.
I mean, you only need a quarter of the unicycle, so
It depends because like if I know that this line is sine of x, this line is cosine of x.
Yeah,
that
it's
helps with,
like
knowing that sine is mirrored over this axis, cosine is mirrored over this axis.
if you go over the circle, it's like all in the right corner, top corner, then sine in the left top corner, then tan in the left
Yeah.
bottom corner, and then
So
cos in the
sine
right
is sine
bottom
is in
corner.
this like in this quarter, and cosine is like in this quarter,
Yeah.
or half.
And because tan is like the two together, when they're both negative, it's
Yeah,
positive.
both together, just this one. Yeah. I am getting pinged. Holy shit.
We're losing time on the speed run.
Oh yeah, shit. You're right.
We need to finish this quick.
Okay.
Stop fucking cheesing it.
The
It's not.
G. Okay.
It's intended mechanics.
No.
This one is.
Didn't. Oh, no.
Wait, didn't we do this before? Oh no.
We had a similar one.
Yeah.
Arctan minus
we did, I
1
think.
over 3.
Just
That, I mean,
Minus 5 over
that's,
6, right?
that's still 5 over 6, yeah. Or minus 1 over pi over 6, I
Yeah,
guess.
minus 5 or 6.
Yeah, minus
Yeah.
5. Okay.
You guys are carrying this.
Only
Yeah,
for the
this part is
beginning.
just remembering, so.
Okay.
Only
sine
for the
of arctan.
beginning.
So let me get rid of this.
What was that? Sin what?
It's the sine of arctan of -4 over 3.
Okay.
So the arctan, well, here we have -4, here we have 3. This is the square root of 25, so that is equal to 5. And sine is -4 over 5. Yes! Okay. I was about to look like a fucking fool if I got that wrong. Cosine of arctangent. And, like, especially...
Cosine of what?
Mhm.
Okay. Yeah, I'm just.
Okay. So I know that the tangent is right over run. So then we have the square root of 82 here. Yeah, and cosine is -9 over... Oh, 1 over. So that is 1 over
Yep.
square root of 82. Sick.
Beautiful.
Yeah, like these questions I can do really quickly, but the one where I actually have to know the values, not so much.
Okay.
Wait,
Sine of
this one
arc
just
cos.
5 over 4? Shit.
No.
Oh, wait, yeah, no,
It's the one where you have to use sine squared plus cos squared equals 1. You have to use this and like mess it around.
Now you
Not
can do it
really.
in this.
I
You can
think
do it in the triangle.
you
Yeah.
can just use the triangle.
Or
Cosine
you can do
is
the triangle as well, yeah.
4 over 5, so that is, so this is, what is that? 25 minus 16, square root of that.
3.
So that's 3.
3.
So that is,
The sine of it,
the sine of it, so that is,
So it's 5 over 3.
3 over 5.
5.
Oh my god. Yeah, sorry.
No, fuck, typo.
Oh god.
No.
Glitch.
Okay.
That's one of my biggest troubles with grasple. They don't show you a box of your answer.
Yeah.
With this
So,
one, and with the bigger formulas, it sucks a lot.
the cosine of arcsine. So we have, and that is what, 6 over 7. So 6 over 7, and this is that's 49. The square root of
13.
Wait,
49 minus-
does it matter where you type the square root?
So that is
Does it matter where you write the square root?
What do you mean where you write the square root?
On which side of the triangle?
The one you don't know.
It does matter, I mean.
Yeah, like this is just Pythagoras. So if you have these,
Yeah.
if you have these two sides, it is the square root of the one plus the other, and if you have these two sides, it's the square root of this one minus this one.
Yeah.
And the same for over here, the square root of this one minus this one. So we have this one, and what do we need to know? We need to know the cosine, so that is...
I mean, there's like a simple rule for it, like, you know, if you guys know SOHCAHTOA, like
Yeah.
sine
Yeah.
opposite over hypotenuse.
So that's square root
Yeah.
13
So
over
if you want to use that, that's very easy.
7.
Been so long since I've used that.
I
Yeah,
still
bro.
use it all daily, no cap.
Beast.
Arcsine of minus 3 over 5. So that is minus 3 over 5. Then we get, this is probably 4, because we use,
Yeah.
yeah. And we get the tangent, so that is minus 3 over 4.
Can it also be -4? But
I like how they're like, use this formula. I'm like, ha, no. Okay, guys, you're up.
Okay, arcsine root 2 over 2, that is pi over 4.
Pi 4.
yeah, pi/4.
Dude, you guys are fucking machines.
I mean, you see that 2 is almost always.
Arcos
Pi over
root 3
6.
over 2,
Yeah.
yeah, pi over 6, yep.
I already
okay.
wrote down all the values on a piece of paper.
Oh,
Ah, nice.
Okay, I'm
Pi over
thinking
6
them
again.
up. Give me a second.
pi over.
Yes, that is.
Okay, that's done. That's done.
All right.
Split. Oh, no, wait, not
83%.
split. That's 2 parts.
No, wait.
No,
How do I undo split? Do I have a
There's you.
undo
Numpad
split?
8.
Hey, let's go.
Okay, let's go. Let's continue.
wait, we are. Yeah.
Find the largest value that x is invertible on this thing. Okay, so this
For
is
the
a
maximum.
cup parabola. So that means we need the maximum value. We need the top, so that is negative b over 2a. So that is 3 over 2. Still got it, baby.
GG.
Did you guys understand what I did, by the way, just now?
No, no.
Oh, I never learned that. It's probably a quick formula, I guess.
Yeah.
The formula was a parabola, so it was something like this. Not the best. Not the
Yeah,
best
not to
parabola,
scale.
But they ask on which interval from 0 is it invertible, and that is basically until the maxima of the thing, because after this you will get like it will fill
Minimum.
with the vertical line test. So from the start until the maxima, that's where it is invertible.
If you don't know this, just do the.
Oh, and the extremum is minus b
derivative.
over a over 2a?
Yeah, minus b over 2a.
Oh, okay.
So the largest day
Yeah,
was.
I would have just taken the derivative.
What
that's
was
why I
the?
did that.
Okay, so find the inverse of f given. Okay, so we have. Let me open.
6x minus 6 squared.
So we have. You can see that like I use a lot of things notes for calculus.
Yeah.
6x minus x squared equals to y.
Switch x and y.
Yeah, and then we get 6y minus y squared equals to x. Oh. My best bet. Oh wait, actually I see. So we have
Square.
minus. Let me actually change this around real quick. So we get y squared minus 6y equals minus x.
6y.
Then we
No.
complete the square, so we get.
You turn the x into or a y into an x. Yeah.
Thank you. So we get this minus 6y, and then we get minus. Or I think it's actually plus 9. Minus 9 equals to negative x.
Yeah.
So then we get y minus 3
Squared.
is equal to minus x plus 9. Then we get plus or minus,
square
really
root
important
of-
step, plus or minus y minus 3 is equal to the square root of minus x plus 9. And they want to know it for x is less than or
X
equal
smaller
to 3.
than 3.
So,
Not minus.
yeah, so we take the minus here, so we'll get 3 minus y is equal to the square root of minus x plus 9. And then we get y is equal to minus the square root of minus x plus 9
Plus 3.
plus 3. And then we paste this in here, and oh! No! So we get minus x plus 9. Okay, it doesn't like my own syntax. Check my answer. Let's go! Okay, so we have... so that is, what is it? 6x plus 7 over 4x minus 3.
4, right.
Y equals 6x plus 7 over 4x plus 3. So swap around x and y's. 6y plus 7 over 4y plus 3. Multiply both sides by the denominator, so we get 4y plus 3 times x is equal to 6 y plus 7. Then we get 4xy plus 3x is equal to 6y plus 7. Then we get everything with the y on the left side. So that's 4xy minus 6y is equal to 7 minus 3x. Then we take out a y out of the factors here. Is equal to 7 minus 3x. And then we get y is equal to 7 minus 3x over
4x minus 6.
Yeah.
I am speed.
Oh my
How about you
goodness.
just keep it like the way it was, and it should probably.
Yeah, I
be
think
fine.
that was okay the way it was before.
Like this?
Yeah.
Probably, yeah. Fuck me.
No.
Made
Never
it.
mind then.
You made it.
Although I don't know why. Pretty sure that you.
No,
Grasp is
they
just
want
dumb.
you to
Oh,
have it
yeah.
in the format that they have.
No, I think we took 4x plus 3 and not 4x minus 3.
So
Did
we
we?
started out with 7x, 6x. Oh,
We did
Oh.
4x plus 3 and not minus 3.
Yeah.
so theoretically, I should be able to just fix that by inverting this tree.
Yeah.
Let's
Yeah.
go.
Saved.
Okay.
It's too bad we didn't get the points though. That's gonna
Yeah,
mess up our
We're not going
100%
for 100% anymore.
already.
So that is 3 over 2. Yeah.
No, this
We
is
already
any
had this.
Okay,
speedrun,
split,
guys.
split.
Start less. Wait. Back to less.
Back to lessons. Yes.
Calculating limits.
So we have to
Go.
do this one now. The limit of x goes to minus 4 of this. So
Frick or isn't?
isn't this just like? Oh no wait, okay. Because the answer ends up being
0 over
Oh,
0.
wait.
It's indefinite.
So El Hospital rule.
Yeah, L'Hôpital.
Yeah, okay, yeah. So
That's only
Yeah.
lecture 6. What?
I was about to say.
Yeah,
this is not gonna be
we're supposed to cancel out. We're supposed to do it without.
Yeah.
Uh,
Yeah,
But
we're
L'Hôpital is
supposed
so
to
much
multiply
easier.
top and bottom by the reciprocal of this.
yeah.
You guys want to try L'Hôpital?
No.
Yeah, we're
I
we're,
mean,
Yeah.
like
we're not
I
required to
mean,
not.
sure. So
we're not
bottom
required to
derivative
do
is
the
1.
archaic methods.
Yeah.
Top derivative is like 1 divided by 2 minus x minus 3.
Yeah. So we
It's
start out with
supposed not prohibited.
Times 1
square root
or minus
of,
1.
Negative x minus 3, I think it was, minus 1. Is that correct? Yeah, over...
Yeah.
I'm going to use this notation real quick. So over x plus 4, I think it was. Yeah. So equals by L'Hôpital. You should also write the limit here if you're actually going to be doing anything with it, but I'm not. So we can take away constants, and this becomes... so that is negative 1 over the square root, or 2 times the square root.
Yeah.
Okay, filling in minus 4 will end up giving negative...
Well, you have to you also have to derive
You-
the bottom one.
Yeah, you have to divide by 1,
Oh yeah,
not by x.
yeah, get one.
So basically,
Wait. Damn it.
So it reaches 0.
Oh, wow. Yeah.
So this is minus 1/2. What is that? Minus 4, or plus 4 minus 3. That square is 1. So this is
So that's 1.
minus 1.
So that's minus a half divided by 1, so that's just minus
minus
1/2.
Okay, so we'll get...
God bless L'Hôpital.
yeah,
Easy.
yeah, okay.
Yeah, fuck that.
I mean, yeah.
Was it faster? Maybe.
L'Hôpital's here, I think.
No, that's... we could do L'Hôpital here, but it's faster.
To be honest, it
this
would
is-
be faster.
No, I
Every
don't- I
limit
think it
is
would be
just a
faster to just
L'Hôpital,
say that this
do
is
it
x
works.
minus
You would
4,
get
x
2x
minus
minus 9, so that's 8 minus 9 is minus 1 divided by 1 is minus 1.
5.
Yeah.
Well, yeah, but you
Yeah.
can also see that because this is x minus 5, x minus
4
4,
and 5.
so that is...
Yeah,
Yeah. You can just
minus-
cancel out. So it's x
No.
minus 5
For
over.
speedrunning, L'Hôpital is always
X minus 5, so then, yeah, 4, and then, yeah, okay. Yeah, minus 1,
Yeah.
yeah.
This
Easy.
is the method I use, but
Yeah.
L'Hôpital would be good too.
Yeah.
Like,
That-
L'Hôpital is fast, but this
To be
one
fair,
can
for
be
these
even
equations, the
faster.
intended method is probably the better one.
Yeah, for this one especially.
Yeah.
So we've got
Because this would be a mess in L'Hôpital
9
too.
minus x plus 5.
not really.
So we have
Okay.
square root of 9 minus x plus 5 minus 3,
Three.
and then over the square root of 81 minus x plus
81
5.
minus x plus 5.
uh,
81 minus x plus 5.
Yeah, minus, I think it was 9.
9.
Okay, so we multiply both sides by the reciprocal. So we get, we end up with, the top one will get both of these squared multiplied by the reciprocal of the bottom. Yeah. So we will end up with this. And like the top one will have this times its reciprocal, so what you get then is just the negation of the squares. So we can take away the square root here and we'll get this. And then the bottom one will be this one squared as well, so this will become 81, and this will get its brackets removed and multiply by the reciprocal of the top one. You guys understand what I did there?
Yes.
Okay, cool. What do we have to fill in? We have to fill in x equals to 5. Let's see where we get. So we get this, we'll get x, 9 minus 5 plus 5 minus 9, so this is 0.
Yeah.
0.
Get to
So
So that's 0.
So the top is 0.
It's 0 over 0.
Just make sure that the bottom isn't equal to 0.
0 over 0.
Oh, never mind.
No, the top is not 0.
How is it not? Wait,
Uh,
9
fill in
minus
5.
9.
oh wait, no. Yeah, it's times square root of 9 minus 3. No, you're right. It's 0. Yeah.
I
0
don't
over
think
0.
we're meant
Yeah,
to
I think you're
rationalize
only supposed to do it
square
for
root.
the denominator, not for the...
Yeah, I think you're supposed to do the square root trick. So you're supposed to just
Yeah,
get rid of
this
the
is-
If you
square
do both
root
at
by
the same time, you
multiplying.
don't get progress.
Only do the bottom one.
Yeah,
Yeah.
sounds
Or the
good.
So
top
you
one, whichever one.
multiplied both by the bottom one only.
Yeah.
Okay, so I'll do that real quick, see if we get more progress there. So I will turn it to a plus.
Actually, it's preferred just to do the bottom one because we just don't want the 0 to be there at the bottom.
Yeah.
Because that's
Yeah.
unsolvable.
That makes sense.
Remember to change the 9 into an 81 at the bottom.
I'm pretty sure Lupita was just asking.
Yeah, it's
Oh, yeah? That is minus 5. So this is just 81 times 2, so that is 192. And then we fill in 5 here, we get 9 minus 5. Or minus
So that's
5
just
plus
square
5.
root of 9, so that's 3 minus 3 is 0, so answer is 0.
Oh, the answer is 0.
No.
No. Oh no.
What? We're getting scanned
No.
here.
Wait, go back with the. How do
Don't
you get
apply the
192?
limit. Solve it a little bit first.
But something times 0 should always be 0, right?
Yeah.
But you're applying the limit. Solve it a little bit, then apply the limit.
So
I would
here
say that.
This would be 18. But even then, you know, this still converges to...
I
Yeah,
think
no, I
I
don't think
found
you
where
did
you
it.
messed up.
Can you show
At the
limit
very
again?
top, you have you divide by minus 9, right? At the very end, it's minus 9. And then you square it, and then you have minus 9 times 9, and then somehow you get a positive number, because you got 81.
Oh yeah, it's negative squared, so it's
Minus
minus
Yeah,
81
it's
squared.
negative 81.
Then the 81 minus
Yeah.
81 cancels out.
It's not minus 9 squared, it's minus 9 times positive 9.
Wait,
Yeah.
Wait, for which one?
no.
That one should be plus 9, where
Wait,
your
but that
cursor is
doesn't help
Yeah,
us though.
this is plus 9, yeah.
And
Okay,
then
wait,
at the bottom, it cancels
Give me
out
a
the
sec.
81.
So we get,
Yeah, that's
we
the
get
problem,
this,
then we get another 0.
we...
You're supposed to also do it with what's above the divisor. You're supposed to do both.
So we multiply this by the reciprocal, this turns into 1 squared minus the other squared. So this becomes 81, and this becomes this thing.
Yeah.
And then at the top we multiply by the reciprocal as well. But the top will still have 0 in it.
Yeah, but if the bottom isn't 0, then it doesn't.
Yeah,
Oh, wait,
but we
it
know
is.
the answer is not 0.
Yeah.
No, you multiply by plus 9, see. You still have minus
Doesn't matter. We're still getting 0 because 81 minus 5 plus 5
This
minus
one-
81 is still 0, and then 0 over
And
0.
we have to do it actually with the nominator, like
Yeah,
with the
try,
square.
try the vice versa, other way. Multiply
Yeah,
with plus
I don't
3.
think that. Yeah.
Okay, so...
Yeah, I'm gonna check the lecture slides because I think this is like.
Wait,
I am confused.
We have to multiply both of the denominator. I think.
I'm confused.
Yeah, now you can. Yeah, now we get 9 minus 5 plus 5, meaning square root of 3. But then you get minus 3 again.
Yeah.
Uh,
if
But
we
then you can
multiply-
divide. You
Well,
can.
if we've got an indeterminate
Oh,
form,
yeah, it's plus
we can
3.
apply L'Hopital afterwards.
So then we get 6 there, so then we get 6 times 0. Fuck.
Wait, what?
Wait, isn't minus x plus 5 a common factor in both and we can cancel them out?
Yeah.
And then on top we are left out with square root of 81 plus 9.
No, we cannot just delete it because there's minus 3 and plus 3.
Wait, this
No, you
becomes
have
9.
a term minus 5 plus 5 times square root of 81 minus x plus 5. And at the bottom there's also minus x plus 5 times something, and you can just cancel those out.
Yeah, exactly. That's what I meant.
Yeah, so you mean we get rid of this one.
And on the top one, the first part is when you multiply them, you have like, yeah, exactly. You could cancel out the 9s as well.
Oh yeah, and then you get rid of this.
Yeah, and we plug in the 5.
Okay.
So then you get divided by 6. And at the top you get 18.
So this
Yeah.
18 over 6. So that's
3.
Yeah.
I see.
Wait, can you switch
the
back?
step of like dividing stuff out.
Yeah.
Can you switch back? I didn't catch like because we changed so fast the tabs. Yeah.
Okay, so basically what we did is we filled in these things.
Yeah.
So after multiplying you get this, but even now if you fill it in, it's not going to help. But
Right.
on both the top and the bottom, if you get rid of this minus 9 plus 9 and minus 81 plus 81, you end up with minus x plus 5 on both sides, and we can divide out with by that.
Right,
And
and
then
then
we
you
get
only
answer.
have the.
Yeah.
Yeah, that's a good one. I did not see that. Okay. Oh, that looks a lot more fun.
Yeah.
So we've got x minus 3 over square root of 39 minus x minus 6.
Yeah, just look it out.
Square root of 39 minus x minus 6. Okay, so what we do then is we multiply top and bottom by the reciprocal. So this becomes, let me copy this first, and this becomes 36. This becomes, get rid of the square root. We put some brackets around here. We multiply by the reciprocal of this. And
It should be plus.
yeah, and we get rid of this x minus 3. Then we can see, is this correct? Yeah. Okay, so this becomes 3 minus x. That is equal to negative opening brackets x minus 3. So then we can get rid of this thing over here and this thing over here. So this is just equal to negative this thing over here. And then we will end up with negative...
Put 3 in?
Yeah, negative minus 3, so that's negative 36. That is negative 12.
Yeah.
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 Nice.
Okay.
Good.
Get this again, kind of thing.
Can we stop? So
Para du lastgras.
Kind of feeling like L'Hopital would honestly be faster.
you know what? Let's try it. Let's fucking try it.
Yeah.
I'm down.
Because the minus 1 over 2, they eliminate themselves from the wall.
Yeah, so we'll get 1 minus x minus 4 minus 1. So then we'll say
Just remove
by
constant.
L'Hopital is equal to... Okay, so these factors fall away. This
And you
only becomes
swap them.
negative or negative 1 over 2 times this. This also becomes negative 1 over 2 times this. We can multiply both sides on the top by negative 2. So this will become this one gone, and this will become this one gone. This one gone.
Why negative?
To get rid of the negative signs. And the negative signs are there because the x had a coefficient of minus 1 in front of it.
Yeah, just swap them.
Oh, okay, true, true.
Okay, did this help though?
What's the value? 4?
Wait, I think it might have. Oh
Yeah.
yeah,
What?
because the reason
You-
You get 6 divided by 1, don't you?
You just remove constants and swap their places of the square roots, and then you calculate.
Okay, so this is +4, -4, same as this. This is
The same thing.
Also +4, -4, so that's 1.
Yeah. So then we
So
will
you
get
get 1 over
6 divided by
6 over 1.
Wait, 1
yeah,
divided by 6.
that's 1/6.
Yeah.
Nice.
Yeah,
Boy.
Mikita is fastest. Oh, what?
0x. Nice. Well, let's take L'Hopital's rule then.
I get what they're doing. The answer is 8.
Yeah.
Like, but basically what they were doing is x -4, x +4, and doing -0x is just fragments of their bad coding.
Yeah. I had it as well also once sometime.
Yeah. Oh, nice. Back to lessons. So that
And
is,
that's
that is
split.
lecture 2 done.
That is
I,
yes.
I need to map it to another key.
15 minutes per lecture. Okay, so 2.5 hour run.
Oh wow, that's actually pretty good.
I mean, that's the start, though.
Yeah, I mean, it
yeah,
gets
these are
harder.
the easy
It's
things.
gonna get
By the way,
harder.
you can try to split the screen. One half is Notepad and one half is the browser. If
Yeah,
it
we can do
doesn't
that.
bug
That's
out,
not too hard.
so you don't have to auto-tap so much. Yeah.
Yeah, and then I will actually put this one over on the left side. Okay, I don't
The
have enough
top,
space.
the top of the browser
could
won't
also
show
just make it
anything
smaller.
interesting,
Yeah,
so
we can make that smaller, I guess. Yeah.
You don't need the skip button, just cover that. Now it can be bigger again, because you don't need the top of your browser.
Oh yeah.
Alright.
Dude,
yeah.
using skip buttons is for pussies. We are the real MVPs. Okay, so
See, we don't skip answers, we give wrong answers.
exactly.
Yeah.
So we have
We
the
I
take
mean,
the
we
only
can
way, man.
just enter 3 wrong answers, and then they're gonna skip for us anyway.
Yeah.
Yeah. Okay, so we have the limit to x goes to -infinity of this whole thing. I think it's just again the square root trick, right?
Yep.
Okay, so we'll end
Yeah.
up with square root of x squared minus 7x plus 5. So I'm first just copying the thing, minus... I got a new keyboard, and sometimes it presses enter without me wanting to, and it really sucks. I hope that actually doesn't fuck with my exam. Oh. So we get this over... then we get the reciprocal here, and then we take... this becomes the
Minus.
squares of both, and yeah, and because we have to use a negative sign here, this becomes a positive, this becomes a positive as well. So then the x squares cancel out. This one just becomes a singular x. Let me see what I did there. Negative singular
Yeah.
x.
Negative x.
And then this one becomes plus 10.
Yes.
Okay, now. Oh yeah, I remember. So what we did is we divide by x on top and bottom.
Yeah.
So then we'll get, this becomes
-1 over 2.
minus
One.
1. This will become
Yeah.
10 over x. And then here we divide by,
X squared because we bring it into the
Yeah.
square root.
so this becomes,
So it becomes
1.
1.
This becomes 7 divided by x. This becomes 5
It's
over
gonna
x
be-
squared.
So it's -1 over 2 then?
Yeah.
Wait, and this becomes 1. This
Yeah, it is.
minus x, this becomes minus x squared. So,
You can basically skip all of
Yeah,
the-
then x to
Yeah.
infinity, 10 divided by x becomes
but,
0,
the thing
7
is,
divided by x, 0.
x goes to negative infinity. So do we then have to introduce x, like divided by x squared or divided by negative x squared? Because I've seen some talk about that and I don't quite get that.
Oh, yeah,
No,
wait. That is.
Since
Well, when
it's
x goes
1
to
over
negative
x,
infinity, it still goes to 0.
yeah, because it's 1 over x, it doesn't matter. It's 0. Either
Yeah.
plus
Yeah,
or
but-
Yeah.
minus
1
x
over
0 doesn't
infinity
matter.
is the same as 1 over minus infinity. They
In
both
this
Yeah,
go to
last
but
step,
0.
it doesn't
like,
matter if it
X
doesn't
squared
matter
over
before,
minus
though.
x squared is -1, and x squared over
Actually,
x squared is
pro tip, whenever you have x goes to minus infinity, what I do is just flip the signs of each x and say goes to infinity, and it works out. No, it does, like,
Yeah, no.
so
Yeah,
in here
it's
you would
right,
just flip
actually.
out to square root
Because
of
I
x
also don't
squared
know,
plus
really.
7x plus 5
Yeah.
minus square root of x squared plus 6x plus 5.
Yeah,
And
that
then
makes sense.
x goes to infinity, and it works out.
That makes
Okay.
sense.
But in
th-
this
then
case, it does make a
at
difference.
this point, if it wasn't like this, we would get minus 1 over 2i, which I don't think they're gonna make us answer that. So
I mean, who knows?
what?
Oh, what?
Yikes.
Well, we'll have a look. No, that's what I thought.
No.
Okay, wait. Let's use your method because you did make a good point. So if we
Is it just minus? Is it just 1 over 2?
no,
Actually?
negative. The x squared stays the same because it's
oh yeah
squared.
yeah.
Yeah.
So this
Just the
becomes-
7x, which becomes positive 7x.
And
Yeah.
6x because positive as well.
This becomes positive as well. So
Which gives the same answer anyway. We're
Yeah,
still in the first half.
Actually, let's just restart until we can fill in 0 everywhere and just speedrun it like that. No, for the people on YouTube, you just missed like an hour of substance because my software shut itself. I don't know why.
Scrub streamer.
Wait, give me a sec. Give me a second. I think I might know.
What the
Is
answer?
your are your
Okay.
keybinds?
Okay, no. For a second, I thought my keybinds do Oh damn it! I don't have a redo split. Okay, that section. I thought for a second that my undo split thing actually reset my software as well, but it didn't, and I just accidentally undid the split. So
Happens.
Invalid run.
yeah,
Big fat L.
it's already an invalid run. Actually, let me actually see because did we already split before? So I can look
We're
at the
still in the
values.
first half.
Actually, let's just restart
55,
and fill in 0 everywhere and just
54.
so let me see. Can I edit?
What? It's going
I
on.
don't think you can edit during a run.
Oh, that's so sad. Oh, it's crashing. Okay, that's so sad. All right, whatever.
We just took an hour for that one lecture now.
Let's just move on.
Yeah, now we do this next part in like 2 minutes.
Yeah.
Yeah, speedrun.
So we get 1 over 8 times x to the power 3 minus 2x squared equals to 0. So this becomes minus 1x squared when we cancel it out against this thing. X squared minus x3. Then we can take an x squared out of here. Equals to 0, or x squared equals to 0. Then we can say this is, by the way, like this, and this should be on the top there, but whatever. So then we have 1/8 x equals to 1/8. Or actually, let's do it in another way. Let's just multiply both sides by 8. So then we get x minus 1 equals to 0, x equals to 1. Woo, 99 woodcutting on my side screen. Thank you.
But hey, they say it's not 0.00, so it should be
Yeah,
1.
it should be 1, but it's not.
You done fucked up?
So how you went from an 1 over 8 x to the third minus x to the second equals 0?
Yeah, you divide it by x squared.
Yeah,
So you should get 1 plus 1.
but then how do you
over
have still
8.
an x squared?
Did you remove a 1? But
Oh wait.
I don't know why it's minus 1, but
Wait, no. Because I added this one to this one, so then we get left over one of
minus.
these.
Yeah.
Minus one of these, yeah. And then we get 1 over, like, if you take x squared out of here, we get 1 over 8.
1 over 8x
Yeah.
minus 1.
Yeah, no, yeah. So this is going to be x equals to 8. Oh my god.
And then find
how
the
do you
corresponding y
get
value.
the, why is
Well,
it x minus 1? Why
So
minus?
basically what I did is...
Oh, right. Yeah, the
Yeah.
1 over 8 needs to be compensated for.
Yeah, 1 over 8 is here, but not here. I thought it was here. as
Yeah.
well. Mistakes like this is definitely what's going to come me the exam, but now I'm trying to speedrun and not actually do right.
Yeah, but when you do it on paper, it's fine.
Yeah, that's
Because you
true.
can obviously see what's.
I don't make
y
typos
is
on
easy.
paper. Okay, and
Just
then we can
x
fill in-
divided by 2.
We can fill in x equals to 8 in this function, but that's really dumb, so I'm going to fill it in here. So we get 4.
What?
So basically, you now have an x value, namely x is 8, and you can fill it in
alright.
here, but you can also fill it in this line, because we know the answer is on this line.
Yeah.
And yeah, that's what I did.
And then the next is going to be 0, and you fill in 0, so
The
it's going to be
tensor
0.
line at the curve is vertical at this point, not 0.00. This is one where we actually have to rewrite it.
Oh.
Yes.
So
We're gonna take a
basically-
different derivative.
Yeah, you just have to plug in
Well,
a
no,
different
we can
value.
take the same derivative. We just have to rewrite it a little bit. So
Yeah,
we
that
have
also
to
works.
add 4y to both sides. we have to subtract 2x from both sides. Okay, then we get the y prime out of here. So then we end up with this. So we get y prime times this whole thing. We divide both sides by the second part. So then we get this thing. Oh, this thing.
Oh, that was my original one.
Yeah. This is a good method too. And now if you just set y prime to 0, then we see, okay, this thing has to be 0, which is what we originally had. However, for this time we have a vertical asymptote, and a vertical asymptote, or sorry, not a vertical asymptote. It has to be infinity, because or at least tend towards infinity. So the line will go up infinitely fast.
So we need to divide by 0.
Yeah, so we need this thing to be 0.
Oh, and by the other one, you had to be 0 over.
Yeah, the top one had to be 0, and the bottom not, and then this one had to be 0.
Right, because that was horizontal, horizontal or not.
Yeah, so then we get 3y squared equals to 4x. So then we get y squared, or what do we want to do?
Let's just take the other one.
Yeah, let's just say x equals to 4 times y squared. Then fill this in everywhere where we get x here. Are not there in the
original formula.
So then we get, let me just copy the original function real quick.
Nice percentage.
Minus, yeah, thank you. Fire xy equals 0. And we fill in this for x everywhere. So then we get this. Well, these two cancel out. I see that already. And this is multiplied by y anyway, so this becomes y to the third. And this, well, we square both of these things, so this becomes y to the fourth. This becomes 9 over 16.
Yes.
Okay. And
minus
then we get
2y.
This, well, this becomes minus. This plus thing gets rid of one of these. Thick. Then we can get y to the power. Oh, y to
You
the
can
power
straight up
3
remove
out
it
of here.
because we know that it's not the point 0, 0.
What did you say?
We know it's not the
remove
point.
the y to the third because we know it's not 0
Yeah.
since it's not the point 0, 0.
Because they here explicitly say, hey, it's not the point 0, 0, so we can get rid of that one. So we say, okay, this is equal to 2. And then we get y is equal to 2 divided by 9 over 16. Which is,
32
wait,
over
this
9.
is the y value? So then we
Yes.
say,
Yeah, we need to plug it
say
back
2
in
divided
the...
by 9 divided by 16. Correct.
Oh, that's the laziest way. Come on.
Like, of course, we know that divided
But
by
it's
fraction
right.
is the
Wait,
same
I want to
as-
see something. Does the answer of the other one also mention the x value? Like scroll a bit further down. Does it have an explanation for the x value?
What do you mean for the x value?
No, it doesn't.
Oh, okay.
No, it does.
Wait, it does say x
the last one
equals,
says x
but we already
equals
had that. Okay.
Wait, so you don't split this one up in the two sections?
I was gonna say maybe it mentions the x value as well, so
No,
we don't
just
even
have
need to
to plug it.
calculate it.
Yeah.
Ultimate
What's here
laziness.
is correct indeed. Like we got to the point of x equals to 3, 4 y squared. That's what they have here. And we just fill that in. But now we just have to fill this into the original formula. So this becomes times
This is gonna become a mess.
squared. No,
Yeah.
not really, because we can just say 3 over 4
Yeah.
times,
Yeah.
Let grasple do the
32,
dirty work.
3 times 32 times 32 over this times 9 times 9.
That works.
Hey, let's go, boys.
With grasple.
So you don't split this one up in the two things? Because with the x one, you made like two equations.
You mean
This
for
one you
this?
only got one.
Well, yeah,
Yeah.
we can say or y to the power 3 equals 0, but people were like screaming at me that we already know that y will not be 0 because it's set so in the formula, so I just left that one out. But yeah, we do split this one off and we just say not applicable.
So the only thing you have left is 9 over 32 times y minus 1 equals 0, and then
Yeah, and then you just like
yeah, and then y equals 1 minus 932.
yeah, but you get this.
By the way, quick
Yeah.
question: when will we have a lunch break?
I was thinking after the end of this lecture.
So you have 23 over 32. And right?
Well, our thing is 32 over 9. So you made a calculation error somewhere because ours was correct.
Fair.
The function of the tangent line to this thing at point this thing is defined as this thing. Yeah.
Amazing.
Beautiful.
Yeah,
and so the answer is this thing, right?
Yeah.
Right. No, it's that thing.
Well, the thing is, we can choose to like write this out. It will make it easier, but it will also make it a lot harder. So I'm not gonna. Let me just eat.
Isn't it just you put a 2 in front of it and then it's 18x
times
plus like
this thing, and then times the derivative of the inside. 4y squared minus 9x times, oh god,
18x.
Yeah, so that's 18x
plus 8y.
4y, or 8y prime minus
9.
9. And then we also, because I didn't realize we were already gonna be differentiating, so I have to do this one. It's gonna be 2x.
Can ask how did you differentiate only one part? Nothing.
Didn't sound like nothing.
Okay. I like
Put in some values.
And now we know what's
now we know
y1,
that, like,
y prime.
x is equals to 0, so yeet. Okay. And we know y is equal to 1/4, so this becomes 1/2. This becomes 1/16 times 4 is 1/4. This becomes 2.
Yeah, that's about it.
That's about it, yep. So this one cancels out to become 1/2. We can multiply both sides by 2. We can add y to this side, or subtract y prime from both sides, and add 9.
Wait.
Yeah.
How do we get a constant derivative for this?
Well, because we already filled in the point. The derivative is based on
Yeah,
the value
yeah,
of x
yeah,
and y, and we just filled in x and y. And I'll see if it's correct. Let's go.
Yeah, nice. Let's go.
No.
Wait. Oh, that was an easy one.
Oh look, the superior notation is there.
The beautiful superior
I mean, it is
notation.
the superior.
Okay, so
it's
they
the
say y
reason
prime is equal
England
to
was set behind.
X to the power 4 plus y to the power 8 is equal to 1. Well, then we first take the quarter root of... No, of course not. We get 4x squared plus 8 y times y prime equals 1.
X
So then we
8
get
y to
y
the
prime
7.
is 1 over 4x to the power of 3 plus 8y.
To the power of 7.
Oh yeah.
Thank you. I knew I forgot something.
I have minus 4x to the power of 3 divided by 8y to the power of 7.
Why is it 1? So.
Actually, yeah, it's not 1. That becomes a 0.
Do you not still
The derivative of 1 is 0.
Do you not have to move the 4x to the right side first?
Wait.
Yeah, it's minus, right?
I see.
So the first part is
yeah,
the
no,
1.
I messed up indeed.
I thought
Because I thought there was a y prime at this one as well, but there's not. So
that one needs to move, and then
we indeed have to move this one first, and then
becomes the top part.
Yeah, and then divide by this. Not divide by that. Divide by this.
Right.
Let's move.
And want to know another fun thing, by the way? Because like when I copy this, it doesn't work, but when I use the notation of LaTeX, I can just literally copy this. Oh, but I'm not using this thing because some of you guys probably are not comfortable reading LaTeX.
I think this looks better.
Like this, better than the other one?
Yeah, because
Yeah.
you might not make the 1 over 8 times x minus 1 mistake if it's clearly shown by brackets.
That's true.
I find
Linear approximations.
the most annoying thing I find is the
I have a break.
the squares.
How long is the break gonna be?
How long do you guys want it to be?
Enough for people to make lunch if they're cooking.
I
They're
guess
cooking.
They're cooking.
What are they gonna cook? Are you gonna...
hour.
I mean, I'm not gonna make something incredible, but like I have to make sandwiches, for example.
That's not cooking.
That's
Look,
not-
for
that's like-
sandwiches, it's like 15 minutes.
15 minutes. That's like five. That's
Not
like 5
50
seconds.
minutes. But like,
Speedrun
okay,
it.
but that's the most basic thing.
Speedrun it. Yeah.
Just do it while you're learning,
I'd
bro.
say like half an hour or
20%.
three-quarters of an hour.
Yeah, just stream
What?
stream Discord on your phone and just watch the lecture while cooking.
Make it and then
Just
eat it.
put the
Guys,
iron next to your computer and just put the sandwich in.
Guys, you guys can go ahead and speed run lunch. I say we come back in half an hour.
Half an
half-
hour?
That's
Down for
reasonable.
that.
I was like thinking like 10 minutes. Alright.
Yeah, no,
I'm
like,
gonna-
people are complaining
mean,
that they want to make it.
Whoever's
3-4
ready
fucking
before
meal.
I
that,
mean-
you can just stay here and discuss
Listen.
stuff.
Listen, I say
the time.
24. 24.
Yeah, 24 minutes. Then we're done at half past.
Alright,
I'm gonna play some Rocket
13:30
League.
we're here.
Okay.
Let me be indecisive, okay?
All right, we're starting again. Where's my?
I know that the
timer? There we
grasple
go.
from lecture 10 is
Uh,
absolutely worthless. So.
And continue. Okay. So lecture 5: linearization and differentials.
Nice.
So the let's see, linearization is not that hard. It's just like
You have to do the
create
equation.
create the line and fill it in.
What's the formula again? Was it like
It's
derivative of f plus
f of a minus derivative of f of a minus derivative of f of x.
is fa? Is that
I think
just
it
the
was
x
this.
value?
It was just like the tangent line or something, right? Actually. But
Wait, what? I
Wait,
think it
wait,
was
wait.
Like this, right?
yeah. Yeah, I think
So what is a in this case?
A is the value that you want to be close to. So in
But
this,
wait,
in
wasn't-
this case it's 9.
yeah, in this case it will be 9.
So the derivative was also a or not? I don't remember actually, but
Well,
So
X,
it'll be
is,
the
X
R.
is the thing we're going to be filling in.
So it's
So
r
this is gonna be
tangent
the
9.
value, and then we're gonna have the derivative of the thing times a 9 minus the value.
So it's
Okay.
going to be arctangent 9 plus 1 over 1 plus x squared then? Well, you don't know that yet, but
Well, I don't know.
Let's fill it in.
We'll see.
I don't know.
So first of all, let's get the derivative. The derivative of the arctangent is 1 over
1
I think
plus
it's
x
1
squared?
plus x squared.
Yeah, it is.
By the way, are you guys like? What do you guys prefer? Because I really don't care. Do you guys prefer like this notation, or do you guys prefer like this notation?
I don't really
I don't
mind.
care
I mean,
either.
the fraction one is
I searched it up. I
don't
think
really care.
the f like derivative of f of x is like fa. So
So it should be f of the derivative of f of a.
yeah. So
Yeah, that makes more sense.
Yeah.
Okay, cool.
So then
I'll
this
use this one then
becomes...
because this is like I can
So-
just paste this in and it will be correct. So I don't
Yeah,
have to
just do that one.
Okay, so we have what is the arctangent of 9?
Do we have to know that?
We need to know f of a.
Yeah, but I think we could just fill in arctangent 9.
Yeah, okay, that's true. So we can say f of x is equal
I
to
don't- I'm not a calculator,
arctangent
so...
of 9 plus well
1 over
so we have,
82?
1 over 1 plus 9 squared.
Yeah, it says 82 then.
So 1 over 83.
Wait.
And then
No, but 9 times 9 is 81,
82,
right?
82. Excuse
Yeah.
me. Yeah. So then we have this times let's see. So that is a minus x. So that's 9 minus x.
You lost the plus sign.
Yep. So plus sign here. And now my question is, if I just like literally copy paste this, does it work?
So we'll
It
see.
should. Oh fuck yeah! Even just the c dot. That's sick. So this should be correct. Let's see if it is. Wait, isn't it x minus 9?
That was in the other ones. I don't know if it's the same. That was for the
yeah,
the
it's
last
x minus
lecture.
9.
Yeah, okay, because like here,
Yeah,
if we fill in a positive number, it will become negative.
So it's x minus a. Yeah.
Yeah.
Alright.
So here we have x minus 9. Okay. Let me fill that in here as well.
Way
Dude, let's go.
easy. Look, even they didn't get rid of the arctangent.
Yeah.
They're like, nah, fuck that.
Okay, so the differential of something. So let's see. If we have something like this, f
It's just
of x,
derivative, right? Or
we
no?
have dy over dx is equal to, unfortunately, I'm gonna have to use this, is equal to like the derivative of this. So di is equal to the derivative of this times dx.
So that's in this case?
And this is just always.
Yeah.
Because the
That's
derivative
always.
of a function is equal to the derivative of y
Yeah.
with respect to x.
Right.
And we can just multiply both sides by dx.
So this is, but the question is, did you just calculate the derivative of this
Oh
thing?
yeah, I guess so. I guess in this case it would be minus 2e to the power minus 2 times
2x.
sine of 2x plus...
It's to the power minus 2x.
Hmm?
It's
Oh, minus
e
2x,
to the
yeah.
power 2x. Yeah.
Plus the
Sorry.
cosine of 2 times the cosine of 2x times e to the power of minus 2x. And then all of that times dx.
Do you have to put the dx then?
I think so.
Yeah, you have to do that.
And
So when you know you have to do, when you have to, what's it called, when you have to put the dx in or not? Is that just because
Well, that is the differential, so.
Yeah, but that's different than the derivative then, I guess.
Yeah. The differential and derivative are two different things, because like the differential is like the dy, and the derivative is dy over dx.
So the only difference is that the dx just comes to the right.
Yeah, you just multiply by dx. At least I think. Let's see.
So I wonder if it's wrong if you don't put it there.
Hmm?
It'll probably be wrong if you don't put it there.
Yeah,
then I imagine.
Yeah, probably. Yeah.
Right.
Yeah.
That's where I'm gonna
It's
lose
a different
points.
thing because you don't multiply by dx. It's just a different value.
Yeah, but that means you instantly have 0 points. I imagine.
Yeah, basically.
That's rough, dude.
It is rough.
You can't get points for calculation, which is horrible.
Yeah.
Yeah.
Okay, so
one slip up, one minus wrong, and just.
Yeah, it's probably the same as like for getting C with integrals. It's just something you need to remember.
Yeah, you just have to get it through your skull. Okay, so let's see.
I have-
F of x is equal to the arctangent of 1 plus 1 over, or let's see, 1 over 1 plus 1/16. Let's see, and then times x minus
1/4.
1/4. Oh.
So that is. Yeah, you could probably fill that in.
Yeah, and I also need to change this. I didn't think we would already be filling it in, but we are. Copy, paste.
Oh, you got an arctang too many, I think. Oh, never mind. It was just in the second line. No, it was in the second line.
Okay. I think this is correct. Let's see.
Nope.
Where does the arctan 1 come from?
Arctangent of x at x equals to 1/4.
Oh yeah, of course. Oh, stupid. Okay.
And then wait, the derivative of 4x, isn't that? Do you need to do the 1/16 times 4?
Yeah.
Yeah, that's a good one. So in this case, we would take this to a 4. Wait,
No, look at the bottom as well, because it's gonna be 1 divided by 4x squared, so it's gonna be 16x squared, right? So it's gonna be 16 times 1/4 squared, which is gonna be 1.
Yeah.
So it's gonna be 2.
Okay, yeah, that makes okay. There we go.
Okay.
Okay. Still a little bit rusty,
It happened.
Okay, so then we have the square root of
13 minus x,
yeah,
boy.
13 minus x, that's like 3.
1 over, it's gonna be 1 over, yeah, it's gonna be the simple one.
Well, in this case, it's gonna be negative, because the negative...
It's gonna be times minus 1, not good one.
Yeah, and then we have 2 times the square
Well, there will go my points. You have to fill in 4.
Times x minus 4.
Correct?
Yeah, seems like it would be correct.
So.
Yeah. Oh.
For fuck's sake. Why do
why is this? If you fill in 4 in 9 is 3 is 1 over 6. Should be Oh, you need to fill in the x, right? In the bottom.
yeah,
That
we need to
becomes
fill in the x
4.
here.
Yeah, so it's going to be 1/6.
Yeah.
Yes.
Okay, yeah, that makes a lot more sense. I keep forgetting that you only have to have one, what's it called? One x in the thing.
Yeah.
Okay, that's a good thing to remember.
That's the difference of FA and
Yeah.
X to the 5th. Oh, great. I'm just going to fill that in as 4 to the power of 5. I'm fucking lazy.
So this is...
This is a pretty easy one, though.
No, this 5 times 4 to... Wait, this is not correct, by the way. This is 1024. And then we get 5 times x to the power of 4. So that is 5 times 2, like this. And then times x minus 4.
Yeah.
And I guess we don't really need to do any more simplification.
So it's going to be 2048 right then. No, wait, no. This is times 5. No, it's fine, it's fine.
Let's go.
Yep.
Dogs.
Oh,
this is always fun.
Oh yeah, no, but this is just like the square root of 64, that's 8, plus 1/2 times the square root of 64 is equal to, well, 1/2 times 8 is 1/16. Let's use fragmentation. 1/16 times x minus 4 over x minus 8.
Is it then times 0.4?
Hmm?
It's gonna, the right side's gonna, the x minus 8, that's gonna become the 0.4. Because you have to like, right, it's something like that, because you have to like compensate for the difference. The x minus 8 should be 0.4, I think.
Oh, wait.
Oh yeah, now you have to fill it in.
Yeah, because
wait, so
yeah, because you have to, because obviously you have to count back.
Yeah, so this is, and then
and because it's larger, you might do minus, but I could be wrong about that.
No, I don't think so. So then we get minus 0.4. So then we get.
Oh, because that becomes minus. Yeah, right. Then that's fine.
Yeah. Dude, let's go. We are such a good team, and I'm so gonna fuck everything up when I don't have you guys.
Dude, same.
Everyone.
Wait, is like lecture 3? You took like an hour on that. Is it really hard, or was it because you had like?
I messed up my split, so I accidentally unsplit and then resplit.
Yeah, okay. I was really confused because I was like, "Oh shit, do I really need to spend a lot of time on that?"
Dude, it's wait, where have you not done lecture 2 yet?
Oh no, I did, but I didn't remember like what we did, so I thought.
I think it was with the tension and stuff, right? Like calculate like sine the arc tension and like.
Yeah, I'm still really bad at that, but I'm just gonna improvise.
There's like this. There's like this. If you just learn the formulas, it's super easy. There's like a very nice picture right here. It's a very nice picture. Like all the.
But actually, I didn't remember all this stuff. Like, I should actually like revisit this.
Yeah. Like, look, if you just.
Okay. Wait, if I go back to lessons, so we just did linearization and bulk split. Okay, so what's next? Next is
L'hôpital.
We
had a red one on 7.
We've been using it several times already.
Yeah, this one should be a speed run.
Yeah.
Is the recording still running?
Yep. Okay, so.
Wait.
Does this become infinity over infinity?
I mean,
yeah, that's the
it's
problem.
that's
the whole point, you know.
Yeah.
But like, they might try to trick us and just put something in that doesn't.
Nah. That's a problem for
me.
me.
Everything by x to the power 5. That seems like a lot easier. Yeah,
Well, the bottom, so the bottom one is gonna be infinite minus like basically 0, because it's gonna shrink.
Infinity and then over.
And then the top one is the same one, and it's gonna be plus 0, so it's gonna be infinity over infinity.
Yeah, exactly. So that's good. Then we let me actually grab this real quick. Technically, since we're just doing this now, I can also just do this. Might be a little bit easier. Because now I can actually, like, you guys can see what I'm writing. So I can say, okay, the fraction.
Although, because if it's the power 1 to 5, it's gonna become very small as well, isn't it? Oh, but if you take a really big number, it's still gonna be really big.
Yeah, exactly.
Yeah.
So
it's gonna be infinite anyway. So
plus, x to the power minus 1 times x minus x to the power of minus.
So I kind of forgot what you have to do here. You have to like get rid of the 1 to the 5, right?
Yeah, what I did here is I multiplied both the top and the bottom by x to the power of 5.
Yeah. That's what you get. Yeah.
Yeah.
You get x to the power 1 plus x to the power minus 1.
Wait, can I do that? X to the power 1/5 times x to the power
5.
I believe you should do it times x to the power minus 1/5.
No,
that way you make it x to the power 0 minus something else, and then you can figure it out.
Isn't it then going to be 1 over 25?
Oh wait, no. I was thinking of what if
Why don't we just slap L'Hôpitals though?
Yeah, well,
if you do it right now, I believe you just simply create an infinite loop where like the one becomes infinite and then the other one doesn't.
You know what? Let's see. Let's see if we get. Let's just fucking pull L'Hôpital out of our ass. Let's see how it goes.
I mean, it's not really out of our ass because that's literally the topic right here.
Shut
up. True, but that is what I'm gonna do on the test.
Frac of. Wait. So this is minus.
The only thing I hate about the grasple exercise is sometimes I'm just like, what the fuck do you want from me?
And then.
Like, I gotta remember what notation they're asking for, rather than how to actually compute it.
And this is the first thing minus the second thing. Enter. Okay. So this is what we have. Then we use L'Hôpital. So this becomes.
This is such a mess. That one line is just.
This becomes the fraction of 1/5.
Oh my god.
And then this becomes this minus 1. So that's minus 4 over 5.
What
right?
did you create?
My
god. I don't fully remember the L'Hôpital anymore. But...
Then. Oh wait, why is it not? Why is this not creating a new line then?
It is. It's just next to it.
Wait. Does this work then? Yeah. Okay. So this is not what I wanted. Oh yeah. So this is gonna be the fraction of 1 over 5 times. Yeah, this should be correct, right?
Why is it gonna be times minus 4 to the power minus 4 5? First of all, why is it gonna be minus?
Well, we're subtracting 1 from this power, right?
Well, I don't know.
Well,
yeah.
We're differentiating.
Oh yeah, we are. Yeah, now I remember.
Men casually forget differentiation.
Hey man, it is what
Listen, it happens, all right.
Don't worry.
It happens to the best of them, and also to me.
And then
doesn't this simply end up in 0 divided by 0?
That's the whole point, and that we should prevent it, right?
Well,
yeah, but I mean,
I don't think this is gonna help us.
No, that's what I mean. I mean,
So the answer is just
what
one.
The result of this like simplification is again 0 divided by 0.
So
you
it's
can really just divide by the greatest power, guys. It's
what I think the answer is 1, because if you multiply it by like x to the power minus 1 divided by 5,
yeah.
you'll get x to the power 0 on the first line, which will be 1, plus x to the power minus 2/5, and that way that will become 0. You do that on the second line as well, you get 1 plus 0 divided by 1 minus 0.
That's true.
Which
we can
equals
add
1.
powers of x to everything. So if you just add 1/5, like
to
every
this
power.
is RuneLite.
X to the power 1/5.
Yeah. So in that would this
minus 1/5.
I mean, we can add it or. Yeah,
we can add it or subtract it. Doesn't really matter.
Yeah, it doesn't matter.
X to the power 0.
Oh yeah, of course.
Yeah, it depends on what he wants.
Yeah, no, you're right.
This becomes x to the power.
Show us the way.
Okay.
And then the bottom one also becomes
Yeah. Sometimes it takes a while for.
No, wait. It does matter, right? Because you get x to the power 2/5, which will become infinite again.
Yeah, but now we just have x to the power 2/5 plus 1 and minus 1.
Yeah, this is gonna be this is 1, right? Then.
Minus.
Yeah, but now you get infinite plus 1 divided by.
Yeah, well, then we can L'Hôpital again. Oh. I deleted something a little too much.
Yeah, but it's the same. The bottom and the top is the same, so it just automatically becomes 1.
Well, not really.
No,
Right.
you can.
We
The
never
infinite
said that.
divided by infinite.
Oh, it's minus. No, the bottom is minus. Never mind.
So it's minus 1.
So
Think
it's just
we
like
get the
no
second
you.
the second term to be constant, so when we loop it out, it just disappears.
Oh yeah.
And we get a 1 in the end.
Wow, these sound really...
Oh
You
yeah.
can
All right.
technically just substitute here x to the power of 2 over 5 to be y, and you get
we can do
y
that.
plus a constant over y minus a constant, which is 1.
We can do that. Set x to the power 1, or x to the power 1 over 5 is equal to u. So then we will get... so
Wait, you can do that?
as
What?
long as your limit stays the same. But x to the power...
No, I meant the latex.
yeah, you can do inline latex. So you have like two types of... so wait, these are both... Yeah, they're both the same. You have two types of like things. You can have like the inline latex, and you can have the like block latex, which stays in the middle. But I prefer the formatting of this one, so I usually use this one.
Yeah.
However, when I'm just writing a proof and I want to use latex like this inside of a line, I use the single one.
Can't you just take the derivative of x power to 5? Why do you have to put it into u?
You don't have to.
You guys are making it so.
It's just a standard limit when you look at it like this.
Okay, which limit is it then?
It's 1.
Yeah, but if you just use the L'Hopital's rule, then the 1 goes away, and then you can just then it's just 1 because x to the power of 2 divided by 5 divided by x to the power of 2. Yeah, that's just 1.
It's gonna be the same thing.
Let's go.
Yeah. So basically, it's just 1. Yeah.
Oh, I see what they did. They yeah, because when this
that's
negative power. Yeah, that's what you said.
Yeah, I mean. Like it's one line of rule. One line of like.
So why does that become that becomes a negative power because
that becomes 0. It doesn't become
1
infinite.
divided by infinity is 0. So
yeah, like they use L'Hopital here, but that's not explicitly necessary. Because we could have just multiplied everything by x to the power of minus 1/5 instead of 1/5, and then we
minus 1/5. But that's exactly what they're doing.
I see they divide by that, and then
they use L'Hopital, but we could have just multiplied, which basically gets the same effect. Anyways.
Gosh.
Okay. So when this goes to 0, we get 0 over 0, so we're allowed to use L'Hopital. So we have the fraction of e to the power of 2t. 2t.
God.
2t.
Dude, we are so grown up. You have no
idea. Yeah.
Yes.
We are the future of society.
Dude, don't say that. That makes me depressed.
You mean?
Okay, so then we take this.
I still no clue about like what study you do. Like, are you in the same year as us?
Me?
Yeah.
Yeah, totally. I'm just first year as well.
I don't know if you're shitting with me or not.
No, I'm genuinely first year.
Oh.
Yeah, he's just a genius.
Yeah, but do you have just a lot of free time or something? Like, I don't know. You give me more help than some teachers do, so I mean.
Yeah, okay.
He succeeded in finding like.
I don't know how in your brain went just like, yes, I'm gonna take on the role of a teacher as a student myself.
Yeah, that's like.
And people will just believe that I have everything right, but then it turns out that I also have everything right. So
I'm gonna be honest. I'm pretty stupid. I do not know that much. But when I'm in a chat with 20 people and I make a mistake, people will be like, "Hey," and I'm like, "Hey." So it looks like I'm very smart. I'm not really, but people correct me, and that makes me look very smart.
Also, I wasn't paying attention. You went from you just took the
yeah, I just
you just took the derivative. Yeah.
Oh. I just filled 0 here, so that becomes yeah.
Can't you, by the way, just already disregard the -1 because it's on both ends? Like it's the top one is minus 1.
You cannot just add something on both sides. You have to either multiply or divide.
No, but can't you just say that the -1 doesn't add much anyway?
You can't. You can if you know that L'Hopital gives you that information, but just by looking at it, you can't.
Okay. Evaluate the limit. Well, this is going to be.
All right, let's go for it.
0. That is 0. So this is. Oh yeah, okay, because there's 3x. Never mind. Makes sense. was about to say, wait, can we just not fill this in? But we cannot. So we have 3x plus 9 sine of 4x plus, and this is 8x plus 4 sine of 9x. I love LaTeX so much because it looks like you're writing a masterpiece and it's only like 3 or 4 or 5 or 6 times as many keystrokes. Totally worth it. So L'Hopital on both sides gives, L'Hopital gives 3 here. This sine becomes a cosine and we multiply by 4.
And then
So that's
then
36. So this becomes 8, sine becomes a cosine, and we multiply by 4. So that is 36 as well. Wait, yeah, okay.
What did you have?
Recompile, yeah. So this should be
Wait,
correct.
what?
Fill it in probably. So
It's
now we can just fill it
36.
in.
It's 36
No, wait,
cosine.
why is it
Oh yeah,
46?
that's a typo.
Yeah.
Excuse me.
I like how every time you make a typo, you delete it and do the same typo.
Shut up. So the cosine of 0 is 1. So we can just fill it in at this point.
Yeah, just remove them and
And we
GG.
get this, and we can
39.
Oh no!
How fast are you?
No, my keyboard sometimes either presses enter too fast or presses, like when I paste something, it pastes twice, which is really annoying.
Yeah, okay then, okay. It's a
Now I'm
mislead.
curious, because this looks something like I could do.
I mean,
we could do without
like, if
L'Hopital.
it's really a problem like that, you should be careful in the actual exam.
Yeah, no, I really should.
Yeah, wait, can't you take the bottom one and put it like x squared minus 4 times x squared plus 4?
Like this is x, let me rewrite this as x squared minus 4 squared over x squared.
I mean, it's the same speed pretty much. L'Hopital and this. Maybe L'Hopital is even faster.
X squared plus 4. Because the difference of 2 squares, we can divide out this one.
What the fuck are you all doing? I just took a derivative and it just.
We are lazy. We don't take.
No, I'm lazy. That took me one line at the answer.
No, the derivative is a bit faster here.
It probably could have been, but this is.
Oh wait, I am cheating. I'm cheating because I need to apply the not mintanregel. I don't know what the English name is.
Not mintanregel.
No. Yeah, I just did 4 times x to the third divided by 2x, and then you came out at 8. Oh wait, it's correct. It is 8. Yeah, you guys they made it way harder.
Well,
we did it in the normal way. What you probably did is L'Hopital rule. We don't even use that here.
Yeah, no, L'Hopital is not really needed.
But it made it easier because I had to do less calculation.
The thing with limits is L'Hopital is just too broken, so you either substitute and it solves, or you just slap L'Hopital until it works.
You slap it on there.
That's a
just
sure way algorithm for solving
Up in the
them.
morning. Wait, no,
Yeah, that's the
not it.
same as before.
Oh, copyright.
Okay, so looking at this.
It's the same idea as before.
Yeah.
You just double one of the powers and the other becomes a 1.
Minus e to the power of minus 6.
X. Yeah.
X.
Yeah, minus 6x, excuse me. So then
X,
we'll get
and we
e
get
to the
the
power
stuff.
minus 6 plus x, so e to the power 0 is 1 plus e to the power of minus 12x, and then at the bottom is 1 minus e to the power of minus 12x.
Stonks.
And those two will approach 0 as x approaches infinity, so we'll get 1 over 1. Every time I say something really confidently like that, I secretly hope that it's wrong.
Why do you hope it's wrong?
Well, not hope, but I'm like, oh, and fuck.
You just get no youth.
Yeah. Evaluate the limit. The tangent of. Ooh. Okay, so there's two easy definitions of the limit of the tangent. So we have 1 plus cosine squared of x and 1 divided by cosine squared of x. I think.
I know the 1 divided by cosine squared, and I know there's another one, but I don't know if it's 1 plus cosine.
Okay, what is the question? What's the question?
We need to
The other
evaluate
one
the
should
limit
be.
of 2x over tangent of 7x.
I don't fucking know.
Yeah.
But the tangent of 0 becomes 0, isn't it?
0 over
So
0.
this is 0 over 0.
It's not-
Yeah,
okay,
definitely,
let's
because
just
if you
do-
put it on a
let's do it that way.
circle,
So
it's
the
gonna be
tangent
0.
of
Yeah, the 1 over cosine squared is better. The other one is 1 over 1 minus sine squared. which requires us to use L'Hopital again.
Yeah, so
Sounds
we'll need
depressed.
that one. So we'll have 2 divided by cosine of...
Oh, this
I
is gonna
mean,
be 8.
you can just swap them. It's less writing.
Hmm?
You can just swap the places of the tangents before you derivate them.
What do you mean swap the places?
Well, it becomes 1 over cosine. So you just they change places like the I don't know how to explain this.
Oh wait, I think you mean like... So this becomes 7
Yeah,
times
it goes to the second fraction
And
part
this
of the fraction.
cosine of 7x. And then this fraction becomes 1.
This is gonna be like a half divided by a 7th.
Wait, so let me get rid of this fraction then. Okay. So this
It's
is
gonna be
correct.
wait. No, because
Yeah, this
it,
is what I
the
meant.
derivative.
We
The
divide
derivative
by a
should still be
fraction.
times 2, right?
Hmm?
It should still go times 2, shouldn't it?
What do you mean?
Oh, you already did that. No, never mind.
Yeah.
I was like,
We already
is that-
did the thing.
oh boy. And shouldn't it be the? Well, I mean, doesn't matter.
Yeah, okay, so then... Oh wait, it's 0.
Cosines are 1.
I don't know what the word is. Because it's 1 over squared cosine is. But I think that makes a difference, doesn't it?
That's a good point.
Oh, but it doesn't make a
However,
difference.
cosine squared of x still becomes
1.
1, so
Mm.
it doesn't really matter.
Yeah, in this with x near going to 0, it doesn't matter.
Yeah, but
It's
it's a really
1
good point
squared.
because otherwise, like, I wouldn't notice in the test. There's probably somebody who guessed this and was like really happy.
Just remember, whenever you have limit of tangents divided by tangent, just do the factor of x divided by the factor of x.
Guys, we got green.
New split.
Let's go.
You got a red one on that one. Ooh.
Shut up.
Oh no. I thought you said that one was kind of 8.
Hey, finally some fun stuff.
Finally, some good fucking food. Okay, so we have...
Hey, look. It's the
1/6
derivative
times
of the tangent.
Yeah, but we have to keep...
Wow.
Yeah, it is.
Yeah, we have to keep in
So
mind...
it's 1/6 tangent. It's a 6th tangent.
Yeah,
so we have
1/6 the
fraction
time.
of the tangent of 6x divided by... Or,
6.
Yeah, divided by 6.
Okay, that was the luckiest draw of a question ever.
Yeah, just back to back. Oh yeah, I need to use brackets here, not these. And then we have to fill that in at 6, and then at... Is the tangent of 0, 0?
Yeah. I think so.
Yeah.
I have a list.
No. The tangent of...
Yeah, the
Wait,
tangent
no.
of
The
0,
tangent of
0.
0, 0, my bad. Yeah.
Okay,
What's the tangent
so
of a half?
what we will get...
Yeah, pi over 2 is undefined.
So that's undefined. It is, right. I was like, I had like just nothing, and I was like, wait.
So what we will end up getting is... so this should be backslash. So this is what we have to fill in, or technically it will be plus c, but because we're going to fill it in, it's not required. So we're
it's
going to
gonna be
this
60.
minus this, and in this case, this is
0.
0, and this is 60.
So the answer is, yeah.
Yeah. So the right part ends up being 0, so we can get rid of this.
Some bracket is not correct.
Hmm?
Oh, never mind it. The rendering on the right side was bugging.
Ah, yeah. Let's go, boy.
Hey.
Poggers.
So good at this. Exam time.
Ooh. Okay, but this would just be the...
That's gonna...
Yeah, it's just the thing.
Like determine the...
Sine is
4. Oh,
four.
so it's just normal derivative.
And these are the easy ones, right? Because you can just do it, like you would calculate the derivative with backwards. Because you don't have to use the substitution rule here and stuff.
Yeah.
Yeah, so you can
It's
just...
basic stuff, but...
So it's just a 4 of x4 times sine is 4x5, and then plus... I fucking know.
Wait, but isn't this just derivating an integral, which is just what's inside?
Do you even need to take a derivative?
No, but
because there's already the x you could.
It's
You need to take the
derivating the integral, so it just cancels out. No.
Yeah. I'm pretty sure it's just literally that.
Yeah, but you have an interval here.
Yeah, but
I'm not sure if this, like, because they have an integral sign here, this might already equate to what comes out of the integral.
Yeah.
Even if you take it like that, the minus part is
Whoa.
0, since it's sine of 0. Yeah.
Wait, so the answer is just you
Yeah,
fill
it is. It is just derivating the integral.
What a difficult question.
Wait, huh?
I mean, it is basic integration. That's the name of the topic. You do realize that.
Yeah, so we have this function, then we integrate that, and then we differentiate the integration, and that just comes back to the original function.
But if it wasn't 0 to t, then
Yeah, no, if it wasn't 0 to t, then I wouldn't have filled in t here. But then I would have filled in t here, and then minus, and then maybe like whatever 2 to the power 3 times sine of 4 to whatever.
I mean, yeah, because f of 0 is 0, so yeah, that's true.
Yeah.
But it was
Yeah,
not 0
the
there.
reason why I
Yeah.
left it out is because x to the power 3 is 0. So.
Why doesn't it become a cosine or something?
I'm really not sure that it even matters.
Well,
I'm so confused.
basically,
Why can't you
what
just
we
say
have
fuck
here
that shit?
is we have a function, then we take the integral of that, and then we take the derivative of that. So we just get the original function.
Yeah, the what was it?
Oh, they're asking the derivative of the. Well,
It's
I don't know
the fundamental theorem of calculus.
Oh wow! So that's basically just read the question correctly, or you're fucked.
Yeah, exactly.
Yeah.
That's dirty.
Yeah, it is definitely.
All right.
And then next time they will do that, but the dx won't be there. So what's next to the integral is already the primitive. So you still need to take the derivative, and then you get fucked over if you don't see the.
Oh, without the dx, you don't have to take the what?
If the dx is still there, that means that they haven't taken the primitive yet.
The primitive, that's the word.
Yeah, or the antiderivative is also fine.
Yeah.
Okay, so we have the
Antiderivative, bruh.
This.
1 over.
Let me first write it out because I need to practice on writing out integrals. So this is t plus 1, and from t of the fraction of 1 over. Whoever said, yeah, no, I'm not gonna do for that's x. I'm not gonna do LaTeX because it's too time consuming. Yeah, suck my dick. I love LaTeX, man, for real. Like, I can just type this. That's so cool. So the first thing I'm gonna do is I'm gonna get the fraction 1 over 4 out of the integral. So then we'll end up with fraction 1 over 4 times the integral from.
By the way, you can try pressing, I think it's Control Shift and down arrow to copy a line. Don't know if it works in this editor.
if the 2 is still there, then it would be easier, right?
Control Shift down arrow does nothing more than this.
I think maybe Control D works. I don't know. There are commands in most editors for copying a line.
You already said this is ln logarithm of square root of x.
Isn't it gonna be 2 times?
Well, I think at this point it's
I don't think it's
this
over.
is just equal to
Yeah. Logarithm of square root of x.
But it's no, it shouldn't be logarithm because it's
Why?
x to the power of -1/2.
Yeah.
Yeah, I was about to say.
It's gonna be
-1/2. Yeah, no,
it's gonna be 2 times
1/2.
x.
Yeah.
Yeah.
2x to the power 1/2.
Of 2 square root x.
Yeah. And we do.
When you
need to remember that we
when
need to
you
fill this in, but then we get indeed. So this is gonna be this plus 1, and then times the reciprocal of 1 over 2. So that is 2 times the square root of x.
It's gonna be.
I mean, if we do take the log instead, like, would that still work or no?
The log?
No.
Well, the log not, because in for the log to work, it has to just be 1 over x.
It has to be
and
to the
only
power
way
of
to get
-1.
is to
Yeah.
u substitution.
I
but
see.
that won't work.
I see. Okay.
Now you just fill in t plus 1 and t, or is this already the answer?
Yeah, no, you fill in t plus 1 and t. So
Right.
yes.
You can put the
you have to
2.
get rid of the dx as well.
You can put the 2 square root x just on top of the I don't know, the divider. I don't know how you would call it.
Yeah, like this one.
Fraction, I think.
So then we get square root of t, or t plus 1 minus the
that also works.
square root of t. And like usually I would put like the big brackets thing around here and copy these ones, but I don't know how to do it in a LaTeX. But so I'm just gonna do it like this. So
Yeah.
like this then. I think.
I think so too.
But it's so fucking suspenseful, man. I swear to God.
Will they show you instantly
The
if you have the
moment
answer
of
right or
truth.
wrong in the test?
Yeah, no, that's why I'm gonna cry.
Yeah, but will they show that or not?
No.
No,
No.
of course not.
No.
No.
But it will automatically calculate your grade or something like that. It said.
Yeah,
I think,
but
yeah, I think you only
You
see
won't-
that at the end. Like,
but they won't show you like you did it good the first time. Then you know, yeah, okay, let's do the second time the same thing.
Mm.
So, like,
How
But
many?
you have multiple
we-
attempts.
Yeah. How many times can you submit an answer?
I think you can
One.
submit as much as you
One?
want until you click the final submit button.
So the final one only goes through. Okay.
That would make sense to me. I'm not sure. I didn't read
Yeah,
it.
because making it only one, you make one typo. You
Yeah,
I don't
exactly.
point.
Imagine
but then
accidentally pressing.
You won't know that you made a typo.
So what if you accidentally press enter? You just fucked.
Yeah,
You
man.
submitted your answer.
Yeah, and that would mean that you wouldn't be allowed to like go over your answers again.
Yeah.
Double check.
I mean,
I doubt-
there's an
I doubt
example
that you would
exam
be able to fill
on
it.
there's an example exam on grasple that we received a mail for.
Yeah.
And
Did
I'll
anyone
do
try
that-
it,
I'll
or-
do that
idea of how it would
tomorrow.
be?
I haven't done it yet.
I have to set up my webcam because I just got one.
You
Okay,
don't
guys,
have to
can
type
you-
the post when you
Yeah.
calculate those integrals.
Well, for now I'm just
Oh, we're at the
I'm
next
just
one.
evaluating it, but can you guys spot the mistake?
Yeah. What?
What?
Maybe without the minus.
Exactly.
Yeah.
I was about to say cosine turned into minus sign with the derivative.
Yeah.
Okay, so then we get this, and then we can say okay minus. So we get thing of minus of t minus sine of 0.
Minus 0.
Sine of 0 is equal to 0.
0.
So this is just equal to 1/6 sine of t.
Yes. Yes.
Suspense. Dun, dun, dun.
Yeah.
Dun, dun, dun.
Nice.
Ooh.
Okay.
Okay.
Grasple
we
is
have the
Hitchcock
integral
inspired.
Of 6 times the square root of x.
So it's going to be
X
0
from-
times x and a half.
1 to 10. Well, we can start by already taking the 6 out of the integral. Like,
Okay.
let me tell you guys, just whenever you see a constant inside of an integral, take it out. It's just gonna
Yeah.
be
Fuck them all off.
Mm.
Wow.
Okay, so now we have
Makes it
the
so much
integral of the
easier.
square root of x, and we already had this one. This is just x to the power
0.5.
half. So then we let me see if I wrote that correctly.
It's 2/3 to the 3/2.
Yeah.
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 So it's going to be 12 or...
Two-
It's going to be
two
4.
times-
It's going to be 4.
Okay,
4x 3/2.
and then x of 3/2. Get rid of the dx, and then we fill in the
What?
right terms.
Because 6 times 2
Oh,
over
it's
3.
2 times that.
Yeah.
Yeah.
Yeah. Okay, so we will have 1 like this. Oh wait, 10 like this minus 1 like this. So times 10 like
I'm not going
this.
to calculate that. I'm just going to write it out flat.
Yeah.
I don't care.
Minus 1 like this. And this is just equal to, let's see, to the power of 2/3 is equal to the square root of the power x to the power 3. Well, this is just 1, so, you know.
Yeah.
Yeah.
I don't think you have to calculate the other one.
No.
We can just fill it in, yeah.
I don't know. I can't think of how fast I get. How you calculate 10 to the power 52.
Let's go.
It's 10 square root of 10, but
Wait,
whatever.
5 out of 5. Let's go.
Okay, what's the square root of 10?
100% maybe? Hmm.
It seems like we didn't fully understand it. We gotta do it again. That's a shame.
Okay.
Grasp sets or scrubs.
Fuck grasp.
Yeah, honestly.
I mean,
Yeah, honestly. Fuck it.
the man's got a point.
Hey, but I hope it does like the calculation part in grasple during our exam as well, because sometimes you might not put in the fully simplified version if that's like not going to give you the point.
Yeah, grasple can.
The question says it. The question says like, yo, you have to like fully simplify it, or you just fill it in.
Oh wait, what?
He said in the
Oh.
lecture, because I asked the same thing in a lecture, and they specified that in the questions, if it says you have to simplify it or write it in a certain way, you have to do it that way. And otherwise, it doesn't matter how you write it. Grasp
Yeah,
will
if
calculate
it
for
says it explicitly, you have to. Otherwise, grasple can evaluate if two algebraic statements are the
I'm pretty
same
sure they're
value.
gonna go like over all the ways it's feasible. Like,
This is technically a standard integral.
Yeah, but we have to do a substitution.
So I'd say take away the square root of 5 minus x squared, and then take the derivative of that.
Mm-hmm. What do you mean?
Yeah.
Like u is gonna be square root of 5 minus x squared. And
Can it be just 5 minus x squared?
I was gonna say 5 minus x.
And then du is gonna be 1 over.
If we say u is square root of over 5 minus x squared,
Yeah,
then,
why not?
Then du is
Yeah.
going to be like something involving x. And that's not going to be
Yeah.
precise. So I say, and this is going to be an interesting one. I say we set u is equal to. Let me actually.
Square root.
U is equal to the square or the fraction 5 over or x over square root of 5.
Oh, it's that one. Yeah, the fucking one I even asked in the Discord, and then I just.
Yeah. So basically, what we're going to be doing here.
Oh,
is,
what?
we can multiply by a constant because therefore du is just going to be equal to dx, so we don't have to worry about that.
Technically, we don't even have to substitute.
So could you like show me how you get to the u again? Because I'm.
Well, sure. So if we fill this in, we get du here. And
Wait, isn't du 1 over 5?
Fraction of x
Yeah.
over the square root of 5. And what did you say?
Like du, isn't that 1 over 5 square root of 5?
No, because u is 1/5 1 times square root of 5 times x, so that's just a constant.
Oh, okay.
Or
what?
Wait. Now that you're
no, because the derivative of x is going to be 1, so it's going to be 1 times 1 over.
Yeah. Now that you mention it, that's a good one.
But how do you not get that u?
So
how is that?
There is a.
I haven't done this before, so I'm just gonna try it, and we'll see if it works.
You can technically skip those steps.
But how did you get to
It's
that
not
u?
really legal, but the same way you can take constants out of the integral, you can take them out and into the d part, the dx. You can make it 5d5x over 5, and take out the 1/5. Like
We could, but I genuinely do not know what you mean, and I'm just gonna go on with this method because this is like just normal u substitution for now.
yeah, it's just skipping the parts of this method
Yeah.
since you're
But
multiplying
this is like
x
the
by a
first time I'm doing
constant.
this ever, so I'm just gonna keep it like this.
Yeah, alright.
I just want to see if it works, and I think it does. Let's see. So du is
Oh,
equal
so
to
it's
this,
just gonna.
and therefore dx is equal to just square root of 5 du. Right? Yeah, because we multiply both sides by square root of 5. So then here we will get the square root of 5 on the top, because we replace dx by square root of 5 du. Okay, so then we will here get the fraction of square root of 5. Okay, so this thing is going to end up with x squared over 5.
So you're saying that x squared is the same as x over square root 5 in the.
I think you substituted wrong.
Yeah, I think I might
Because
have.
you wrote that x squared is the same as u squared.
Yeah. I see. I made a mistake in my substitution.
I think we can
So that
substitute
means
u.
that x is equal to u times square root of 5. I'm kind of like winging it. I think you guys noticed, but
Yeah.
I'll see if this works, and if not, we'll try again. So therefore, this thing should actually be this squared. Oh yeah, I think this is correct. So this thing should then be this squared. Recompile. Why is it writing capital U? Because I put a capital U. No. Is my capital key is on.
Nice.
Dude, I'm making some proper brain power. Okay, yeah. I see how this works now.
Let the bass kick.
So this is equal to 5 times u squared.
What the fuck is going on?
Okay, yeah. So this substitution it's a little weird.
Yeah, I wouldn't say so.
It's in the end it ends up working out. Because now we can say, okay, this is equal to square root of 5 times.
It's a fucking convoluted.
Yeah, okay, I see. And then we can cancel away the 5 on the top and the bottom.
So it's gonna be 1 over square root of 1 minus u squared.
Yeah.
So it's gonna be 1 over 1 minus u.
No, it's no, you cannot just take the square root of 2 things. But this is just the arctangent.
Oh, no, you can't.
Yeah,
I
this
am
rectangle.
cheating.
Man's got brain power. You have no idea. Okay, yeah. So this is, or this is
I'm
the
gonna
arc sine of x, right?
Arctan. No?
No, it's not
Oh
tangent.
no,
It's not a
it's
tangent.
yeah, it's sine, it's sine,
X
sine,
It's
sine.
sine.
Yeah.
I'm just gonna accept that I have this
What
wrong.
we end up getting is
No, it's the cosine. Wait.
No, the
Let's
cosine
look
is
it
the
up, let's look it
minus. Right?
Cosine is minus.
I am no.
Anybody had the formulas for all this? Or
I have it here. It is the arc sine. It is the arc
yeah,
sine.
the
I
arc
can't.
sine is this, and if we had like this,
A minus in front of it,
yeah, a minus
then
in
it,
front of it, it would be the arc cosine.
and I think the inside had to be a plus of the
For the
arc cosine. I'm pretty sure it has to be a plus in the middle. But
No, arc cosine
Oh,
and
just
arc
the-
sine are literally the same, except for that the one is the opposite, like the minus of the other.
Yeah.
and they're misrated.
Yeah.
Oh, you're
If
right.
you look at the calculus channel, there's a pinned message that says that.
Yeah.
So then we get arc sine of u. So then we get arc sine of. And we said u to be x over square root of 5. So we have fraction x
X
over
u.
square root of 5. Okay. So we start with this. We set substitution u equals to x over square root of 5.
And that's where I stop. I note how you get that from that.
Okay, for this one, I saw a discussion earlier in the chat where they were like, okay, you have to get rid of this 5 some way. If you set u is equal to x over square root of 5, it works out. I never tried it, but I just was like, okay, we have to do it here, so I'm gonna try it.
Yeah, well, in that case, I would get it, but like, I'm like, if
but
it's
how do you come?
if there's anything else, I'm just gonna be
Yeah,
like,
the other way is you
there is-
need to get
Okay, let me first. There is a
Yeah.
constant here that is not 1. Just set u equal to x times the x divided by the square root of the constant.
right. So if I
Any
just see
constant
this,
that works. That also works with the cosine version. I'm not sure if it works with the arc cosine function. I'm not sure if it works with the arc tangent function. It probably does. No. No, you probably have to figure something else out there, but.
right, but just go on.
Now you know this trick. So now you know.
No, I think for me, I think it makes sense because if you have x over root 5 or x over root 6, 7, doesn't matter what integer it is or whatever number it is.
Yeah.
You're trying to get it down to so that you can turn it into arcsine or arccos or arctan, right? So you want to have 1 minus something or 1 plus something. So you're always going to have that same number that you have in that square root, unlike for u. If you get what I mean.
Yes.
Yeah.
And you swap the x by u times square root 5, because if you take the u equals x over square root 5, then you can rewrite that to x equals.
Exactly.
Right. All right.
Cool.
I'll try to remember that.
Okay, so we
Did
got
they
this
do it?
one next. Like we're already busy for like 32 minutes with this one.
Yeah, because this one has two. This one has
exactly
two parts.
the version of that.
yes.
So let's see how far we get. So we have the instead of the square root here, this is just x squared plus 7, and because of this trick, we're gonna say okay, u equals to x times square root 7. Okay, so these are our substitution values.
Oh, whoa, what the fuck?
Yeah, no, it sometimes doesn't like.
Wait, why are you the square root of 7?
Because the constant is 7 now.
But no, but this time it's not a square root, so it
Yeah, no,
shouldn't.
Yeah,
should
but
be 7.
this is another standard is arctangent.
So it should be square root 7.
Should it be?
I'm a bit confused.
Well, I don't know where this would come from, because in the last one you also had the square root, but then because the 5 is in the square root.
Yeah, exactly. Now the 7 is not in the square root, so just doing.
Oh, okay, I was about to say.
I think it will work like this. We'll see. I'm gonna be honest. I don't know. I've never tried
Yeah,
this.
that's
I'm
how
just
it
gonna.
I thought you would just take x squared plus 7 and you get 2x, and then I don't fucking know. You like.
Yeah, but like if you get 2x, you'd have to have a 2x.
Yeah, but then you get 1/7 time. I don't know. It's just,
Yeah, you can only use the you can only use the substitution if you can already see the dx or the du over here, and we do not see an x here, so we cannot say anything about x squared or x to the third or whatever.
Yeah.
Equal to u. So basically,
becomes-
if there's nothing in the numerator that you can work with, let me check if my recording software is running. It is. If there's nothing in the numerator to work with, all you can do is work with constants times x.
Right.
Wait, so what do we make u equal to?
We said now u is equal to x over 7.
Right.
And we're going to see if it works. So dx is equal to 7 du. So we end up with the integral of
Oh, and then it becomes
7
1
times du.
over u squared
X
plus
squared
1.
becomes...
You're genius.
let's see, x squared becomes...
I think it's u
squared
squared
times what? Times 49?
7. Oh yeah, okay. Yeah.
C dot... okay, I think we're still not quite correct.
No, yeah, and you need to divide it by 7, so it's gonna be 1 over.
Yeah, but now it's 1 over 7u.
Yeah, but that's balls.
Wait, let's see what we get. So if we divide everything by 7, this becomes a 1. Or let me actually make a new line for that one. So this becomes a 1, this becomes a 7, this becomes a 1. And now my question is, are we just able to say, okay,
you have 1 over 7.
Oh wait, no.
You can't just say it's gonna be 1 over 7 times 1 over u plus 1.
Yeah, but we cannot.
No, you can't just say fuck it. And u plus 1 doesn't give much, so the 7 is definitely well, bad.
Yeah.
Bad.
Wait, what
7.
if we say t is equal to
square
root of 7u?
I'm gonna see what I get.
Because if we do this, let's see, then dt will become square root of 7 du.
Is there a standard way that this always works, like how this works?
I'm just improvising at this point. We haven't learned any of this, I think.
I don't think so.
Frac 1 over square root of 7 equals to u. Okay, so for the next substitution, we'll say t is square root of 7u.
Wait, why did we?
Well, because we
Can you
cannot
scroll
work
up
with
a
this
bit?
either.
Can you scroll up a bit?
Yeah, sure.
Shouldn't u be equal to x over square root of 7?
Yeah, it probably should have been.
Yeah.
Because it's the same idea as before. We need to make x squared plus a constant be x squared plus 1, so the over part should be the square root of the constant.
Yeah, indeed. So it should be the square root of 7 here.
That's why we just made a circle here.
So I have a different answer. I did it on my way, but I don't know if it's correct, obviously.
I'm gonna have a look to see if this works. So now we know du is equal to.
Wait, so you did change it to square root
I
again?
mean, du is 1 over 7 dx.
Yeah. Or du, yeah, 1 over
But
7,
then-
1 over square root of 7 dx.
Yeah, because now if you look at what you've done,
It's basically the same
you
as
said
saying-
t is equal to, which is square root of 7 u over 7, which is u over square root of, x over. Yeah, just substitute in the t equation, t equals square root of 7, substitute the u. Like, not substitute, but like put the, what we said u is x over 7.
Okay, so now we end up with. Oh, and then get rid of the c dot 7. Now we end up with this, right? Oh, shouldn't be here. I think this is correct. At this point, I'm honestly not sure anymore.
Was it correct or not? Well, it seems like a lot of. It seems like it's a lot. You made it a lot harder than it should have been.
Yeah, I definitely did. I should have said like square root of 7 here.
I hope Wolfram takes this notation. Let's see.
How does he take? This is eventually going to be equal to 1 of square root of 7 times.
Wait, why is ln the log? Is that the same thing?
Yeah, Americans use log as the natural logarithm, and like our log 10 is their like log subspace 10.
So if I want to get the derivative of a natural logarithm, what do I type in Wolfram?
Just the derivative of log.
Oh, so instead of ln, I should write log.
Yeah, I think so.
Let's see what that gives me.
Okay, so we have t is equal to square root of 7 times u. Square root of 7 divided by 7 is x divided by square root of 7.
I want to have a natural logarithm. Yeah. Does anybody ever use Wolfram here?
I have.
Well, I can't get the ln.
If you just say log instead of ln, does that work?
It doesn't seem like it unless the capital log. I don't know.
It's probably wrong. That's what I thought. And now if I get rid of this. Oh. What?
I think why is it the log? On.
Okay, it's gonna be log first of all because it's a straight up formula. 1 by x squared plus a squared is a straight up formula that you can use.
I thought that too, but I can't.
You just ln x squared plus 7 and then the derivative of that.
So basically I did this in high school. So 1 by x squared minus plus a squared. Wait, it's plus. Oh shit, it's plus. Even that is a formula.
I mean, isn't that sine?
So what is your answer? Like,
it's not given in the formula sheet.
It's not given in the formula list, but the answer is 1 by a arc tan x by a plus c, where a would be root 7.
Wait. I think it's sine. Like if you go and check it, like derivative integrals of sine. Wait, no, but then no. Okay, no, that doesn't work.
Yeah, the arcsine is minus. The arctangent is 1 plus square root of x. So.
Oh, arctan. My bad.
So would this be arctan of x over?
Oh, my answer is going to come out at 2x over x squared plus 7. So I have 2x the many.
Okay. Do you mind if I make a call here, or should I go?
It's fine. It's fine.
So this will be correct. I don't know. No, that's what I thought. Wait, so that's what I had. 1 over 7 arctan of x over. I had that. What do you mean?
Maybe you because you have to do the c dot or something.
Yeah, no, I did the c. Oh.
No, you have 7 divided by square root of 7. It's x divided.
Yeah, I changed that. I changed that.
Yeah, he changed that though once.
I fixed it, but I think I first took away this, then I fixed it, and then I didn't put that one back. But my answer was correct. Okay.
Yes.
So you are just allowed to say 1 over 7. Wait, can I see it? A little bit up. They just say 1 over 7. 1 divided by x over. What the fuck? Bruh.
Yeah. So my answer was correct. They just immediately substituted the divide by square root of 7. I just did one extra step where I said times 7, but that was wrong. But in the end, you would get the same answer, namely just the arctangent divided by the square root of. Yeah, because this is what we had as well. Like here, look, it's just literally the same.
Wait, so there were like a few extra steps that we didn't really require.
We did like here, I did like divided by 7 instead of divided by square root of 7. But
yeah, which really wasn't required.
I here did another.
What the fuck is this? This.
Yeah, just if you see this, just do it with the square root because you want to have x squared cancel out the 7 instead of just x.
Yeah.
But apart from that, my method was correct. I just.
So if it's any form of the arcsine, arctangent, or arc cosine, you just
divide by the square root, I think. Oh god.
And then you just like fuck around.
Oh wait, this is really easy. This
is simple.
Because it's arctangent x times.
Yeah, we can just say
1 over.
You just take 1 by arctan is
Yeah, we can just say u is equal to arc10x. Because then du will be 1 over...
Yeah, so it'll just be u.
1 over 1 plus x squared. Dx.
And so dx
yeah, okay. So then we will end up with the integral of... Oh, I didn't copy it yet. Arctangent of x is this plus 1 plus this. And we can copy this. And this will be part of the du. So this will just be the integral of u, du.
What will dx become? Won't dx become 1 plus x squared?
Yeah, and that will cancel out with divided by 1 plus x squared.
Oh yeah, because go times that, and then it's
Yeah. So this all cancels out, so you get the integral of u du. So that will be 1/2 integral of u, 1/2 u squared du, or 1/2 u squared plus c. So we will get 1/2 arctangent x squared plus c. Hell yeah. Compensate for the lost time.
Okay.
Ooh, this one is interesting. So this one is pretty easy. Because we have, so let's see.
Take sign as t or u.
Exactly.
What the fuck is that sound?
What?
Somebody's getting a notification and it sounded hella wacky. But
that's my friend, I'm sorry.
So you take u equals?
So we take u equals to sine of 2x. Because we can already see the derivative of u in here. So du will be...
What the fuck?
What? Oh, because the derivative of sinus becomes cosinus, and we already have a cosinus?
Yeah, because we have a cosine. Do keep in mind it becomes 2 cosine because of the...
Yeah, so
we can just take out the...
You can put a half in front of the integral.
Exactly, so we'll put a half in front of here to compensate for the...
So it's going to be a half, and then 0 to a fourth.
Absorbed by the du.
You gotta remember that's from 0 to a fourth pi, by the way.
Yeah, I will do that once I've got everything filled out.
So this is u to the power of 5?
Yeah. So
Gmor
sucks. 1/6 u to the power of 6 du.
No, without the du. Without the
Oh
du.
yeah, without the du. So this is going to be...
It's going to be 1 over 12.
1 over 12 u to the power of 6. And then we just fill in...
No, we replace the u.
Plus...
I mean, what we can do is we can take the bounds as like... the sine of 0 is 0, and the sine of pi over 4 is... Anyone know?
1...
It's going to be a half pi,
1 by
right?
2.
It's going to be half pi.
Half pi.
Half pi. Okay.
No, 1 by 2.
Because it's 2 times a fourth pi, so it's going to be sinus half pi.
Oh yeah, sorry, half. So it's going to be half, which is 90, which is 1. 0 to 1.
So, wait, we'll take the sine of...
Yeah, sinus of half pi.
Minus sine of 0, so let me actually write that out real quick. So we'll take the sine of...
And then that's in square. Wait, it's to the power of 5.
Over 4 to the power of 6 minus sine
0.
Oh, and this should indeed be...
2.
So it's going to be 1 over 12.
Yeah.
Yeah, I forgot that it has to be like pi over 2 because of the 2 pi, but...
Yeah.
Yeah, so and this to the power of 6 as well.
Right.
Okay, then this will become 0, so this will cancel out. Okay, sine
Could
of pi over 2.
Could you technically do this by taking the u as the cosinus, and then because then you also get a minus sinus.
Yeah, but then the thing is, you would have u du and then still times like sine to the power 4.
Yeah, fair. Alright. And you get stuck. Yeah.
Yeah, I wouldn't.
Wait, so why was pi over 4 into pi over 2 now?
2x.
Oh, okay.
Yeah.
Because I know that I don't know where I think
this works because I'm very lazy. Let's go, boys.
Yeah.
Wait, it wasn't. That's 1 over 12, right? This is the same. Yeah.
Ooh. Okay, yeah, this makes sense. So all of these are they just already they basically hand it to you on a platter, so it's really nice.
Yeah.
But is that going to be in the exam the same?
Probably not.
I don't think they will give us this.
Probably gonna do
question,
the
like-
book exercise then again.
I mean, you probably start with some easy ones and then you get
Yeah.
to the harder ones. And if you can do all the easy ones, then you probably can get to a 5 and then hope that
Yeah.
you can get some of the hard ones.
Well, you don't have to get a 5, right?
No, you don't, but like,
Yeah,
If-
I mean it would be nice.
I would like
Wait,
to get
don't
like
you need to
7 or
get the
something.
5?
No.
If you're gonna get 30%, what you want to get is like a 7.
Yeah.
Yeah, about
Basically,
a 7,
you
so you
want
can
to
get a 5 on the
Then
answer.
if you get a 5 in the final exam, that's
Yeah.
I'm
You
more
want
worried about
compensation
web
to
days.
be able to get a 5. That's basically what I'm
like
going for.
if you get a 7, that means if you get a 5 in the actual exam, you get 5.5 mean, which I think is what you need to pass.
No, you need to get a
No,
5.
no, you need a
5.75.
5.75, so 5.8.
Oh,
that's
all right. Then
fine.
in that case, I think you need 7.3.
I mean, most people here can just write a Python script to calculate what they will need.
Okay.
I mean, you could, but you could also just grab a calculator.
Exactly. You could just fill in the numbers and
The thing is, people here are good at programming, but not good at math.
Why do you think we're 3 hours in and we're only at lecture 7?
Whoa, whoa, whoa.
Exactly.
Talk for yourself, man. I'm shit at both.
Yeah. We on
Thanks.
Oh, legend. Okay, so this will be 1 over 5, and then ln of x to the power 5 plus c.
Wait, hold on, I wasn't looking. The fuck you already the entire thing. So what did you took as the u? And an x and then 1x.
Yeah, here we took ln
And then you just get rid of the 1x, right?
Yeah, because du is equal to 1 over x dx, so I can already...
And then you already have
here.
that. Yeah.
Yeah, and then we just have u to the power 4, that's gonna be 1 5 u to the power 5.
Yeah, alright. Yeah.
And
Yeah, I
then
was
ln x.
still writing. It's not that fast.
Let's go.
Storms.
Wait, didn't we just have this?
No, because last time it was the sine is
Yeah.
power 5.
Oh,
So the
yeah,
only thing
okay.
now is that you take u as cosine, isn't it, I imagine?
Yeah, fair.
And you just got
It's
the
just as easy, it's the same step, but... cosine squared x, sine... Oh, it's 6x actually, my bad. So we take u equals to the cosine of x, or 6x. Du is equal to the negative sine of 6x times 6, because of the chain rule, the chain rule. Only my real black pen, red pen people will get that.
Gee.
Okay, so we take negative 1/6 out in front. And then we integrate, this will become u squared.
Does it become negative minimum?
Hmm?
Doesn't it be? Oh yeah, because because you have only
differentiating that, so.
you only have
Okay, then we can just fill this in. So this will end up being 1 over 3. So this will become 18 u to the power of 3. And then we fill in the bounds. So u ended up being cosine of 6x. So we'll get 6 times pi over 6.
We can actually also already
cosine pi
like before, and then it will.
1, which is minus 1. So it's gonna be an 18th, 1 over 18. Is that correct?
Yeah, probably. No, negative 1 over 18.
Why?
Because we have a negative sign in front.
Yeah, but cosine is pi becomes minus 1.
Oh yeah, it does. Oh, you're right.
So the negative
Yeah, the negative cancel.
But how about the right side? The right side, what does that become? If you fill in
cosine
0,
of
you get...
0 is just 0, right?
No, it's 1. Cosine of 0 is 1, I think.
Yeah, it is.
Oh,
Cosine is the x.
I was
The
thinking
x
of,
axis.
I was thinking
So
of
it's gonna be-
half pi, or pi.
So it's going to be minus 1.
So again,
Like 118 minus 1, I think? Or is there
No,
something
no,
in front of
what,
it?
wait.
I haven't written it out. Let me write it out.
Isn't
I
it just
think
0?
it's like -1, -1, and
Oh,
it
so
would
then
end up being
Oh,
1.
yeah. It's, wait,
One
it's going to be
2 over 9.
0.
Yeah, it's yeah, it's 9. Yeah.
Yeah, because
Hold
it's
up,
minus 1, minus 1. That's minus 2. Minus 2 times
Yeah.
minus 18. Hey guys, 3-hour mark. Let's go.
Woo!
Ooh. Back to lessons. So that's lecture 7 done, right? Let's go. Integration by parts. Ooh, DI. Let's go.
Cool.
Okay,
Here I'm almost confused, like which one I would take, but
Okay, evaluate the indefinite integral.
this one I know. But...
To
Yeah.
Well, we don't know the integral, but we do know the derivative. So if we just say, okay, we take the derivative of arc, we take the derivative of, excuse me? Can I not, like, type?
No, not allowed.
Is it white or?
I don't think it is.
What the fuck?
Oh wait,
What
hold on.
happened?
I'm on the wrong layer.
Oh.
So let me delete that layer to get rid of
F,
it. Okay,
F, 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 F.
arctan of 2t, and we integrate 1. Let me move this I over a bit, because that's going to be really annoying if I have too little space. And then we fill this up. My paint.net skills are almost as worth as much as my assembly skills. Okay, so if we integrate arctan of 2t, we get 2 times the arctan of 1, so we get 1, no?
No, we get 2 over 1 plus 4t squared, I think.
Yeah, exactly. So we get 2.
Why are we like zoomed in on something?
Hmm?
Why did we go from the whatever you use, the latex online to this?
Because we are using DI method.
Yeah, the DI method. Like I don't know how to get a D and an I and a plus and minus shit into there, so I'm just gonna do it like this.
DI method, the fuck?
Oh, you missed the first part.
He wasn't here at the
I wasn't here in the lecture 1 and 2.
Oh, you're gonna get your mind blown, my man. So
yeah, because I'm always confused with what U and what D and what V I take.
So
yeah, but you don't need that here anymore.
Like
okay,
at all.
you still need it, but
for any of these. Because I know I have to take arc tangents 2t for this one, and then it becomes dv is dt, and then v is t.
Plus, oh yeah, I should use t here instead of x. Just imagine that, because I'm too lazy to change it.
What the fuck is going on here?
Arctan, oh my god.
Oh yeah, but you still need to know what d you have to take.
Arctan of 2t times t minus the integral of t divided by 1 plus 4t squared.
And why did you swap the 2 out?
Hmm?
Where did the 2 go?
Oh yeah, 2 times the integral of this.
Yeah.
Okay.
Well, wait, are you then allowed to say that the 2 is changing into a t? Doesn't that become 1?
Where?
You say 2 times the integral of t over 1 plus 4t squared. But that t, how do you get that t? That's on the top of the thing. Yeah, there. No.
Yeah, this.
No. Wait, huh?
Like,
oh, you do it times. Yeah, you do it times.
Yeah. So you go every row that you do not want to take the integral yet. You go this times this plus minus plus minus.
Yeah, but it's basically
when you want to stop, you just take the integral of this.
Yeah, it's basically the same. It's just what I do.
Does it still need to be the minus?
Because then you
still
that? My struggle is what D and what I do I take. What D and what I do I take, you know? Because sometimes you get like this stuck in this infinite loop, and then you say like, yeah, A is like this integral, and then you like.
Yeah, but you can do that as well.
But then the other time, one time it does work, and the other time they're just like, nah.
It only works if you have like cyclic functions, like either e to the power x or like cosine or sine.
Yeah, but
so
I
we
don't
have
stuff.
the arctangent of 2t times t minus the integral of, or minus 2 times the integral of the fraction of t divided by 1 plus t divided by 1 plus t to the power of 4.
T to the power 4, hold on. How do you get t to the power 4?
No, t to the power t squared.
Yeah, and where did the 4 then go?
Yeah, okay, so
it's gonna be 1 plus 2 t squared.
Yeah,
I
so
think.
this is 1 plus 4 t squared, yeah.
Oh, does the 4 not get rid? Because you divide it by 2, don't you?
Where?
Like you 2 times 2, or not? Oh no, wait, no, yeah. That doesn't matter.
Okay, so this is correct. Now, what we do is we say we can set the bottom. We're gonna do a u substitution, and we're gonna say u is 1 plus 4t squared.
Yeah, right. That's I think.
And then du is
8t.
8t.
Dx. So dx is gonna be 1 over 8t.
And this is gonna be fraction. This is gonna get absorbed. This is gonna be 1 over u. However, this is gonna be. We still have to take a 8 out of here, so this becomes the fraction. Instead of 2, it becomes 1/4, because we multiply by 1 over 8. And
Wait, what does TX mean there?
Yeah, TX, what is that?
yeah,
What?
so this is the...
It should be. Oh, no, it should be
Yeah, it should be
DT.
DT. Okay, I was already like...
Yeah, okay.
Sorry. We've been going at it for like 3 hours. I'm getting a little bit... Okay, so this should be correct, and we know that this is just the natural log, right? Yeah, surely. So this is just going to be the natural log of u. And that's just going to be equal to 1 plus
Don't forget the arctangent.
t squared. So then we will get this plus c. Let's go!
Let's go.
Fuck yeah. Okay, cool. Sick.
5 more times.
Want me to beat your teeth out?
4.
Okay,
Got one.
so this is just basically literally the same thing, except for we take out all the constants.
Well, yeah, now it's instead of the 2t, it's gonna be x. That's the only difference.
Yeah.
Yeah.
It's
So
just-
basically, wait, do we still have this one? We probably.
This one is easier.
So I'm just
Yeah.
gonna say take away this 2. I'm gonna take away this 1/4. I'm gonna take away this one, and I'm just gonna say fuck it, hand it in, see if it works. It probably does. X times x of what? ln.
Well, do you still keep the ln?
Yeah.
Well, let's go.
Oh no, I forgot the plus c.
Ah,
Whoops.
and it's still
Oh, it's still
wrong.
incorrect.
Yeah, because the wait,
You don't do a substitution anymore the second time. Like I think you can do it in one go. It's just the derivative of the arctangent.
There we go. Okay, yeah. So it was still the same. I just forgot that we set d equals to, or that we let's see. So here we, yeah, here we still have du is a half dt. So or du is 2dt. Excuse me. So we still have to take half out of it.
I'm just gonna write it out anyway in the test.
oh yeah, okay, yeah. Yeah.
Okay. Ooh, this
So
is,
in this
no, okay,
case,
this is not a cyclic one. This is a really fun one though.
So yeah, in this case, would you take the u as x or sinus? Because if you take sinus, you have to do it like twice, and then you can like replace it. But
no, we that's not how this one works. That is, there are some of them.
You have to bring it over the other side, right? This one.
No, that's not this one.
Oh, okay.
That only works if both of them are cyclic.
Okay.
Let's say.
over cyclic. When you say cyclic, you mean only.
When if you differentiate it enough, it will become its own. So
Right. So that is only ex. That's only ex, sinus, cosinus,
Yeah.
and then.
So the only ones are ex, sin, and cosine. So here we have.
Right. So if this would have been like e to the power x times sinus 8x, then you'd have to take. Then it wouldn't matter which u you would take. You just have to do it twice, and then.
Minus 64 sine.
And if it's a constant, then.
Yeah.
Then what happens?
Wait, what do you mean?
If the x was a constant, so let's say like.
Well, then we just take the constant out, and then you just have the integral of sine 8.
Oh, okay, fair.
Yeah.
Wait, how did that 8 go away?
Hmm?
In the sin x? Or...
I think you forgot.
Oh yeah, that's a typo. Good one.
Magic.
Yeah, I try to be really fast, but it doesn't work.
No, it's fine.
I mean, we don't have to be extremely fast. We have to be fast.
Yeah, that's
But
true.
like
We have
the
to be fast.
exam, yeah.
Yeah, I'm gonna take it a lot easier than I am now on the exam. But this is the good part about when the thing you're differentiating is gonna be it's like tending to 0. We can say, okay, we take this one plus this one plus the integral of this one, but the integral of this one is just gonna be a constant.
Yeah, and it's a c.
So
Wait, why does it become minus 64 sinus? Doesn't it become minus an eighth? 1/8?
Mhm.
Wait.
Oh wait,
Where did you get the cosinus from?
Yeah, so basically the
Oh,
sine
yeah, but
becomes
with
negative
integrating.
cosine, and the negative cosine becomes negative sine.
It is an
but why is it
integration.
minus
Yeah,
It is
but
an
it's
integration,
1/8
not
and then
differentiation.
1.
It should
Yeah.
be 1/8, yeah.
Yeah.
And then, yeah. Okay.
Okay,
But you
now
do
we're
it again. Wait, hold on. You do it again?
Hmm?
What's the third step? Well, how did you put?
Yeah, that's just for.
Yeah, in the end,
Yeah.
we have to add the integral of the bottom row. However, the integral of the bottom row is just the integral of 0, which is a constant.
Yeah, this is the methods. That's different than. But yeah, just let them do it and then.
Yeah.
Let him rip.
So we get minus x over, minus x over 8 cosine of 8x. That correct? Yeah. So then we do plus 1 over 64 sine of 8x
16.
plus c.
16.
Yeah.
Whatever, 8 cosine 8x.
And that should work. Probably. Yeah. Okay, nice. Yeah, that's like the difference between the methods.
Yeah.
Oh yeah. All right. Well, yeah.
Like the simpler, if you have it
Faster,
to
but
right.
yeah.
Yeah, it's faster, and like it's really not that hard if you haven't learned it yet.
Well, they
I
only
wouldn't start
like,
figuring it out during the exam, but if you haven't figured it out before, then you're good.
no, yeah. My worry is more that just like I take the correct u and the correct d.
Yeah.
So in this case, you have to first get the square root of x out, right? Like t equals square root x. So
Well,
it becomes this becomes 2t dt. So dx becomes 2t dt. I remember that because it's always the fucking same. And they always do it as soon as you have a square root of x.
Wait, give me a sec. What do you mean? I'm not.
So for some reason, wait, you logged out.
Yeah, no, my.
Oh, it's because you weren't touching the ring around it. You're only in grasple, but not in bright space. That's always fun.
Oh, what?
Yeah, welcome. Yeah, that's after 3 hours.
Well, you have been doing grasple for 3 hours.
Yeah, if you don't like go outside of the little
because
grasple
we're in a full like if we did this, like if we touch something here, then yeah, but we're only touching.
Yeah, but if you touch like the bottom, like if you go down to the white, like the little bit grayer part.
Yeah.
Then you would count again, but you just haven't done that in 3 hours. I'm just gonna start writing my answer.
I'm thinking of doing a U sub, but that doesn't work.
That's what they normally do, so I'm just gonna go with it.
Okay, let's see.
I'm forcing you. And then you can do substitution.
So imagine we have arctan of the
don't die.
Arctan.
It's alright. It sounds like it.
Of x dx. And what happens if we say u equals to let's see, square root of x? The only thing is I don't see a square root of x.
You mean there's a square root of x in the arctangent?
Yeah. Oh wait, what if we're?
Oh, you have to make it into t, and then you do the like t is not the u. Like they first get rid of the thing. Although this might be an easy one, so you can do without it.
I was about to say, like,
this could be an exception of that one. But normally in any of these questions, if you get like a square root of x, they're just like, oh, you gotta get rid of it, like making it into t, and then with t you can do the what's it called? This fucking thing. I don't know. This never trying to practice. Yes.
Okay, so let's try taking the differentiate, the what's it called?
Primitive.
No. Derivative, yeah.
Yeah. Okay. So if we take the derivative of this, we will get arctan. No. 1 divided by 1 plus x, because we get square root of x squared, times the derivative of square root of x, so that's going to be times 2 times square root of x. I think. Yeah. So then we take...
That was loud as fuck.
Oh.
But what were you trying to say? Because it cut out as well.
Yeah.
Okay.
What were you trying to say? We didn't hear you.
Yeah.
No, I didn't say anything. I said, oh yeah.
Okay. Okay, so we have the x times the arctan of x arctan of square root of x plus the integral from, or well, it should probably be minus. Yeah, minus the integral of.
So I also have a question.
Give me a sec.
Yeah.
Fraction of x over 1 plus x times 2 times square root of x. 1 plus x times 2 times square root of x. dx. Boy, this does not look fun. So until now it's correct. The question is, how do we do this?
Well.
Okay, so maybe what if we cancel out this one?
You went a completely different route than me. Holy shit.
Yeah. So if we divide x by square root of x, we will end up with square root of x on the top.
I think I have the answer.
Then we can get the 1/2 out of the thing, so we can say frac 1/2. Okay.
But I could be wrong.
Yeah, and then we can say, okay, let me copy this stuff over. So u
Where did x go? Like there was some x on the numerator. Yeah.
X divided by the square root of x is equal to the square root of x.
Okay.
How do you get the square root in Wolfram? Is it on some?
Yeah, backslash sqrt.
Yeah, backslash is from top left to bottom right.
Yeah.
Yeah. Right. sqrt and then x. God, this notation is horrible. Minus 1/3 times x times.
Oh, I'm getting what? Stop doing capital letters. S and H. So. Oh wait, actually.
If you put it in square root, you have to like surround it with brackets. I'll find out soon enough.
This is interesting.
See.
I heard someone got it already, or?
Nope.
Let's see what it gets. No, is it square root and brackets x? I want to have a square root in my Wolfram. I don't know what the notations are. Why is the whole Wolfram just like here have all the signs and just like flicking them in? I don't know. Is there like a fucking?
Wait. Okay, so let me just rewrite this one. It's gonna make it more clear. So that's just gonna be.
Where the fuck?
Dx equals to that du, and I can copy this one.
Maybe I have to do this
instead of dx, but
where the fuck?
thing. And here we have
like that.
1 plus u squared, and here on the top, and this is an interesting move, but here on the top we have a x. Wait. I thought it was gonna clean up a little bit more nice.
Why that's u. Like square root of x is just u. Why just don't you put u instead of square root of x?
True, but then we would have square root of
No, not square root, just u. U is square root of x.
Yeah, that's right, but we also have a square root of x here.
Mine is wrong, by the way. Let's see what
And what's then the problem to have u to the power of 2?
Then let's see. So if we get rid of the square root here and the square root there, then we would have u squared over. Oh, that should not be square root. It should just be u squared. Okay, so far I think we're still good.
Yeah, exactly.
But how do we do this?
Well.
Well, you see.
Actually, it is so simple.
There has been a message posted by somebody, by Tim, about this exact subject. So let me see if I can find it. Yeah. Okay, we get she. So basically, what he's doing is if we take this and we say 1 plus u minus 1, that's still the same, right?
I mean, Yes.
I mean, sure.
Okay.
I just subtract. Okay, that's
So
fine.
then we have the
Oh, and then you can cancel out.
yeah, 1 plus u squared becomes just 1.
Well, why is everything big braining?
And then you take the integral of 1 minus this thing. And that we can split up into two integrals. So we will have the integral of 1 du. Integral of 1 du minus the integral of 1 over... Okay.
So when are you allowed to split it like that? When are you allowed to like, split an integral?
You mean splitting the fraction or splitting the integral?
Like what you just did in the last two steps. So you went from the integral from 1 minus 1 over 1 plus u squared to 1 du minus 1.
Yeah, okay, so basically I split this up into two fractions, namely 1 plus u squared minus 1.
Yeah.
Yeah.
And then
we have the integral of 1 plus u squared over 1 plus u squared, which is 1, and
1
minus this thing.
Yeah.
And if you have just two separate terms, you can just integrate them separately.
Right, and yeah, so two separate, that means it can't be like a times or something. It has to be like a minus or plus.
Yeah.
The sign of the last integral should be plus, though. Right? Because it's now minus. So.
Yeah, but when it was minus, like
where's the second minus?
it's gonna cancel out.
Oh yeah.
Like the second integral.
You're right.
Yeah.
Okay, and the integral of 1 du is just gonna be u.
But then the minus disappears. Because it's 1 minus 1. So then that minus is like yeah. Why does that become plus?
We have
then you lose the minus.
This whole thing. So if we're gonna split it up, we get minus this plus this.
Yeah, but then it goes minus, and well, whatever. Sure, it's probably fine.
We have minus 1
I
minus
trust,
2, so that becomes minus 1 plus 2.
Yeah, sure.
Okay, so the integral of 1 du is just equal to... Wait, what is that equal to? Just u? Or is it a half u?
Yeah, that's true.
Oh, no, just u, because it's 1 over 1 u.
Yeah, u.
Yeah.
Okay, and then we get the integral of this, which is just equal to the arctangent of u.
Yes.
That was...
So the only mistake I made is that I split it with t squared. Well, u squared in this case.
Yeah. So
which
u
isn't
squared is
allowed.
Square root of u, so then we take the square root of u, or square root of x, sorry. And then
That's a big brain move, though. How the fuck are you gonna remember that?
Okay, this was a good one. This is a really good one.
I would never remember this. Well, I would remember it, but like if I see that, I'd just be like, I don't fucking know.
Could have this gone faster, like the first step already, or?
Wait, isn't it like minus arctan in the end?
Wait, what did you say?
At the end, minus arctan. Why is it becomes plus? Oh, I mean, yeah, it was minus and now it's plus.
Yeah, we have minus
It's correct.
1 minus another thing. So that's minus 1 plus the other thing.
Okay, yeah, because you extract them, yeah. I see. Yeah, I mean,
let me make it a little bit more clear. So if I put an opening bracket here, closing bracket here, opening bracket here, closing bracket here, opening bracket here. This is still a minus now. Closing bracket here. Now you can see, like, okay, where did my closing brackets go? Ah, wait, recompile. Oh, I put it before the du, excuse me. But yeah, we subtract this minus that, so that becomes minus this plus that.
Yeah, alright. And that minus in the middle comes from the fact that it's originally 1 minus, right?
This one, yeah.
Yeah.
Well, this is like minus 1, not 1 minus.
Yeah, and then that minus,
yeah. Okay, yeah. Yeah, okay. So, let's see if it's correct, guys.
Don't forget the plus c.
One of the exercises.
Don't forget the plus c. I will fucking kill myself.
You haven't done entry yet, huh?
Let's go!
Woo! That was way too long, though.
Holy shit!
Yeah, this is gonna be a third of the fucking time of your exam.
That was way too long.
This is fun. This is fun. This is a cyclic one.
What the fuck?
This is a cyclic one, so then does it matter which one of the two you take?
Well,
it does,
the thing it
of
depends
course.
on is like if you're like what you're gonna do with your sines and cosines and stuff.
You want to be integrating your E because the
Yeah, usually you want to be integrating your E.
Also because it's simpler in general.
Yeah.
Yeah, so this becomes 1 over 3 e to the power
lazy.
3x, and this becomes 1 over 9 e to the power 3x. This becomes sine of 2x. This becomes cosine of 2 times cosine of 2x, and this becomes 2 times or 4 times or negative 4 times sine of 2x.
Wait, the sine goes into the. No, shouldn't it be minus 2 cosine?
Sine becomes cosine, becomes minus sine.
Yeah, it is. Because if you take the derivative of 2 cosine, it's going to become minus.
Yeah, that's what we did.
4.
Yeah.
Minus 4
Yeah,
sine
but-
2x.
Yeah, but when you
What? That's good.
you went from you first take the primitive of sinus 2x, right?
No, we take the derivative.
Oh, you
There's a
take
big
the
column here called d.
Yeah.
That's for derivative. There's the big I here. That's for integral. Yeah, the integral.
Yeah, so the u would be sinus 2x, right?
I have
you
no
take-
clue. I never learned their method. I only know.
We don't do that here. We do that
Alright,
the
I do. So yeah, okay. Fuck, I was right. No, that makes sense. That makes sense.
Okay, cool. And then we have this one.
Do you just circle what you want, or there's a
No, you always have
like-
to circle from top left to bottom right until you.
Oh, when do
stop,
you
and
actually
then
know
you
when to
circle the
stop?
bottom one.
When do you stop? Like,
Up to you. If I wanted, I could have just taken this one, but then I would have probably seen it. I would have done it. Need to do it again.
yeah. Okay.
Don't
So
stop.
I
The
just
music
decided, like,
tonight.
hey, I know that this is going to be something in terms of my original integral.
Oh, okay, yeah.
So then I want this to be my ending integral, because everything that's
Yeah.
like diagonal is not an integral, and everything that's horizontal is.
Yeah.
So let me actually put this one on the right side. That makes more sense because I want to type over stuff a lot. So now we get the integral of.
Hell yeah, Thomas.
So this is sine
Zeker.
2x a to the macht a to the power 3x.
Wait, we lost the question.
Or
Yes.
Now I can't make it.
Yeah. Okay. So this is the original integral.
He's gonna type it.
All right. Yeah. Yeah.
This is equal to. We'll set this equal to L.
L. Big L.
Yeah. Or let's do big I because it's an integral.
Yeah.
Okay.
big
So I is equal to.
Big I notation.
I was about to say. This is a new big O notation.
Okay. So it is equal to fraction 1/3 sine of 2x e to the power of 3x minus fraction of 2/9 cosine of 2x e to the power of 3x minus fraction 4/9 sine of 2x e to the power of 3x. However, if we look at what we have now and what we have in the top, let me see if I can. Oh, I don't know what I just Control Z, but I hope it's nothing important. Oh, I think I just copy pasted my thing. So, oh yeah, okay. And it's very important that you don't forget. You have to still take the integral of the last thing. So, let me get this. Now, if you look up here, this is the original integral that we have. So we can say, okay, we still know that E is equal to this, and we know that this integral is equal to E as well. So this is the formula we get out of it. Recompile. Yeah, there we go. So now you can see, okay, this is what we will end up doing. So if we add 4/9i.
Someone's making a lot of sound.
Yeah.
13/9, I think. Yep.
Who is this? This is me.
No, that's not you. It is Plugats. You will probably get a server mute if it doesn't stop.
Okay, I'm gonna unmute you in 5 minutes, and if it's still busy, then you know you're gonna get muted again. Anyways, so now we know that I equal 13/9i is equal to this. So then if I copy this, and then I divide this entire thing by this fraction. I divide this entire thing by this fraction.
So I don't know if mine is correct. So let me see if I can fill it into Wolfram.
Isn't it beautiful?
Magnificent.
Thank you. And now
You can basically fill this in the calculator.
Yeah,
right.
when you're gonna submit this. Plus C.
Oh. See, this is why they tell you to simplify in high school.
Let's fucking go!
Yeah, let's go, man.
Oh my god, it's actually working. Oh, that's hilarious. Look at how ugly this is.
Oh my god.
This is
if mine works, mine is probably worse. I have 18 divided by 45. Yeah.
Oh, let's go. Hint, you will... What do you mean? This is like literally what we did. Oh. Okay, guys, fun stuff. So... Like, this is literally the same constant. So now you just have cosine of x instead of... Could I cheese it?
Do you think you can just copy and switch cos to sine?
Well, no, because there are some parts that are different. Like, because the cosine of x instead of cosine of 2x.
Oh, right, okay.
Let's see. Logically speaking, what would we have to change to make this correct?
It just died! No. My thing just died. Fucking...
Okay, so e to the 3x is the same. This is going to be... So let's see. If cosine is one step further, so this is going to become minus sine. Minus sine is going to... Yeah. Sine will become cosine. This will become an x. This will become just an x. This will become 1 over 9. And this fraction will end up being 1 plus 1 over 9 instead of 4 over 9. So that is 10 over 9. No? Is it though?
What was your original one?
You can see it on the right there.
Yeah.
That was the original one?
Yeah.
Yeah.
1 over 3 minus 2 over 9. Alright, I might have the same. Wait a second.
So let's
So
13 and...
Is it then going to be 1 over 3 times 13 over 9 or 9 over 13? Let me see.
Let's go!
What the?
Can you
actually?
That's such bullshit.
Can you keep the
That
answer there?
That is so beautiful.
God!
It's going to be 313.
Okay, so basically what I did is everywhere where there's sine of 2x, I just swapped it over one place, and everywhere where I recognized a 2, either like 2 or 2 squared, I just took that out and replaced it with 1.
Wait, hold on. The only difference is that in my answer, no, I was talking about the last one still, but you end up with minus 4 over 9i. I end up with plus 4 over 9. I somehow have a plus, but minus there.
Yeah.
I don't know. Yeah, I know yours is correct, but I don't know how I got a plus there.
You just forgot a minus.
Yeah.
When
So
yeah.
it was.
Ooh, wait.
Probably.
Back to lessons.
Oh, because they both go times minus 2.
Split.
Oh, yeah. All right.
What?
I make that
Yeah, you need to change that keybind.
Also, I'm pretty sure that lecture
We're
10,
almost done, man, and it's
lecture
not
10
even...
is worthless, by the way. The questions are bad. There's 2 questions.
We're still gonna go through them.
There's only 2 questions. One of them is multiple choice. And if
We're still gonna go through it.
Nothing. It's. I mean, yeah, sure. But let's start with lecture 9 first.
We'll see when we get there. We're gonna do it because otherwise it's not a lecture 1 to 10 speedrun, obviously.
Are we still recording? Yeah.
Of course we
I'm
are.
still recording, yeah.
Well, you say of course, but that's what you thought last time.
Oh, I see what you mean. I see what you
Okay,
mean.
wait. I'm starting to get like. Huh.
Yeah. Wait. You can just put the arctan to the left hand and then do.
Wait, didn't we do this one, kind of?
Well, yes and no.
Yeah. We already had this one.
We did this one, yeah, but.
I don't know if that's
Not to infinity, but yeah.
I think the. So we substitute arctan of x by u, so we'll end up getting half u squared. So the answer is half u squared, but instead of u, we will get half
arctan
0 squared. What is the arctangent of infinity? That's like pi over 2, right?
Yeah. Because the limit.
Yeah. No, it's not undefined. Arctan 10, arctan of 0 is undefined, but this is.
Yeah, if it's minus infinity, it's going to be minus pi over 2.
And then we do minus 0.
Oh right, yeah, my
So-
bad. Sorry.
This is correct.
It's gonna be
Damn
no. It's
it.
gonna be pi over 4, right, or something. Wait. No, wait. It's gonna be a half
Oh yeah, half. So
times pi over 2 squared.
pi over 2 squared.
What?
Because it's gonna be so
Yeah, pi over 2
the
squared.
the primitive is gonna
8
be
over pi. Yeah, because
yeah.
because it's gonna be half times arctan of x squared.
Yeah.
So this is the answer.
So I think that's it.
Let's
Yeah.
go!
What?
Dude, we didn't even have to write anything. We are so good.
Wait.
No, I didn't got that at all. How did you do that in your mind?
Okay, basically, we know that this is just equal to the derivative of u du, where u is arctangent of x, because we did this like 10 minutes ago.
Yeah.
And then we know that the derivative of the integral of u du is equal to a half u squared, and we just said, okay, it's a half arctangent of or a half arctangent x squared. So a half arctangent of infinity is pi over 8, or pi squared over 8, and a half arctangent of x, or half arctangent of 0 is just 0, so just pi squared over 8.
It sounded really confusing. I know what you said because I did myself, but
Yeah.
nobody's saying anything, so I guess they all understand.
Okay.
That's
like pi. Yeah. It's understandable.
Yeah. Also, in real life, you cannot say the arctan of infinity. You gotta say the limit of a goes to infinity.
Yeah,
the
you have
arctan
to
of a
spread
is
it like this.
You know, fuck that. Okay. If the integral of the verges fill in div. Well, this isn't very nice.
So first thing you have to put the limit to 8, like 8 is.
Yeah, first you have to say the limit of a goes to
Yeah,
infinity of.
and then we have to calculate dx. So, I think this is where you have to actually substitute the square root x by t. So this is going to become t is square root x.
Oh yeah, and then we'll end
and
up
then
with,
you get
u with the arctangent of.
And it's going to be 2 plus 2t squared, I think, over 1 or something like that.
I don't think it's going to be 2. Oh wait.
Wait. So
yeah,
you know that
let's
t
actually
is
do it instead of just talking.
yeah.
So I'm gonna fill it out.
So it's going to be
So we have
dx is 2t.
the integral of. Did that fuck up with my recording software? It didn't. Cool. So we have the integral of fraction of the square root of x times 1 plus x. Oh, and I need to add a 1 over here times dx. We can say, okay, u is equal to square root of x. Then we can say du is equal to the fraction of 1 over 2 times the square root of x dx. We recompile this, look at what it says. Okay, makes sense. I forgot a closing bracket, sick.
Oh, you do different, alright.
So here we will get 1 plus u squared. We have to add a multiple of 2
You have to
in front,
change. You have to
and we can
change
get rid of
the.
this.
Yeah, that needs to become a u still.
Yeah, the du. Okay, so now everything is in the u world. Well, this is just equal to the arctangent of u. So we get 2 times arctangent of square root of x, because u is equal to square root of x. Does anyone know what the arctangent of 1 is? Or can we? Yeah, no, probably we can just fill that in.
Isn't it just pi over 4?
Yeah,
Probably.
that's
Okay,
true.
cool. So we will have the 2 times the arctan of, what is it, infinity? So that's 2 times, that's what, pi over 4?
Why don't we use limits? I mean, so these are improper integrals, and we usually use limits.
In theory, we should be saying the limit of a goes to infinity of 1 to a, and then fill in a, and then do that. However, we know that the arctan of quote unquote infinity, so the arctan of A as A goes to infinity, is equal to pi over 4.
Yeah.
No, it's gonna be pi over 2, right? So then. Oh wait, it's square root. Square root. Wait. No, wait, it doesn't matter. Yeah, it's gonna be 2 times pi divided by 2. So it's gonna be pi.
Yeah, but then we also have the square. So then we
Oh, the
have
1. Oh yeah, it's gonna be minus.
Yeah, so we have pi.
The arctangent of 1.
Minus 2 times the arctangent of 1.
Isn't that one undefined?
I don't think so. No, the arctangent.
It might be 0.
No, the arctangent
So
is defined from. No wait.
Yeah, it is 0 because the yeah, because the sign is a 0 and it is, or it is minus 1.
We'll see.
Oh, I can't fit type anymore.
It is. No, it's pi over 2.
Huh.
Or it's pi over 4 actually, but then we multiply that by 2.
Oh, okay. Yep.
But yeah, we yeah, this is what you theoretically should say. So you should say limit as A goes to infinity, 1 to A. Then say, okay, the limit from arctangent square root of A is actually, like that, but
yeah,
like CBA.
Well, I think it's gonna be a 3-split question now. Yeah, and I already know the order of the answers.
Okay, so we have this. If the integral diverges, fill in div. 1 over x minus 1 dx. Isn't this just the natural logarithm of 1 of x minus 1? We'll see.
Well, if you fill in 1, it's gonna be it's gonna have an error, isn't it?
Well, we're not filling in 1.
Between 0 and 6, if you fill in 1, it's gonna have 1 over 0. It's just bad. And I'm pretty sure you have to address that. Because then you have to check if the left side is still the same as the right side, or something like that. This is like, I think it's the second form of, like, I don't know what they call it. The second type is it anyway.
Wait, but if you
because in between this range of 0 to 6, you fill in 1, it's gonna become 1 over 0, and that's bad.
But wait. I think if you fill in, yeah, man.
Just do it, whatever.
Wait. I think I got what
because I'm pretty sure you have to address that.
So officially, we would have to say the limit as x goes to, or x goes to 1 of the integral.
Yeah, and then plus
from 0 to x. Or let's use A.
Yeah, A, and then
blah 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 dx plus the limit as A goes to 1 of the integral of from A to.
What part is it in the book?
So you just got to do A approaches 1 to the left, so 1 minus.
Skip this part.
I don't know what page is it in the book because I just did it in.
No, you need to. Oh, so that's technically wrong. So essentially, what you need to do is you need a limit A approaches 1 to the left, and then a limit B approaches 1 to the right.
Yeah.
Right.
That's correct.
Yeah.
So this is like from the right, and this is.
Because now you use both A, and I don't know if that's could be confusing, but yeah.
So even if
it's basically the same. I mean,
they just a plus. Oh yeah, mine. Yeah.
Yeah.
Yeah. So this is what you would have to write down.
Yeah.
Okay.
That's what's gonna be the answer, because then you have to check if it's divergent or not, and if it's not, you have to make the sum.
Also, I have to. I still didn't fix this. This should be x minus 1. Okay, so
Convergent just means there's a limit, right? Or...
Well, you have to check if it's divergent or not.
Yeah, I'm gonna need like a bit of you guys' help because I didn't understand this lecture all too well. I do understand that, like, because we're filling in all the values, we're eventually gonna fill in 1, and that's gonna be an asymptote. We'll have to see.
Yeah, so you have to check if the left side is the same as the
right. Yeah, you have to check if it is the same from the right side and the left side. So if you get the same thing for you have to check if this integral with left and right is the same. So and that means that this exists at this point. So
so now we need to calculate the primitive. For sure.
And if we get like a limit to infinity or a limit that oscillates or something like that, we just say that it diverges.
Yeah. So if we do this, then we can say, okay, the integral of the fraction of 1 over u du. So that is.
Or we can apply squeeze theorem. We can apply, I think, squeeze theorem here. So we're gonna find.
I've never used that. I'm gonna be honest.
Well, I mean, if you find a derivative that is, if it's larger than this one, then we can just prove that it converges, because it is between two integrals, the one which is larger than this one and the one which is smaller than this one. The smaller, I think, will be 0 or something that is smaller than this integral here.
Well, I think this is the easier with detail because this is already the answer. But are there things where you can only use the squeeze theorem?
Probably, if there's no way for you to figure it out, then probably.
But I think what we're doing right now is better than the squeeze.
Yeah,
theorem.
for this one, I don't really see why you use the squeeze theorem, but there are others where you would definitely have to use it.
Yeah, in this case, if we just prove that these two integrals converges, we know that the whole integral converges.
Yeah.
So yeah.
Yeah.
But let's see, we eventually have to fill in. But is the ln of a negative number?
Yeah, that's bad. So the left side is bad because 0 is ln minus 1.
Yeah.
And then the right side is the right side. I don't know. I think the right side is okay.
Yeah, the right side is okay, but if the left side is already bad, then
I'm
it's
pretty sure that the
divergent,
right.
right?
Yeah, so I'm pretty sure it's divergent.
Let's go.
Yeah.
Okay.
And you wouldn't have known it if
we
you
did it
didn't
in the
split
right
it.
way.
Yeah.
Then we can say, okay.
And then the right side goes to infinity. I think the right side goes to. Yeah, and then the left side you swap them around, and then it goes to minus infinity. But it's basically the same. If you find that one side is just broken.
Yeah.
And
if one side is broken, you're like fucked anyways.
Yeah. Either you did something wrong or it's divergent.
Yeah. Okay, so let's do this one now. So
the only reason why I said you had to split is because I knew it was going to be divergent.
Okay, so this is an integral of type 1, right? And this is an integral of type 2.
Yes, I think so.
Okay, so now we will get this integral of of just e to the power of minus 3x dx. Okay, so that will equate to
minus
1 over 3, and then the same thing, or 1 over minus 3.
Yeah, the same.
And the same thing. Recompile, please. Oh yeah, okay. And we have to encase the minus 3x in brackets, otherwise it doesn't like that.
So it's gotta basically go to 0, right? E to 0 is 1, or is it not?
Well, let's have a look. So we have to fill it in from 0 to infinity.
Yes, so it's gonna be minus
1. This times. So we fill in. We don't really fill in infinity. We fill in x or a as a goes to infinity, but yeah.
Right.
And then minus, and this is gonna be.
It's gonna be
0. Or
okay, what's gonna be?
Hmm?
Yeah, but then the right side also needs to go times a third. I don't know if you have that. Can you print it out?
Yeah, there we go.
Yeah.
So this becomes minus 1, and e to the power of, and here we get e to the power
of becomes 0.
That limit goes to 0, so this is just minus a third.
Something a third.
So that is just 1 over 3.
Yeah.
Let's go. Ooh.
Damn.
Again, that we have to get the 3. So do you take u equals square root 3 then here?
Well, u equals to x divided by square root of 3.
Oh yeah.
Yep.
Although I think this one can be done in an easier way, but I'm gonna do it anyway because I wanna have it. I wanna try attempt it.
Okay, let's have a look at. Also, does somebody know, since this is an even function, can we just say that this is equal to 2 times the integral from 0 to infinity?
What?
Yeah, that's the theorem. So.
Well, I didn't hear.
You have even and odd functions.
If you have an even function, so for example, the cosine is an even function. If you fill in minus a, it's same as filling in a. With an even function, if you have a cosine going from minus infinity to infinity, or minus a to a, that's the same as saying 2 times the cosine of 0 to a.
But that only matters for these type of questions, right? Or could we have already technically done
that is only if the integral exists, and with these kind of integrals, like
we don't know if it exists.
So when did we have to use that? Did we have to use that the last lecture or something?
I don't remember.
So I can't remember using it in the class, but I remember it using it. I remember it coming by in the book exercises, but.
Can we rewrite it as integral of minus infinity to 0 of that thing was integral of 0 to infinity?
We don't really need to use it. It's just sometimes it's just simpler, but you don't really.
Wait, why the 0?
Okay.
Well,
I mean, it's arbitrary.
Yeah, we could say
Just-
we could say
just
0, we could
because.
say like 10, we could say whatever.
But I also wonder if the thing where
Well,
you
I
say
mean-
it's 2 times 0 to infinity, if that also works. Maybe we could try it.
Or let's do like the full thing. So let's say the limit as a goes to negative infinity of the integral of a to 0 of the fraction of, dude, I fucking, that mine.
Sounds like a lot of repetition.
Yeah, dx plus the limit as b goes to positive infinity. Like, I'm not gonna write it down in my notes like this, obviously. I'm not mathematical. Of the integral from 0 to b of the fraction of 1 over x squared plus 3 dx. So this is the formal way to write it down.
Yes.
And these are integrals we can solve. Well, I'm gonna say to solve this, I need to just solve the boundless integral. I don't know what it's called exactly, of frac 1 over x squared plus 3
Indefinite?
dx.
Wait, no, not indefinite.
Hmm?
Wait, no. I'm losing my mind a bit.
You're right, man. Need to call an ambulance?
No. Just a bit tired.
Same, honestly.
U equals to x times. I like how in 2 lectures we're done, but
Okay.
then we still have to. I'm still gonna do like 1 or 2 exams to actually put it to use, see if it actually works. Okay, somebody doesn't like the sound of that.
Wait, you're gonna do 2 exams. Wait, after this, you're gonna do.
Yeah, we're not finished after the end of the
No,
grasple. Then we're
obviously not.
switching to exams.
The practice exams like that they gave you in.
Yeah.
Like in the program itself, or just like old exams.
Yeah, no, old exams.
I should try those as well. I'm gonna try those myself though.
Are
there answers for those?
I'm not sure. I'm just gonna use.
You got Wolfram Elf. Should be enough.
Yeah.
What?
You can just Google the questions and then get the answer.
Wait, Google?
Oh wait.
Really? Oh, because they're old exam questions, so they're probably on the internet or something.
No, you just fill them in like a calculator, and then the calculator spits out the answer.
Oh yeah, well I've struggled with like Wolfram for some reason.
Yeah. So du is equal to square root of 3.
Do you guys have paid for Wolfram?
Okay, so.
You just wrote down the same. You wrote it in a double line.
Oh yeah, I copied a line too many times. It happens.
dx equals.
So then we get this, and then x becomes x.
I don't know how to go on from that, honestly. I'm kind of stuck.
Wait, we said u equal to x over x over square root of 3, so x is equal to
square root 3u
times u. So this will become u squared times 3.
Yeah.
Or let's say 3u squared, and dx will become square root of 3 du. So we say du times square root of 3. Let me actually put that into the top here.
So then where does the plus 3 go?
Good question.
Oh, yeah, wait, I'm stupid.
Oh, wait, yeah.
I sometimes forget like if you do times something and it's gonna go on top. And then...
Yeah,
and then, yeah.
What we can say now, if we can multiply by square root of 3 over 3. So we can say fraction of square root of 3.
Or just get rid of all the 3s.
Over 3. Yeah, okay. So when we have this now, we can take the bottom square root of 3 out of the fraction, so out of the integral.
The top one is going to become 3, right?
Yeah, and the top one is just going to become square root of 3 squared is equal to 3. Yeah,
So
now it's
took
all
it out
coming together.
completely. You just took it out completely.
Yeah.
Okay, so this becomes...
Alright, what did you change? The only thing that changed is that you added 1 over square root 3.
What do you mean?
But you didn't get rid of anything. Oh, no, you did.
Yeah,
it
then...
just takes a while to compile. And like whenever I enter, I like copy paste the line and then I start editing it. But sometimes it's still trying to like display the old line.
Bad computer.
Okay, so now this thing will just become the arc tangent, right?
Yeah, because it's now just 1. Yeah, you can just swap the 3s by 1s, yeah.
Yeah, so then the arc tangent of u is equal to x over square root of 3. So this will become the arc tangent of that thing.
Oh, okay, but I mean, we have an interval from a to 0, so I think we should put a minus because we subtract from 0. Then we have a, so it's like we have intervals. I think we should consider that.
Wait,
in this integral.
I didn't understand.
We have an interval from from a to 0.
Yeah.
Right. So that means this integral that we get in the last lines before transforming it to arctan, we should subtract, like from replacing u with these intervals. Like, we treat it like an interval without interval, like an integral without intervals. I mean,
yeah.
where we subtract the intervals.
What do you mean subtract the intervals? Well, we don't have to because now everything is back in the x world and we can just fill in x integrals. Like
now we do it.
If we wanted to, we indeed could have here said, okay, as x goes from 0 to a, or from a to 0, and then here said, okay, as u goes from blah blah blah, and then here say, okay, now we're changing it back to x go. But we can just skip that entire step by just saying, okay, this is the integral without bounds, and then in the end we fill in x over here. So we don't necessarily have to modify the bounds or anything, we just don't include them at all.
But hold on, doesn't that
don't include them at all?
Sorry.
Why don't include them at all? Like,
well,
why not?
If we say, okay, instead of the boundless integral, I do the integral from 0 to from a to 0.
Yeah.
Then I would here have to change that into the integral from whatever would it be, 0 from like a over square root of 3 to 0, yeah.
Yeah, it would have
and then
change that as well.
Back here when we were changing it back, it would turn back into the integral from a to 0.
Would it? I don't know that.
Yeah, because the relation between x and u never changes, and if we put something in x and then it becomes u and then it becomes x again, then it's just going to be the same.
Because in the answers, you can see that they change the intervals according to the substitution that you do. If substitution is, for example, u equals square root of x, they change the x. They put a square root in the intervals as well. So
if we made this a bounded integral, here this would be from a to 0.
Yeah.
Here it would be from let's see, it would be from a divided by square root of 3 to 0. That's going to be u.
Yeah.
And here it would go back from a divided by square root of 3 back to back to a and 0. It's just that if we wanted, we could take this in the u world and fill in a divided by square root of 3 and u. But now if we just have it in the x world, we can just fill in a and 0.
Yeah, that's better, I think, like more suitable, comfortable, for sure. Yeah, okay.
Yeah, so we could fill in the changed values here for arctan u.
Yeah, there are two methods.
But we can also just keep it in the x world.
Basically.
4 hours. I want to die.
Woo!
And that is including a like 30-minute break and some other stuff.
So when if you fill in minus infinity and infinity, won't it just cancel out and it just becomes 0? It
depends. We first have to check if they exist, but so So let's see. Let's fill stuff in. See if and how it works. So.
Because I can remember it not being 0, but in my head it's like.
We have the arctan of this minus the arctan of this. So the first thing is going to be the arctan of 0 minus the arctan of A, right? Yeah, up
Oh,
power
you
minus
split
0.
it up.
Oh, yeah, now you subscribed. Okay.
Oh, okay, yeah. If you split it up, then it makes difference.
Yeah, and then after that we add the same thing, but then for B and.
Yeah, then I'm wrong.
So this is gonna become B and.
Because they do have they have the zeros, so it's gonna be minus, plus. All right.
So we have 1 over square root of 3 of this thing. The arctan of 0 was that 0?
Yes.
Sick.
Yes. 100%.
So this is just gonna be. Wait, I can
0.
take away. Wait, let me first make a copy so that I don't mess stuff up. The arctan of 0 over square root of 3 becomes just this. We can get rid of this as well. Is this correct with like the amount of closing brackets and stuff?
The window is no small.
Let's see.
Didn't Stefan say there was like an actual symbol that means
Yeah,
close
just
all
as many closing
brackets?
brackets as needed. But I want to keep my shit precise in math. Okay.
What about the second interval? The integral, like we had 2 integrals, right, in the beginning.
Yeah.
What about the second one? This one, yeah.
This is the first one is this one from 0
Yeah.
to A, and this is the second one from B to 0.
Yeah, it's the same. Okay, yeah.
Yeah, these two are like the same integrals, it's
Yeah.
just a different bounds.
Oh, and then it becomes minus upon minus, and so you get. That's why it's not 0.
Is minus 0 the same as or the arctan of minus infinity is the same as the arctan of infinity? No, it's not, because the arctan of minus infinity is equal to minus pi.
Yeah. So it's gonna be. So the left side is gonna be minus, and then wait.
Yeah, but
now I'm really confused. Okay, hold on.
So if this thing is gonna be minus pi over 2, then this minus sign will cancel it and turn it into a plus pi over 2.
Why did you even get a minus there in front of the arctangent?
Well, it was at first arctangent 0 minus arctangent A, but the 0 just falls away.
Oh yeah, right. So it's just So
this arctangent of A over 3 is just going to become positive pi over 2, was it?
And then the right side is also going to be positive pi.
So we have.
But it was because it is an even function, right? So it's always 2 times.
Yeah. We could have known this, but.
Yeah, but we
just chose not to do that.
Yeah.
So if it's even, so you could do it really quick, but we just did it.
Yeah, but we haven't learned that yet.
It's just 2 times
it existed.
So yeah, and this is gonna be
2. So that is gonna be.
Or you have to do it times the 1 square root 3. Wait, 32.
Yeah, we already did that. So in the end, the 2 are. Let's actually keep it like this.
Where did they get the 32 from?
No, that's not 32. It's like square root of 3 times 2. So.
Yeah.
Oh, wait, he did it all of a sudden on both sides. I was like, hold on, did you try to correct yourself?
So let me see. Okay, so if we have it like this, but then if we do it twice, then we can just get rid of one of them, and then take this away.
It's gonna be
pi, and then pi over.
It's gonna be
pi.
A fraction of pi over
square
root 3.
Yes.
If this is not correct, I'm gonna scream. Let's go.
Let's go.
They didn't even simplify it. Wait, did they?
No, they made it more
simplified form.
What is simplified?
That looks worse.
Well, this is rational. This is simplified form, because usually you would want square root to be in the numerator, not denominator.
Yeah.
I think our answer looks better, but
it's called a rationalization.
1 over x and an x. Well, I'm pretty sure that if you take the derivative of x, it's going to be 1 over x.
U is equal to ln x, and this is just u to the power minus 4. So we're going to end up with
1 over x. No, nothing. Go on.
So we're going to end up with u equal to the u is ln 4, or u equals ln x. We have u to the power minus 4, so that's going to be the fraction of minus 1 over 5 ln x to the power 5, and we fill in the stuff there. Do people understand that?
Yeah. Well, can you repeat again?
It's gonna be 1 over
so
u to the
I
power
did
4.
I did a u substitution in my head. So I said, okay, ln x is u. Then the derivative of ln x is going to be 1 over x, so we get rid of this one. So all we have done is
No, I think you went the wrong way,
power 4
right?
du. Hmm?
It's because it's -4 and it's a primitive, so it goes to -3.
-4.
It's going -3.
Minus.
Yeah, it goes
So
-3
it is
because we're in the
-1
negative.
over 3 times ln x to the power of 3.
No.
Right? Because
this is minus, by the way, but no, because
the primitive goes up, right? It goes to 0.
Wait, now that you mention it, excuse me. Yeah, you're right. Okay, cool. I keep messing that up. Thank you.
Yeah, I do the same. I just.
Oh yeah. No, it's yeah.
Yeah.
Let me just put little neat little brackets around there.
Little me.
But the question is, ln infinity just goes to infinity, right?
I think so.
I think so. What?
Yeah, probably.
Okay, cool.
Really slow.
ln infinity goes to infinity, yes.
ln infinity goes to infinity. Yeah.
It's not the IV.
Well, it's 1 over ln.
Oh,
0.
yeah.
0.
Okay, yeah, I forgot about this minus sign. That's a good one.
Maybe.
So, we get negative this thing, and then we're gonna get the ln of infinity. Not really, but we're gonna say it is, and then minus the ln of e to the power of -3. I forgot closing bracket, didn't I? Sick. Okay. Well, we know the ln of e is equal to
1, right?
Yeah, 1, and 1 over 1 to the power minus, or 1 over 1 to the power 3 is 1. So we're going to end up with this, and then the ln of infinity to the power of -3 is a really big number to the power of -3 is 0. So we're going to end up with -1. These two minuses cancel, so the answer is 1 over 3.
Wait, so what happens to the ln? It becomes 0, you said?
Well, the ln of infinity, it becomes infinity. But
Yeah.
we have infinity to the power of -3. That's equal to 1 divided by infinity to the power 3, which is 0.
One divided by
So
ln e is 0, or
yeah, this thing is 0. This thing
no,
is
ln is e. Okay, just 1. ln e. Yeah.
If I do 100 million to the power -3.
Yeah, that's going to be 1 divided by 100 million to the
Oh
power
yeah,
3.
that's super close to 0.
Yeah.
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 Alright, so I number to the power, and if it's to the power -4, it's going to be the same, right? But then even lower, technically.
Yeah. Yeah, but like 0, like 1 divided by infinity and 1 divided by infinity squared, still the same.
Yeah.
Let's
So
go.
then,
I like how they like grounded it. Okay. Ooh.
Okay. It's minus x divided by 5. Is that a z?
Yeah, I can't even
That's a
see.
5.
Minus x over 5, I think.
So that is e to the power of the fraction of x divided by 5, or minus x divided by 5. So let me make that big for you guys. This is the thing we're integrating.
It's gonna be minus 5x to the power -1. So it's gonna be.
Yeah. So the derivative of this is equal to.
It's gonna be 1 over 5e.
Yeah. Okay. So this is
minus 1 over 5.
Minus 5. Yeah, minus 5 times this. So this is the derivative, because this is the same as minus 1 over 5 times x. So then we just multiply by the reciprocal.
Yes.
Okay, I'm gonna cancel these two. Oh wait, that's not. Oh, not quite what we have to do. Let me put some brackets around here. So we have this upper bound minus lower bound. The upper bound here is infinity. The lower bound here is 8. But here again we have. let me actually make a little neat, like infinity.
So it's going to be -5 times e.
Yeah, so here we have
minus infinity, which is
e
it going to be really
power
close
of
to
a
0,
minus a really
or?
big power? So this is the same as saying 1 divided by e
Yeah,
to the
that's
power
gonna-
of infinity minus 5, so this is just going to tend towards 0.
Yeah.
So this is 0 minus. We'll get rid of these two minus signs while we're at it. So then this is the answer. And I don't know if we can simplify any further, but I really don't want to. So we'll get a 8 over 5. Let's go.
Nice.
Ooh, okay. Consider or determine whether...
Wait, why is there a big white cap? Fuck happened? There's enough space. Like, put that one to the right and the other one up.
Oh, this one, yeah.
Yeah.
Okay, so this is an improper integral of the...
Let's see.
Of the second type. Or...
And the first, I think, because it goes to infinity, and if you fill in 2... Oh no,
yeah,
because
it doesn't go to 2.
2 is not in between the range. 2 is not in the range. So
Wait,
it's only the first,
was
right?
the first type, was it like to infinity, and the second type is it as an asymptote?
Yeah, I think the second one is that it's in between the range.
Wait, what is the first type and the second type? So
the first type is if one of the two numbers is infinity, and the second type is if or for any of the values in the integral, it goes
wait,
to...
I can't hear. Yeah, someone was talking over.
Okay, so the first type is if one of the two is infinity, that's an improper integral, and the second type is if there is like an asymptote inside of the range of the integral. So here, if we would fill in either 2 or -2, then it would be an integral of the second type. However, this goes from 7 to infinity, so it's only of the first type.
But if it is wrong, it's going to be the other way around. But
yeah, no, but it's correct.
Yeah, right. Yeah.
Okay.
And to be explicit, vertical asymptote. So we're looking at vertical asymptotes. So that's why we look at the denominator. Yeah.
Yeah. And here the same thing happens because...
No, because now it's the...
here's both of them, yeah.
Yeah, it's both of them.
Because square root of 4 squared is this.
Yeah, this 2.
So
No, I think that one.
Second type. Ooh.
And then...
this one, this is not improper. Because for this to be an improper integral, this has to be either 2 or -2, but it's only -1 and 1. So all the values here are just good. I like how confident I am, and then I press the button. I'm so afraid it's going to be wrong. This is an improper integral of the second type, because the value of +2 is inside of this bound.
Yeah. And then the last one.
This one is also a of the first and second type, because one of the numbers is infinity, and also 2 is within the range.
Yeah.
6.
3 points. Woo.
Okay.
We won't get those questions, I think.
Hmm?
I don't think we'll get those questions on
No,
that.
that would probably be too easy for the exam.
So this is going to be -3rd e to the power -3x. And then...
Okay, so the integral will be minus...
0
minus... Yeah, and
minus...
then minus...
Yeah, right. This one's really...
So then we can get -1/3 times e to the power of the top one minus the first one. So this is going to be e to minus infinity. Oh, infinity.
It's going to be minus infinity, right?
Yeah, well, 3 minus times 3 times infinity, and this is going to be minus.
Yeah.
3 times 1. So then we know that e to the power minus infinity is equal to 0. We have here e to the power -3. So this is gonna go away. We have two negative signs there. So this will go away as well. And then we just have 1/3 times e to the power of -3. So that is 1 over 3 e to
joining and leaving, by the way. Yeah, I have that as well.
Yeah. Okay.
So now there's only 10 left, right?
No, because I think we also have for 9.
No.
No.
10 is like I said.
Split, yes.
Split, we did it.
One more.
Yeah, you were the person who said that I didn't have to have another one. You were right.
Yeah, that was me.
Yeah,
the 10th one, we might speedrun this, like.
Speedrun the end.
Yeah.
For which p part of R does the limit of n times ln of 1 plus n to the power p exist for a real number? So the ln of infinity over infinity, we can solve that using L'Hopital. Infinity times ln 1. ln 1 is just...
ln1 is 0, I think.
Is it? Yeah, ln 1 is 0.
Yeah.
So this is going to be...
I can recount it for you. Let's see.
Hmm.
No, wait.
So I think if it is...
So I'm pretty sure it's p is lower or equal than -1.
Yeah, this is like a learning thing. I did not learn this.
Yeah. So. Yeah.
Who did? We're like 15 people. Someone must.
Someone must have learned this.
Yeah, it's p.
It's p smaller than -1.
Or equal. Oh, wait,
equal. Never mind.
Yeah.
SMH, you ruined.
That's what I said.
Okay. Like, can you explain why?
So basically, n to the power -1. If that goes to infinity, then that becomes 0, right?
Yeah.
So then you just have ln1, and that becomes a real number.
Oh.
All the other ones, you'll have an infinity number, or it doesn't exist. I'm pretty sure. And so technically, p lower than -1 is correct as well, because it doesn't matter which one you do. Like it could be -500. Doesn't really matter. But the thing is, they wanted all of them, so that's why it had to be equal or lower than -1. And I don't know if that makes sense, but
it makes sense.
It kind of does. So it's like you have something that has a power, and for this power, you know that as it goes towards infinity, it will either go towards 0 or towards infinity.
Yeah. So if infinity is to the power of a minus, so like -4, then it'll go to 0. So it needs to be a negative number for 0.
Isn't it? Because if p is negative, then n to the power of p will always be 0 if you go to infinity.
Yeah, and that way you get rid of the infinity in that formula, because there was an n in front of it, and well, if you put n is -1, then it's going to be -1 times ln1 plus infinity to -1, which is ln1 plus 0. So you have -1 times ln1, which is 0, and that's a real number.
Yeah.
And in all the other cases, it's probably going to go to infinity. Like if it's
you would have infinity multiplied by ln1, because n goes to infinity, and you have n multiplied by ln. You have infinity multiplied by
ln1 is 0, so
and 0 multiplied by infinity. Yeah, okay.
Yeah, I'm sorry, I said -1, but I meant infinity for the n. Yeah.
Okay. For the following limit,
You better finish within a minute so we get the 420.
Oh, let's go. For the following limit, give all value to p part of the integer such that the limit is equal to 0.
You can get rid of the n to the 4th plus 4n to the 5th.
Yeah. So basically, if it has to be 0, then the top part, like the bottom part, will have to have a bigger exponent than the bottom part.
Yeah.
So
it has to be at least, or at most. Well, it has to be
so it's
less
5.
I think it's 6 or 1 over 6.
It's maximum 5. Minimum.
If it's 6, it's 1.
No, 5.
No.
5. Yeah, 5.
But it has to be.
Never mind. I think it's
6.
Oh wait, no.
Oh wait. Yeah, less than 6.
It's 6. It's 6.
Yeah, 6 because it's less than. Yeah.
And it has to be strictly
and
more
then
than
minus
0,
infinity.
Right?
Minus infinity, I think.
4 seconds.
Minus infinity.
Let's do it.
Minus infinity.
No.
No.
I'll see if you guys are correct. Yep, nice.
Okay.
We were like
But is it even an integer?
Well, it is part of zeta.
Okay. Yeah. Yeah, I don't
For
really.
which p part...
Wait, hold on. Oh, because we had one wrong.
Oh yeah.
Yeah, no,
it's equal.
It's the same one. It's the same one.
-1 again.
You have 25 seconds.
Yeah, it's that one.
Split.
Go.
Twice. Split twice. 420.
420, 30. Woo!
Not even 0.60.
Yeah, not even 6.
It's too bad we can't verify
would
that
you even-
Theorem.
Well, I mean, if somebody wants to voluntarily moderate and do this entire thing. Well, I mean, I split this one wrong, anyways.
Yeah.
I'm gonna be honest. I think you'll be the only contestant. So.
Yeah, but that means that we can collectively own 2 world record on
I was about to say
speedrun.
this is a world record, guys.
Well, what is the other one?
Okay, so we're gonna do 2018-19 test 1 and test 2. So there are quite a few questions. We're probably not gonna make it. We're starting at 5:30 or 4. So we're probably it starts out well if I can't even read my fucking clock. But we're gonna see how long we'll take. But these are like longer than. Yeah, these are like 2 hours total. We only get like what is it, 1.5. So we'll see. Okay.
But it's 1 hour, right?
Both of these exams are both 1 hour, so in total they're 2.
Oh yeah, okay.
Okay, so let's start out. Find the derivative of arctan of 1 over x. So we have arctan of oh my god, 1 over x. Well, the derivative of arctan is 1 over your own fraction or your original function squared, or 1 over 1 plus your original function squared. Excuse me. However, we also have to multiply by the derivative of 1 over x. And the derivative of 1 over x, well, that is 1 over 2x. Or, sorry. So, we have this times the derivative of 1 over x. So, 1 over x derivative. And the derivative of 1 over x is, I think, just ln x. Oh, wait, no. That's the integral.
Minus 1 over x. I think. Yeah, minus 1 over x.
It's a minus 1. Wait, but wouldn't it be... Wait, the derivative of x to the power minus 1 equals...
It is equal to...
x, is an x squared.
Yeah.
1 over x,
is,
negative 1 over x squared.
Yeah, okay, so it's minus 1 over x squared, right?
Over x squared.
Yeah.
I mean... yeah, that's true. Sorry, my bad. It's minus 1 over x squared. Yeah.
Yeah, okay, now we're good. So...
Wait, are we timing it?
Well, yeah, but we started at like 30 past.
Okay.
I can start a live split if you guys want. But basically this becomes 1 over x squared times 1 plus 1 over x 1 over x squared. So this will eventually be equal to x squared plus 1. Oh yeah, and get rid of this bracket. Okay. My layout is fucked up, but I don't care to change it, so... The eventual derivative of this should end up being... Wait.
I think we have minus. Like...
Yeah, it should be minus...
yeah.
Yeah, minus this thing. So, our answer for 1 is minus 1 over x squared plus 1. Okay, cool, so let's start with 2. Let me actually say... Can I do that without it complaining? You probably won't be able to see it because it's on the left here, but yeah. So this is going to be the answer for assignment 1. Okay, consider the function f from 0 to a to the real numbers, given by f of x is equal to 5 minus x squared. Find the largest positive a such that f is invertible on the thing. Well, that's the situation I drew out earlier. So we will just have to find the value, or like the maximum of this parabola. So it's going to be equal to negative a over 2b. In this case, a is negative 1, so that's positive 1, over, and b is going to be 5, so 1/10. Yeah. So in this case, we say a is equal to 1/10. Assign.
Can you write a little bit of intermediate steps for this? Because you just wrote down 1/10 and that's it.
Well, sure. We can say a is equal to. The only real intermediate step I can think of is, well, let's just say in this case, minus a over 2b, because that's the part where the parabola has its maximum.
Yeah, that's.
And then you just fill it in. But the thing is, there's an a here now and an a here, but those are like two different a's.
Yeah.
But yeah.
Call it a and a second.
Yeah, like we'll call this a subscript x and b subscript x to say these are the ones from the original function.
Yeah.
But yeah, we just fill that in. There's not much mod to go there. You just have to know that to find the place where a thing is invertible is until the maximum of a parabola.
Yeah.
Okay. Simplify the expression, i.e., write without inverse trigonometric functions. Well, we have the arcsine of, let's start with a. We have the arcsine of the sine of 3 over 4 pi. But let's see, the sine is on the top half, so it has to be either between pi and 0. So I think this is just equal to 3 over 4 pi, correct? What do you guys think?
What's the answer? Oh yeah, that's true.
Yeah, because it's just already in the interval where we want it to be.
Yeah, arcsine, yeah.
Yep.
Okay, then we have the cosine of the arctangent of 1/3. Well, then we can bust our little triangle.
Wait. Isn't it like that? Wait, no. I thought like the bound was minus 1 over pi over 2 and then something like that.
That depends on which function it is. Let's have a look actually. So imagine we have the unit circle. That's a big ass unit circle.
It's the arc. Yeah, I don't really know the bounds.
So when you're looking at the inverse sine, the sine is this line. So this is sine of x. This is cosine of x. And so the inverse sine of x will return something in this half. So between 0 and pi.
Okay.
And in the same way, cosine will return something within half and negative pi half, or a half pi and negative half pi.
Makes sense.
Okay, so then we have the cosine of the arctangent of a third. Well, let's go over here. We have the arctangent of 1 over 3, rise over run, and this is equal to the square root of 3 squared plus 1, that's square root of 10. So then to get the, what do we have to get again?
Cosinus, I think.
Yeah, we have to get cosine of that. So that is 1 over square root of, wait. So that's 3 over square root of 10, yeah. Frac 3 over square root 10. Okay. Assignment. But if at any point you think I'm making a mistake, just tell me, because I'm not very smart. Consider the relation xy squared equals to y to the power 3 plus 12. Find the IDX at the point 5,2. Well, okay, let's start. So we have.
Is this y to the third power?
Yeah, so it's xy squared plus equals to y to the third power plus 12. Derivative of both sides, they get 2y squared times the derivative of y. Other side we get 1 times the first part plus x times the derivative of the second part. That's 2 y prime. Okay, we can fill in the point x is 5, y is 2. So x 5, y is 2, so this will become 2 times 4 is 8. X equals to 5, 2y becomes 4, so this is 20. Y squared is equal to 4. So we have this function, carry it over to the other side. We will get equal -4. We subtract 8y prime from both sides. We get 12y prime is equal to this. Or actually, let me change this up so that they're all double dollar signs, because otherwise we're not gonna be able to see it properly. So redo, yeah. Okay. Okay, so far I think we should be good. And then this should be -4 divided by 12. So that is equal to 1/3. So the dy dx is equal to -1/3. Let me write it their way real quick. dy dx isn't a fraction. Yes, it is. Okay. Find, if possible, the limit as x approaches 0 from the right of arctan of ln of x. Also, these two are not possible. Are also possible answers. Well, the ln of x as x approaches infinity from below or from the right, that goes to -infinity, right?
Find if possible.
Yeah, because like inside of a graph, that would look like I think something like this.
Yeah.
This would be a function of ln. So we approach -infinity, and the arctan of -infinity is pi over 2. So that is fraction pi over 2. Oh, I just realized I'm actually going to be making this exam on my laptop, because I'm not going to give those privacy leeches access to my main desktop. So I won't have any issues with my keyboard either. That's going to be sick. I just remembered I muted that guy like really long ago. Oops.
Yes, you'll be able to speak in 5 minutes.
Yeah.
5 hours later. Okay.
Okay, assignment 6. Find all horizontal and vertical asymptotes of the function blah 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 blah. So horizontal asymptotes, that goes like this. So that's when we fill in x is infinity. So first I'm going to start with the vertical asymptotes, because I find it a lot easier. 3x equals to 0. Ooh, this is an interesting one. 3x equal to 0. Therefore, x is equal to 0. But if x is equal to 0, we have 2 minus square root of 4 plus 0. So that's 2 minus 2. That's also 0. Therefore, this I think this should be a hole in the function instead of an asymptote. So therefore, this function should have 0 vertical asymptotes.
Right, it's just one value that's not defined, but
Yeah, exactly.
Wait, but
it's continuous.
Hmm?
Like assignment. Go.
Okay, Rolo, you go first.
The word would be continuous, right?
Yeah, but it's not
if there's like
now.
Wait, because there is one value that's undefined. I'm a dumbass.
Yeah, so it's not continuous, but that doesn't mean it has an asymptote.
Right, yes.
Okay, cool. And now here, if we fill in, if we divide everything by x, so let me get the fraction of 2 minus square root of 4 plus x squared over 3x. We redo that. Where? Oh, there it is. So if we divide everything by x, we'll get 2 divided by x minus square root of 4 divided by x squared. Let me actually do that in proper notation. 4 divided by x squared. plus 1 over 3. And this is going to be 2 over x. So if we divide everything by x, this is what we get. But the thing is, here, if we fill in x goes towards infinity, and this is equal to 0 minus 1 square root of 1/3, so that's minus 1/3. However, if we fill in negative infinity, does something change?
Yeah.
I think no, because x is denominator, which is 0 always, so it doesn't change.
The way I like learned it was like if there's a square root, I think it should be like a minus sign there.
No, it's a square.
Whenever you do like,
it always goes like it goes to 0. Doesn't matter if it's 0 or plus infinitive, I think.
Well, but even then, if this were to become -1, then there would be then it would be a asymptote in the imaginary plane, because we would end up with 0 minus 1.
No, 0 plus 1.
If this x becomes a negative sign.
Because we divide.
Another thing with assignment 5, it is like it goes to minus infinity, right? As you did a graph. So then the arctangent is minus pi over 2.
Wait, for 5 you mean?
Yeah. Like you draw the graph
that's like this should be negative pi over 2. Yeah. I thought I put that down, but I forgot. My bad. But yeah, this one, should this have 1 or 2? I'm gonna go with 1, and if it's wrong, we're gonna have a long look at Wolfram Alpha as to why it's wrong. Because I'm not gonna get any answers. Okay, assignment 7.
Wait, did we do the... Okay.
Hmm?
No, it's...
Okay. If possible, find the limit of x goes to 0 of ln of 1 plus x squared over 1 minus cosine of 3x. Well, cosine of 3x is equal to 1, right? Or like the cosine of 0.
Yeah.
Yeah.
Okay, so then we get 1, and the ln of 1 is also equal to 0, so this is just going to end up with the form 0 over 0. Therefore, we can apply L'Hopital! Exactly. So 1 plus x squared, and then we have 1 minus cosine of 3x. Okay, if we use L'Hopital, let me scroll down a bit so you guys can actually see my stuff. Oh, yeah. So the ln of 1 plus x squared, if we take the derivative of that, this is going to become 1 divided by this stuff times the derivative of this thing. So that's going to end up with 2x over 1 plus x squared. And then this 1 is going to fall away. This cosine is going to turn into a negative sign. That's going to cancel out with a negative sign. Haha, negative sign. And then we have a 3 in front of it here. I edited the wrong one, but that's okay. Okay, so now if we recompile. Yeah, this seems correct.
Can you move out constants from limits?
Mm-hmm.
Okay.
Yes.
So you can if you look at the limit, you can put 2/3 out of this limit now. Because 2/3, 2 over 3, you can put out of the limit.
So wait, we have this fraction divided by this.
Would
it be the same as multiplying the top of this fraction by this?
Yeah, like you have 2 times x, and you move this thing down in the denominator. The denominator
okay,
goes
so you move it down.
down.
Okay.
Yeah.
Yeah. Okay,
And I was asking if now we can move
I
2
was just not
over
sure
3
about-
out.
Yeah, I'm just not sure about that step, but when it is like in a neat form like that, you can totally move it out. Yeah.
When it is what?
Like when it's like this, you can like when it's just one fraction, you can totally move that like one form out. So 2 over 3.
I see. Yeah, you can always.
Are we applying L'Hopital again?
Now it's
For
0
numerator,
again.
we have the ln of 1, which is 0, and 1 minus 0, or 1 minus cosine of 0, which is 1 minus 1, which is also 0.
Oh wait, we're plugging in 0. Okay, I thought we were plugging in infinity. I was like, what?
No. Yeah, that's a good point. Let's get out 2 over 3, and then simplify our thing here a bit. Okay.
Okay. Yeah, exactly. That's what
Now if
yeah.
we fill in 0 here, we get 0, and if we fill in 0 here, we also get 0. L'Hopital again. Let's go. Well, the top is going to be quite easy. Yoink. Bottom is going to be a lot harder. Well, not a lot, but a bit. So we're going to start out with... so let's start out with this one. So we'll turn this into sine becomes cosine. And we also multiply by 3. And then we add the sine of 3x times 2x. Yeah, I think that's correct because we do the differential of this times that plus the differential of this times that. Yeah. Now what happens if we fill in 1? We'll get, this becomes, oh wait, yeah, we fill in 0, sorry. So this becomes 3, and this becomes 0. So let's actually fill that in real quick. So the cosine of 0 is equal to 1. So this becomes 3. This is 1 plus 0, so this will also just become 3. And a sine of 3 times 0 is just equal to 0. Same as 2x, obviously. So we will end up with 2 over 3 times 1 over 3 equals 2 over 9. Agree?
Yeah.
Sick.
Wait, what you do? Like on the last step?
Okay, so in the last step we just filled in x equals 0. And then this becomes a 1, this becomes a 1, so we get 1 over 3. And this becomes a 0, this becomes a 0. So that's just 1 over 3 times 2 over 3 is 2 over 9.
Yeah, I see.
Okay, sick. So that was assignment 7, assignment 8. How many questions are... Oh.
There are only... Wait a minute.
Wait, guys, we're speedrunning this. What the
Yo,
fuck?
we are gonna do 2016.
I mean, it is true that we are like 10 people who have been doing the grasple exercises up to now.
Yeah, well, like, we spent 5 hours on this so far, so... But that's still insane!
Yo, what the fuck?
Okay, consider the function f given by f of x equals to x to the power 3. Find the linearization of x at 2. Well, that's just easy. That's like the thing we did at the beginning.
Yeah.
So let me first find the formula by heart is fx equals f of a plus f extent of x.
Of a.
Of a, yep, thank you. Times a minus x. So therefore, we can say f of x, or in this case it should be L of x. Because it's the linearization of x.
Wait, was it x minus a? Or wait, I don't know.
It is, I think it's the answer we get minus, wait, no. Yeah, no, it's x minus a, thank you.
Yeah, okay.
Eventually, you'll figure this out, like, if you mess that one up, you'll figure it out on the exam as well, because you'll get, like, a negative answer where you shouldn't have, and it's like,
Oh, okay.
But, yeah, it's a good thing you noticed. Okay, so f of a, so that's just minus 8. So L of x is equal to minus 8 plus, and this, wait, is it f of a or f of x? F of x, right?
This is f of a.
A,
yeah.
yes, because there's only one x. Only one x. That's the thing I should remember.
Yeah.
Okay. So if we have x to the power 3, that's like 3x squared. Fill in minus 2. That is 12. So it is minus a plus 12 times x plus 2. So this is going to be the answer then. We can even simplify it a little bit more so that it looks all nice and pretty. So that's going to be 16 plus 12x.
Yep.
But, oh yeah, because when you fill in -2, this becomes 16 minus 24. That becomes -8, which is the answer we want. Sick. Assignment 9. A square has edge size R and area A. Suppose A changes from 81 to 80. Use differentials.
Oh.
Ooh, this is interesting.
Yeah.
So first of all, we get...
Okay, so that's linearization.
No, that's not linearization. This is...
No. That
Differentials.
is the change. Yeah, the change.
Okay,
We have to estimate what is the
we know
change.
for a fact that dy, or dy over dx is equal to f accent x, or so the derivative of x.
Yeah.
We've been given a few things, and in this case, let's say we want f of the capital of the small r. So then we have a is equal to, and then what should that be? 2r squared. Yeah, because it has a edge size r. I thought it said like radii r. I was like, why are you doing that? But yeah, we have a equals r squared because the area of a square is edge size r squared. Yeah.
Then dA will be the change that is happening, like the differential.
Yeah, so this is going to be dA over dr.
Yeah.
It's going to be f accent of r. So we know our change in r, so dr is 1. Yeah, is 1. And we can also multiply on. By the way, can you guys see what I'm writing here? Yeah, right.
Well, it's a little small, but yeah.
Yeah. Okay. Cause like, I'm not writing it in a form LaTeX likes. But we can multiply here by dr on both sides. So let me actually put this in like this. Maybe LaTeX even likes it, if we're lucky. Okay, yeah. So this is all we have so far. We have dA is equal to f accent of r times dr. We have a is equal to r squared. From there it comes that dA is equal to 2r dr. Or we should...
dr is 1, I think.
Yeah, because like this is exactly what we were saying here as well. So we have dA is equal to the derivative of r squared times dr. So this is correct. Well, we know that dr is 1, so we can fill in 1 here, and we know that r that's the original size, right? Or well, wait. First of all, I made a mistake. Dr is actually -1 because it changes from 80 to 81 to 80.
Yeah.
And
actually, yeah.
The r is indeed the.
Wait, A changes from 81 to 80, right? So.
Yeah.
Oh fuck.
So not dr.
No, dr. A changes, not dr. To make it seem like the size changes.
All wrong. So while everything we said so far is correct, it's just not going to help us.
Yeah.
So if we change this into a function of a,
this
into dA, and this is going to be dr, then we can write this as r equals to the square root of a. Okay, we can say dr is equal to -1 over square root of, that should be square root of a instead of square root of 2. So this should be the fraction of 1 over 2 times square root of a. And then times dA. Well, our difference in a is actually -1, so we can add a negative sign in front of here. And our original area is 81. So this is... So therefore dr is equal to 1 over 2 times square root of...
And this is 9, so minus 1 over 19.
We can change this into like
18.
3 squared times 3, so this is going to be 6 square root of 3. So this is going to be the estimated change in...
But isn't square root of 81 9? It is.
Yeah,
so
it is.
2 times 18.
Minus 1 over 18.
Yeah, okay, that's fair. Oh, you said you could leave your answer at a fraction. I was like, what? So I assumed you had to leave it in a root form. But no, this is indeed a lot better. So we have negative 1 over 18. Oh my god, I forgot to close it. I didn't forget it, but sometimes it just deletes 2 of them instead of 1. Can I get my answers, please? There they are. And assignment, there we go. So and actually, theoretically, we shouldn't be using dr. We should use the delta sign, like a triangle. Because dr is defined to be infinitesimally small. And delta r is a measurable change.
So where should we put delta instead of dr?
Everywhere.
Everywhere.
Yeah, but we I don't know how to do the delta sign, so I've been using d. But theoretically,
I mean, they would want us to see our solutions, so I guess we need to learn that.
Yeah, no, like basically they only ask you to estimate corresponding change in r, so we can just say our answer is minus 1 over 18, so we don't really have to write down anything other than that.
Really? But I thought for the exam they're gonna check our solutions as well.
Mm-hmm.
So yeah, I mean,
they're not gonna check out our solution or our way to get to the solution, only the actual solution.
Yeah, they don't care how we get there apparently.
But why would we have to upload our paper that we write on? Like, we have to scan that and upload it to some place on Brightspace.
Because they see you writing somewhere and they want to check you're not doing anything illegal.
Yeah.
Wait, do you have to scan your writings? Wait,
yeah.
For calculus?
Yeah.
Oh, okay.
But they're not actually gonna read all of your things that you write. It's just it's an anti-fraud measure.
They're just gonna check that you're actually calculating.
Okay.
Yeah. Okay, guys.
But the way you calculate, don't give a shit.
Yeah. Yeah. I see.
Okay. So, wait, what was my key again? Oh wait, I can just stop it now. So 29 minutes for our first exam. Let's see how
a bit more because we started the timer later.
3 minutes past, so a little bit more. Let's see how we did. So this is exam 1.
But that's the power of like 10 people, you know.
Yeah. Obviously, don't expect yourself to get these answers as quickly and with the same accuracy.
I mean, we'll get other questions.
I mean, actually, even the accuracy, we don't know if we succeeded or if we messed up.
Okay, for the first one. Negative 1 over. All right, correct.
Wait, it's negative 1. Yeah, okay.
The answer. Oh my god, I'm dumb. I said negative a over 2b. It's negative b over 2a.
Ah. Well, oops.
Oh yeah, that's actually true. I should have noticed that.
Yeah,
you did the device the wrong way.
Yeah, oops. Well, I mean, if I would have given it more thought, I probably would have got this right. Like, on an actual exam, I'm gonna go past my answers.
I mean, we're gonna go back through the answers at least.
So we would have gotten this correct, but I'm gonna say it's not correct for now and see what we get out. So the answer is what?
For 3, what is the answer?
For 3, they have. Wait, why?
Oh yeah, it's still that. Yeah. So it is the bound is that like minus 1
but
over 2 pi. I don't know. Wait, where can you find all these formulas with the bound?
I don't know, because I thought this would be correct. We must have sine y. Just... Well, that sucks. This one is correct though, but yeah.
I think if it's sine and then arcsine, then it will be like that.
Yeah, but this is
Yeah, try to do it with the triangle method and see if you get the same answer.
Well, with the triangle method, it's going to give us the same answer.
3/4, which we got.
Yeah.
Or 1/4.
No, it's going to give us 3/4 because the triangle method doesn't account for any of the bounds. Yeah, no, this is interesting. We're gonna
that becomes a risky method. Now it becomes not method which is not always.
We made other mistakes as well, because here it says this is 1/2 and we have 1/3. So let's find where the mistake was. 4 plus... Okay, this part we had correct. Right? Yeah. Huh?
I got -1/2, but I thought I made a mistake. But Pan did not.
But then I probably did. Wait, why is there... 2 times... Wait. Oh my god.
3 times, yeah.
It should be 3 times.
Yeah.
Yeah. This is why you go over your answers. It's just that we didn't do it this time.
Yeah, and we were pretty tired, I guess.
Yeah. Okay. So we would have gotten this one correct again? Okay, the answer is, well, we know that this and we know that this. Okay, that's correct. That's sick.
Yeah, so like we should do plus and minus for the other one.
Yeah, so here they said, wait, for which one is this? 6, assignment 6, that is, yeah, we said 1, but they do plus or minus. Let's see. So what did they do? So here they say, yeah, here they get, oh, I see. Okay. So what they do is they make it so that you have the thing inside of the fraction in the form x squared times whatever the fuck is in here still. And then dependent on if you're filling in a positive or negative number, that becomes negative x or positive x. I see. Well, okay. Now that's actually really good that we did that, because now I actually
Yeah, I don't really understand it, like how it's done, but I just know it, like.
I understand how it's done. Let me actually see. This is assignment number 6A.
No, I understand it, like why it's like this, but no, like when I see the calculations here, but I just don't know, like
on the exam, you wouldn't think about it, Nestle.
Yeah.
No, but this is something we actually stood still next to, but we weren't sure about how to approach this. But now we do.
Yeah, I know that it's only for like I only do it when there's a square root, but I don't know like when, like for what else. Like,
okay,
I
so
we should do a minus sign when there's a
in
square root.
theory, like for the people who don't get it yet, so this is still the original function. Let me recompile it. Yeah. So what we do is we get x squared out of here, and then this becomes fraction of 4 divided by x squared, and this becomes 1. So for now we haven't divided the entire fraction by anything. We just have we just divided this, and then if we fill in a negative value for x here, that means when we get it out, this is going to turn into negative x times this thing. Because it doesn't matter what we fill in here, it will turn into a square root of x squared anyways. But when you're getting it out, it does matter what gets out.
Oh, yeah.
So when x here is a negative value, you get a negative value out of here. And when x here is a positive value, you just get a positive value out.
And you have to make it negative again because...
Yeah.
By the way, grasple was recorded. Is this recorded?
Yep.
Okay.
I'm just going to throw it all together in a bit. But yeah, so there are two different different values. One for where this is positive, one for where this is negative.
Yeah.
Okay. Here they say there are no vertical or horizontal asymptotes. Yeah, we have B0, so that's good. So wait, what did they say? Okay. Yeah, okay, so they just say, okay, if you use square root trig or L'Hopital, this will just be a number and not infinity, so therefore it is not an asymptote. Okay, for 7, we have 2/9. Hey, that's correct. Yeah, and that's we also had that. Yeah, we just did it in a different way, but our way is correct as well. Okay, final linearization. So that is, yeah, they have 12x plus 16. Let's go, boys. And there they had -1/18. Let's go, boys. Oh, and they also use D, so that's totally allowed then. My bad.
Oh, okay.
Wow, that's sick. So we made a few mistakes, but all in all, let's actually see. So we made a mistake in
6B.
6B, so we had this one incorrect. Or no, we had this one correct. This one incorrect, 6A.
Also B, because on B we wrote it, the answer is 0, but it's actually doesn't exist.
Well, no.
So
for 6B, that's this one, and they just say, okay, that's 0.
Yeah, but so it's 0. So there exists vertical.
They say there is a candidate at x is 0, but that is not a vertical asymptote. And we were asked how many are there. We said 0, so that's correct.
Oh, I see.
Yeah. Okay. So we had 6A correct. That's one mistake, costing us 1 point. We had this one correct, I think, -π/2. Yeah. Here we made a mistake, so that is another probably like they probably would subtract 2 points, so that's 3 points off. Here we had 3/√10. That's correct. Here we made we had a mistake here. That is 4 points off. We had a mistake here that is 6 points off. I know those are like, out of those, there were like 4 points just due to stupid like miscalculation mistakes. So
yeah, but those are gonna happen in the exam. Even if you reread yourself, they're gonna happen.
So I'm gonna calculate a score with them, but if we're gonna review our own tests, we will probably, hopefully, find them.
So wait, I have a question.
Yeah?
Like with the vertical asymptote, why do they use the limits to show that it's not a like candidate for
this one? Well, if they fill it with 0, then it would be an they're not allowed to do that because it's an indeterminate form. However, when they say the limit of, then they can say, okay, here's an answer that's not infinity or negative infinity. Therefore, it's not an asymptote.
Okay.
Yeah. Because when you have an asymptote, it should go to, like, either infinity or negative infinity.
Mm.
But when they just fill it in, then it doesn't get to either of those.
Yeah, I just saw it with like perforation, like I mean hole.
Yeah, I thought so too. We just skipped this step, but we got lucky.
Yeah, yeah.
Okay, so when you want to find out if something is a vertical asymptote or not, you can fill it in and try to figure out what the value is.
But you can also like say that it's
okay, but if I fill 0, it becomes -√4 over 0.
Yeah, so that's 0/0. Then you can use L'Hopital.
Yeah.
But that's minus. No, that's not 0/0. That's -√4. So -2/0.
No, it's 2 minus the square root of 4. So that's 2 minus 2. That's 0.
Yeah.
Oh yeah. Okay.
Yeah, but you can use L'Hopital or the square root trick to figure out that this actually has an answer that's not infinity or negative infinity.
Yeah, the indeterminate form is just 0/0.
Indeterminate form of 0/0.
Yeah.
Okay, so that is.
Are we doing another one?
Wait, first we had 6 mistakes. That's 14 points. So that is we had an 8.
Okay. Pretty good.
An 8 in like half the time.
I mean, yeah, but we're 10 people.
We're a lot of people.
Yeah.
So I'm not saying you
Okay.
shouldn't study after this. I'm just saying past exams to test yourself. So let's go to test 2. And yoink. I deleted the end document as well. Blah, blah, blah. Okay, assignment 1. Restart and restart. No. And go. Rewrite the following integral using the substitution u equals to x to the power 3. Fun. So we have the integral. We have the integral.
2 minus 2. Is that x to the power of 8?
Yeah.
Okay. It's a bit hard to read.
Yeah. Wait. Let me actually see if I can.
You can also download the file.
You can. There's a button to there's a button there.
It's alright.
Yeah, below. Yeah.
Like this. Surely good.
Yeah.
Okay. So we have the integral from this to this of x to the power of 8, 10 of x to the power 3 dx. Well, they want us to figure out what happens if we say u is equal to x cubed. And this is something that you guys might have not seen yet. I'm not sure about. But when we say that,
I mean, changing the limits. You mean?
No, not only that, but something else. We'll see. Du is equal to 3x squared dx. Therefore, dx is equal to 1 over 3x squared du. And also under here, I'm going to add a line saying that x is equal to u to the power of 1 over 3. Sorry, fraction 1 over 3. Okay, so these are our 4 like substitution constant thingies. Now let's fill those into the original integral, and we're gonna work on the bounds like when we're done. For now, I'm just gonna keep those empty. But this will become a u, obviously. Dx is gonna be replaced by this. And x squared. Oh, so I'm gonna say.
I mean, we know x is u to the 1/3, so.
Exactly. Well, first of all, we can see that this x squared here cancels with 2 x's over here. So that's going to be 6. And we know that u equals to x to the power of 3. So we can say this is actually equal to u squared. And that's the thing, like, I didn't know if you guys have ever seen that when you write something in another form, there can still be x's left that you have to manually get rid of.
Wait. Can you just re-go through that last step? Because I don't know, I blanked out for half a second.
Yeah, I get it. That's dangerous when you're working with us. So, oh, wait. So we had this. Well, we got rid of the x squared here. Because
right.
we take 2 of those. And
right,
x to the power of 6 is the same as saying x to the power of 3.
Yeah. Okay, yes. I don't know. It's simple. It's just, I don't know, I just...
Yeah, no worries. So
it's a bit
this
late.
is going to be a new integral. We are allowed to take this outside of the integral sign, by the way.
Yep.
And then we have to look at the bounds. So when u equals to x squared, well, our x's are 2 and minus 2. So that's going to be the integral from 8 to negative 8 of this thing. And this is what you will end up filling in over here. So this is our final answer for assignment 1.
Because you don't have to evaluate.
You don't actually have to calculate it.
No. They explicitly say do not evaluate.
Yeah.
Okay. Ooh.
That's cool. That was nice. That was a nice start.
Yeah, I enjoyed that one. Okay, so they say find a reduction formula for in, that is, express in in terms of in minus 1 and x.
What?
Interesting. I've seen this
reduction formula, yeah.
Yeah, I've seen this come along before. I just haven't practiced with it at all. Oh, this is a lot more on like, yeah, this is a lot more on theories. Like a lot. Oh fuck. Okay.
Like for.
So I of n is equal to x times ln of x, or n. Well, what happens if we just go ahead and roll with this? So we have I subscript n is equal to the integral of with no bounds of x. Let me actually say that. X times ln of x to the power of n dx. So this is what we have now.
Right.
You just fill in n-1 or?
So what we want to find is we want to express in terms of in minus 1. So can't we just make in minus 1?
I suggest taking x as integral and the other thing as derivative, and then writing out what we get. While
I'm thinking that as well. So
while integrals are parts, and then just replacing by I minus 1.
There we go. Okay, so the thing we want to differentiate is ln of x to the power of n. The thing we want to integrate is x. So here we get a half x squared.
Yes.
And the so this is going to be n minus 1 times ln x to the power of n minus 1. Oh god. I'm gonna put it over here. And we multiply that by the derivative of ln x, which is over
Isn't it n times ln of x to the n negative 1? N minus 1, sorry. Isn't n times ln of x to the power of n minus 1?
Good call.
Oh yeah. Yep.
So we have n times ln of x to the power of n minus 1 divided by
right.
x. So,
No, that's right. That's right.
Okay, so then we have this thing times this thing. Enthusiastic. Enthusiastic. So then we can say, okay, I of n is equal to the to ln of x to the power of n times x squared times a half x squared. So I'll create a fraction of 1 over 2 x squared ln x to the power of n minus the integral of, and this is going to look fun, so we're going to have n times ln of x to the power n minus 1 times x squared over, well, x squared over x is going to be x. Oh, I see. Oh,
well, yeah, that's
bastard.
just yeah.
Oh shit, I pressed the insert key. Okay, so what we end up with is n times ln of x x to the power of n minus 1 times x dx. However, if we look at our original integral,
yeah, well, I mean,
exactly that,
you
except for this n.
should have, I think, x to the power 2, because integral of x should also be included in the second integral.
But we included
the integral of x.
Oh yeah, I did indeed. Good that you mentioned. I did indeed get rid of the fraction. However, we did include this x squared. We just divided one x out, so we have one x left, and that's this one.
You divided. Can you repeat? How did you get rid of the x to the power 2?
We got this one. We have to multiply this all together. So we had I took this x squared. I divided it by this x. So we got rid of this, and we got rid of this squared. So then we have 1/2. So that's this half, or this half.
I mean, we can take the half out anyway.
To the power of n minus 1 times x. So this is the one x we have left. That's this one x over here.
Yeah, it's just a product. Yeah.
Yeah, that's just a.
Isn't it a plus 1/2 or?
No, this is all like multiplied.
No, I mean like because there's a minus, and then you should always subtract the integral. But now we have a minus sign outside, right?
We subtracted the integral, but there was no minus sign like anywhere here.
Oh, I thought that the minus sign before, like the DI method, there's a minus sign there.
Oh no. There's no minus sign here. This is just like my self-made fraction.
Okay.
Okay, so what we can do now.
I mean, the minus sign is overall. You're subtracting the
overall
the
we're
integral.
subtracting this thing, but there's no minus sign in the D or the I.
Yeah.
And now there's an important thing to see. This thing is equal to n times the original integral of the key n minus 1. However, this thing is in terms of x, yeah? So what we can do is...
Right, we want to make it in terms of I to n minus 1.
It's good in terms of x. It's just that the thing that's different here is this n. However, this n, looking at the integral, is just a constant. So we can move it out.
Right.
Yeah, that's true.
Yeah, because the integral is in terms of x. So anything.
I always forget that letters are constants when it's not related to them.
Yeah, and that's the fun part, because now we have this beautiful integral in terms of our original function. So we can say this is equal to this times I subscript of n minus 1. And look, we have a function in terms of for I of n in terms of x, n, and n minus, or an I of n. So what was the explicit question again?
Just to make it beautiful, I'm factoring out
and x. Yeah, so I think, yeah.
This was a nice solution.
Yeah, this was good. There's one quick thing I wanted to do. I'm just gonna collapse the fraction so that like everything is maybe under one fraction, but apart from that, you know. So that means that this part is gonna end up over here on the back. So that just means that this is this entire thing over 2.
Better looking.
Yeah, looks pretty.
That's what it is.
Okay, so that's correct for this one. We've already spent a lot more time on 2 than we did on any of the previous things. Assignment 3. This is good though, because we didn't practice with this too much. Considering the following sequence. Is this sequence convergent or divergent? In case of convergence, find the limit. Well, we can...
a squared n over 4. There's no negative.
Yeah, so it's just gonna...
It's just gonna increase.
Well, it's being divided by 4 though.
I mean, yeah, but the division does not increase.
Yeah, so it's
wait, right, no, the number before... I'm sorry, I'm...
Yeah. Like say this is 10, and it's gonna be only 3 afterwards, so it can decrease.
The question is the squared on the a or on the n?
Well, no, it's just a n squared. Because you cannot say a n squared, because then it would not be a complete formula.
Oh, right,
because
okay.
N can only be,
in that case, wouldn't that be 4 over 4 plus half, and then it continues going higher because the value has increased? Wait, no, the value decreases.
Yeah, what I'm gonna do...
It becomes 1.5.
My gut feeling says that this is convergent, and I'm
No,
gonna
this is
try to prove it. So what I'm gonna do is I'm gonna set... Like, as n goes to...
Like you just need an example, because when you have a value of 2, it goes less. That means that any value that's less than 2 will also go less in this setup. So it's gonna continue going less and less every time.
Yeah, and what we can do now is we can say, okay, let's k equal let's actually...
I mean, we have to find the limit anyway.
Let's take the limit as k goes to infinity. Infinity of a subscript k. And let's just... Yeah, okay, so this is what we want to find, right? As we approach the infinity term, we want to find a subscript of that. So what we can do is we can say, okay, infinity plus, or infinity, yeah, if a subscript infinity is same as a subscript infinity squared. Because, or squared plus 1, because infinity equals infinity plus 1. Of course, not really, but limit stuff, etc. So we can say L is equal to the fraction of L squared over 4 plus the fraction of 1 over 2. Do you guys get what I mean with this?
I think we did, yeah.
Okay, sick.
Wait. No, I'm not sure.
Okay,
So,
if eventually we want our number, we want a to be a subscript of a really, really big number, so let's say infinity. It's not a number, but whatever. And the a subscript infinity, that will be equal to this number if it converges. Because if it converges, then if you plug in the nth term, that will be the same as the n plus 1 term, because it will all be the same.
I mean, at that point, it's not actually going to be 0, though.
No, we'll see.
Because every time it's going to be half.
Exactly, and
at least.
We don't know what it will be yet, but we have this function in terms
Right.
of L being the limit, and we're gonna figure it out. So first of all,
So you're saying the limit to the infinitieth term?
Yeah, the limit of k goes to infinity of the kth term.
Okay.
And we're gonna multiply everything by 2 because I think that looks nice. So we're gonna end up with 2L. Actually, let's multiply everything by 4. That makes it a little nicer, because then we can get rid of all the fractions. So then we get 4L is equal to L squared plus 2. And then we get L squared minus 4L minus 2 is equal to, that's not, plus 2, yeah, is equal to 0. Okay. Yeah, that's still correct, okay. Then we can say, I don't think there's a nice factorization for this. I'm just going to use the formula. So that is, we know that this value, by the way, is limited from below at, what's it called? Bounded from below at least 1/2. So it's going to be at least bigger than 1/2 because it never goes below
Right, it
that.
cannot go below 1/2.
Exactly. So we will take, let's see, so we have negative b, that's 4, plus or minus the square root of b squared, that's 16, minus 4ac. So that's just 8 minus 8 over 2. Well, then we can just say, okay, the square root of 8, square root of 8 is equal to 2 times square root of 2. We can get rid of this fraction then. So then we end up getting 2 plus or minus the square root of 2. Well, we know it's not going to be 2 plus the square root of 2. Yeah, the square root of 2 is less than 2. Approximately, the square root of 2 is about like 1.5. If you tell that to another mathematician, he's going to get very pissed. But we know our number is going to be something a little bit bigger than 0.5. So it's not going to be 3.5. We know that for sure. So we can say, okay, from these two options, so from x 2 plus square root of 2 or 2 minus square root of 2, we know it's going to be 2 minus square root of 2.
Right, yeah. I think square root of 2 is like 1.4 something.
Yeah, exactly. So
1.44.
Yeah, whatever.
3 or something like that.
Exactly matter what it is, but all that matters is that this thing will end up to be just above 1/2, which is where we bounded it below.
Right, yeah.
Yeah, or that
it can't be 2 plus square root of 2 because.
Yeah, yeah, because that's gonna be like 3 point something.
So could you repeat that again?
Okay, so theoretically, we know that it's gonna get closer and closer to a number that's really close to the square root of 2, because this term is gonna grow like smaller and smaller. Square root or square root of 2, sorry.
2 minus the square root of 2.
So it's gonna be something a little bit above square root of 2, because if we looked at like the series, let's start out at 2. 2, that's going to be 2 divided by
1.5.
That's going to be 1.5. That's going to be 1.5 divided by 4 plus a half. It's going to be even smaller. So I don't know, 1.3. It's going to keep on getting smaller and smaller and smaller.
Until it goes to like
a little bit
1.58
above 1.5.
something.
So we guessed that. And here we have to pick between 2 plus the square root of 2 and 2 minus the square root of 2. And it turns out that 2 plus the square root of 2 is like 3.4, which is not going to be the case. So it turns out to be 2 minus the square root of 2.
Yeah, that's cool.
Okay. Consider the following series. The sum of blah 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 blah. Is series convergent or divergent? Well, we know that every new term. Oh, I can actually already give you the answer. That's sick. Every next term, so it's going to be like 5 over 2. 5 over. Let me actually write it out real quick. It's going to be 5 over 2 c dot 3 plus 5 over c dot 3 squared plus 5 over c dot 3 cubed, etc. So this is what this
every time
so this is what
the division part of the fraction is going to increase.
Yeah. So basically what we're saying is this is equal to 5 over 2 times 1 over 3 frac 1 over 3 plus frac 1 over 3 squared plus frac 1 over 3 cubed. Yeah. So we know for a fact that the starting term of our sum is
Oh, that's genius. You can take it out like that.
Yeah, I mean, we theoretically wouldn't have to. Like, we can also just compute it without it, but
Right, but like that's, man, this is glorious.
I'm glad you're enjoying it. So, to calculate this
Didn't you
sum,
have this in the lecture or?
Yeah. Lecture 10.
Yeah.
Wait, that like that is if n is 3, right?
In this case, the factor, the r, is going to be 1/3, and we know for a fact that it's convergent because the absolute value of 1/3 is below 1. So if like the factor that it's going to get bigger with was higher than 1 or smaller than -1, then
it's 3 to the power of -1, so it's -1p.
What? I don't know that.
Like, it's the thing we were talking about earlier on, the p. It's like the p value. When you've got something to the power of a p, if the p is below 1, then it's going to get smaller.
Yeah, and this p is equal to 1/3. I'm not sure if this is actually a p series, but
I mean, no. I think the p is 3 to the power of -1,
that's
and then it
1/3.
goes -2 minus. Yeah, you're right.
I
no,
thought this is just the geometric series, right?
Yeah, it
Where
is
the
a
ratio
geometric
is
series.
1 to 1. Yeah.
There are multiple names for them, but yeah, we can use the formula for the geometric series, and we can say, okay, the first term is, we can either pick this or this. It doesn't really matter. We can say, let's say that I copied it 3 times already. Let's say this is the first term, and then do they actually give us that on the formula sheet? I don't think so.
The equation for the limit of a sum of a series.
Yeah.
They don't give it to us?
No, I think we have to learn it.
God damn it.
Yeah, that was like one I really was banking on, but whatever. I think it's like
God damn it, I knew it at one point.
1 minus r or something. Let's look.
Which
Yeah, we'll have to know that in the exam, and convergence is with an A.
Let's say convergence of geometric series.
The one A1 over 1 minus
So
r.
it is A over 1 minus r.
Yeah.
Okay,
okay. So I was correct. 6.
And the ratio is 1/3.
Yeah.
So
and that's the r in this case. So that's gonna be the original factor over. Oh god, it's gonna be pretty. The original factor over 1 minus 1/3. And let me see if it compiles them. Yeah. Okay. So then this becomes 2/3. And if we have, if we divide by a fraction, it's the same as multiplying by its reciprocal. So we get is equal to fraction of 15/4. I think.
Yeah, that sounds about right.
Okay. Wait, this is my wrong one. Yeah, this is the one. So our answer for assignment 4 is 15/4.
Are we gonna get stuff like this in the midterm?
Yes.
I think so, yeah.
Yeah.
Yeah, but
Maybe not
This
as
is-
much
this
as
is
in
for-
this one,
Yeah,
but
this
yes.
this one is like focused on this, but we will get some questions about it.
yeah, but isn't this a series?
Yeah, this is series, but it is here. If we look through here, we can get stuff until lecture 10. Oh yeah, you're right. It is a
Wait,
series.
series?
What the fuck?
Okay, we don't get that then. Probably we don't get it, no.
Probably not, but let's just do it anyways.
Yeah.
Woo! Let's
we
go.
We are unable to do some of the stuff because, like, we haven't even gotten some of the stuff yet.
Yeah.
We're gonna get that tomorrow, but let's try it anyway.
Yeah.
If we're unable to get it, we'll just say, oh yeah.
I mean, they'll still have some questions. I mean, do they only have questions on series though?
I mean, it's gonna be close. Well, this is an alternating series, is it not?
Yes, it is.
Well, so is this. So is this.
Yeah.
Yeah, we don't really.
Consider.
I don't think
power
we've learned this
series.
stuff yet.
We haven't done a power series either.
No.
Maybe we can
Yeah.
switch to another past paper that's more
Yeah.
I was
relevant
about
to
to say,
what.
okay, guys, we did it. I am.
Yeah.
What
curious,
about
though.
9?
I want to see if we succeeded the questions we did answer though.
Yeah, exactly. I'm
Wait,
curious.
wait, we can do question 9. We can do question 9.
Yeah, question 9 is.
What's
I
question
think,
9?
What's question 9?
I mean, integral.
Oh,
Yeah.
wow, easy.
Oh, sure, let's do that.
Yeah,
This
sure.
one is easy. Yeah.
So, assignment 9. So here we.
How are they getting such easy questions, man?
Yeah, I was about to say, dude, what the fuck?
Yeah, what?
Like, bruh.
Bruh.
So this is just equal to x to the power minus 2 dx. Well, I mean,
Like,
this
if
is
we got this on the exam, I'd be happy, man.
this is like,
Bruh,
this is an
if we get
integral
this on the exam,
This is an integral question on the what's it called?
sequences, series.
Yeah, or like the sequence is part of the exam, so I understand why they would make it easy.
Okay.
Right, but still though.
Yeah, indeed, but still. So this is just gonna be minus 1/2 times x times 1/x.
Wouldn't it be minus 1/3? Because wait, no, wait.
No, -1.
Oh wait, it's integral. It's going the other direction. My bad.
yeah.
Sorry.
Yeah. So this is actually equal to minus 1/2x.
Why 1/2?
Yeah, it's 1 no.
It's x to the minus
yeah,
one,
it's actually
so-
1/, so it's just 1/x. Yeah.
Mine.
Okay.
Wait.
So this is.
It's improper.
Yeah.
So yeah, and then we get
And then we just fill in, right?
yeah, we just fill in, so we'll get minus
Guys, it's improper at 0.
Yeah, you have to split it into minus
split
2 to 0 and 0 to 1.
Okay, yeah.
yeah, okay,
Okay,
that's
yeah.
a good catch. That's a good catch.
Yeah. Otherwise, it would be cheating.
Yeah, but I guess that's also like one of the 2 points for the calculation.
Yeah.
But then we will get I'm gonna do it like the long way. So we have the limit of a goes to 0 of the integral of of this thing plus limit as b goes to 0 and these should be like 0 plus and 0 minus. Minus plus the integral of 0 minus this whole thing, and then it should go from from b, and this is from the negative. Wait, no, this is from 1. Yeah, from b to 1, and this is from 1 from -2 to a. Okay, so if we look what I wrote, we have the limit of a goes to -1 to 0 from the left side, -2 to a. I did make a mistake here. So what is this? Oh yeah, that should be... if you guys get this mistake, it's just like when you use the bracket and subscript, like the superscript and the subscript, if it's more than a singular character, you need to put curly braces around it. But yeah, so we get 0, 0 from the left of this thing, 0 to the right of that thing.
Right, so that's like 1 minus 0, and then 0 plus a half, isn't it? Because we've got basically negative 1 over x. Right. At which point it would be minus 1 and a half.
Let's see what happens when we fill it in. So we have this thing. So let's see, I'm going to paste that for every integral. So we have first integral plus second integral. And then I'm going to fill in the two values per integral. So we have the first value minus second value. And then the first value is a, the second value is -2. And here the first value is b, and then minus the value of 1, closing bracket.
But it's 1b, 1 minus.
Oh yeah, excuse me.
Yep.
So that's...
Oh wait, no, I'm an idiot. Oh my god,
It happens.
Oh man, like working past 5 starts to be a bit... Oof.
Yeah, we've been busy for...
We've been at it for like...
6 hours?
6 hours and 50 minutes. We started at 11.
Yeah.
That's metal.
I mean, like with the pauses, it's been like a bit less than 6 hours.
Yeah, that's true.
Yeah.
I mean, only 6 hours. That's respectable. We're not finished though, but... Okay, so then if we fill in 0 for these, well, I was about to say if we fill in 0.
Can't just do that.
Yeah, but we can't.
Yeah.
So is it possible?
I mean, wouldn't they cancel out? Because they're both basically the same level of infinity, wouldn't they?
No, I don't think that works like that.
That's too bad.
Let's look at the graph of 1 divided by... Because I think
Not sure you're allowed to do that in the exam.
Well, I mean, I could sketch it by heart. Like, if we have the graph here...
Wait, so we have minus...
Because there will be minus infinity plus infinity,
like
right?
This.
Right.
This. So,
yeah.
Approaching x from the left is going to be positive infinity, or from the right is going to be positive infinity, and from the left is going to be negative infinity. So these are two different values.
Yeah. Too bad.
So what we do then is we say divergent, and we look if we're correct. So this is test 2. Let me go back a slide or a page. I hate that I'm more nervous and upset about the fact how they're going to be fucking proctoring this thing than the actual exam, which is going to be easy.
Yeah.
Whatever. So test 2. So for our things, we had rewrite the integral, so that turned out to be 1/3 u squared tangent of u du from 8 to -8, so that's 4 points.
Yeah, that's good.
Nice.
Nice. We had 1 over n ln n to the power.
Yeah, they just
yeah,
didn't.
That's correct as well. Then we had here L equals to 2 minus the square root of 2, boys.
Nice.
Nice. And then the last one, 15 over 4. Let's go. Let's fucking go. And then the last one is equal to diverges and the original integral as well.
Let's go.
Okay,
Woo!
sick. We had
Okay,
4 points.
so,
We had fucking 4 points for this.
Of what we answered. Are we gonna look for another past paper that's more relevant?
Yeah, let's do like another one. Like and that's the end. Like after that we'll stop.
I gotta go though. Bye.
Okay, have a good one. Okay, so let's
Do you want to try the? Wait, no, we can't do that because we have to test the proctoring software.
Yeah.
I wanted to see if we could try the grasple one, because that would be more realistic to like the actual conditions.
Yeah, but I'm only gonna do that like on my actual PC. Like the PC I'm gonna do it on, and this is not my my PC I'm gonna do it on.
Yeah, fair enough.
I'm gonna do it on my laptop. Because I can like clean. I have like one part of my desk that is where my computer stands, and then my computer itself, and then like an empty part. I don't want to clean up the part where my computer is, so I'm just gonna clean up the part where, like the empty part. And I'm gonna put my laptop there.
Right, fair enough.
Yeah, I have like a bunch of writing on my walls and shit.
I have nearly nothing on my walls. Apart from the little paper I wrote down with the trigonometric identities, which I guess I will have to remove.
Probably. My girlfriend actually like paints on her walls sometimes. So she has like a few quotes and stuff on there, and she literally cannot remove that writing.
I have two paintings that I want to put on my wall, but I don't know if I'm allowed to, because I'm in a housing, like I don't know if I can put things on the wall, like.
Yeah. Like for me, I have like a bunch of stuff where there's text on it, and I'm literally just gonna like, cause it's taped to my wall with double-sided duct tape. So if I get rid of it, I actually tear my my behang. So I'm gonna have to put like A4 papers over it so that I can.
That is ridiculous.
Yeah, it's fucking ridiculous, but.
Wait, so we can't have anything written
You cannot
around
have
us?
anything written in your room.
I'm gonna have to clean the fuck up.
Yeah, I'm gonna like
Holy
start at
shit.
least like an hour or two before like preparing my shit.
I'm gonna even prepare myself on Sunday.
Yeah, let's do the CSE by the way. Let's do the CSE 1920 test one. Oh wait, but there's no answer for that one.
For a second, I thought these are years when this test was done, like the year.
Yeah, no, it's last year. Let's do this one then because this one actually has answers.
Sure. 2016 is a long while though.
Yeah, but I think we should be good.
Fair enough.
From 9 to 10, this seems like a chill test. From 9 to 10. Like in the morning, you wake up and you do 1 hour of test.
Well, I mean, I wake up, I have 2 hours of travel time, and then I have to do an hour test. Then I have 2 hours more travel time.
Yeah, that's not.
I'm really not looking forward to when on-campus education is coming back. I'm literally just not going to go to campus for anything except for tests and stuff, and just read the slides. Because I just don't want to go.
I mean, 4 hours of transit is ridiculous.
Yeah.
I don't want to go on campus as well now.
Yeah, like I made a poll a while back where and I was like one of the only people who voted, hey, just keep it like this, lol.
I'm so happy that they make it non-mandatory, man. The on-campus sessions.
Yeah, on-campus stuff is no longer mandatory. Like, I talked to a guy who didn't go to campus at all since like year 1, quarter 2, and he is completely in the right. Like,
that.
Well, of course, except for tests and stuff. Let's focus on
Yeah.
this thing first, and then I can stop the stream, and then we can talk along. Every exercise worth 2 points, whatever. Find the inverse function of f given by blah 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 blah. For x less than 0. Okay, well we start out with y is equal to the fraction of x squared minus 1 over x. Restart. No, go. Damn it! Anyways,
Can you zoom in on the left side?
Yeah, sure. Let's actually do that here. Yeah, whatever, close enough. So we have y is equal to x squared minus 1 over x. If we change the stuff around, we get x equals to y squared minus 1 over y. We can multiply both sides by y. We will get yx is equal to y squared minus 1. We can subtract y squared from both sides. Then we get minus y squared equals to minus 1. Ooh, I'm tempted to do something dirty. So this is going to be equal to 0, this is going to be plus 1, this is going to be like this, and then we'll get this plus that. So now we've got something in terms of y squared, something in terms of y, and something in terms of 1. Can we just use the ABC formula?
Yeah.
Yeah, why not?
Yeah.
So we get y is equal to the fraction of b here is x, so we get x squared minus 4 times 1 times negative 1, so that's plus 4, over negative 2. And it's complaining, let me fix that. There we go. Let's go. Oh, it's x squared. B squared minus 4. So this is, oh, it didn't carry over. So we have minus square root of b squared. Oh, yeah, okay, I see what I did wrong, excuse me. So what I was doing is I was only calculating the inside of the square root. So this is, okay, and then we have negative b, so that's negative x, and then plus or minus. I think there's a thing for that, like PM or something. Yeah, so we have negative x plus or minus square root of x squared minus 4, and it should be minus 4ac, so that's plus 4.
Yeah, isn't it plus x?
Hmm?
Or isn't it plus x?
Well, the term that is in front of here is
It is plus x actually.
Yeah, you negate it because you have a negative before the y squared, and then you put it in negative again.
Actually, I think
it can. No. Because minus 4ac, you have one negative, one positive, so it becomes positive.
No, I think it's plus. I think definitely plus, because if you write this formula, this equation, this quadratic equation to just I to the power of 2 minus I x minus 1, and then you do the same thing, you get x plus minus. You get the same thing, but with plus x.
Wait, can't you just write the extra step?
then this would also be swapped.
No, it remains. Oh yeah, I think yeah. Sorry, I do it in this way.
Yeah, I
Like,
never actually do it like this.
yeah, I always have the first link plus, not minus. Like,
Yeah,
I usually convert it
first. If you want, I can distribute like the negative sign here, so this will become, and this will become.
I mean, it's gonna be y squared minus yx and minus 1, but then it comes down to the same because a just becomes 1 and c becomes minus 1 instead of minus 1 then 1.
Yeah, so this is what happens if you distribute the minus sign, and then we get the same. These two are equivalent functions.
No, I think what he meant was when you make it y.
Here, yeah, you can do it here, like.
It would be y squared minus yx minus 1.
Yeah, but you can do that. You can multiply everything by minus 1. You can also just not do it. I chose not to do it.
yeah, it doesn't matter. I feel because I do it in this way on paper now, and because I saw you and mine, and I just got confused about.
Okay,
yeah.
So we have this.
Wait, does it actually matter if you write plus minus or minus plus?
No.
Not really, but it's just like to show that we inverted
Plus
the plus
minus looks better.
It depends only when you have like other plus minus things, like, and it depends if you want to read up or down.
Yeah.
Like sometimes we have many things. Yeah.
We do know that in our original formula, x was always less than 1. So in our new formula, y is always going to be less than 1. Therefore, this has to be a minus.
Yeah.
So I can change this MP into just a normal negative sign. Yeah, so we'll end up with y squared equals to x minus whatever, blah, 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 blah.
Why is it negative?
Can we answer that? I guess we have to, actually.
Yeah, like there is nothing else we can do. This is the answer.
It's negative because it can be larger than 0, so the plus doesn't make sense.
Like if it was plus, then you'd be adding two positives, which can only be positive.
Yeah. Plus we
Well,
know that like both this one and the answer will always be negative because this thing is always bigger than this thing. Well, it depends on your values of x, but whatever. This is the one we have to do because in this case x cannot be smaller than 0, so in our inverse y cannot be smaller than 0. And that also makes sense because if y could be, or in this case if y could be bigger than 0, then we could have a plus minus here, but then we would have two functions. Binnen. Ja, dat is heel jammer. Ik maak dit ding af, dat duurt waarschijnlijk nog 20 minuten.
Basically, if it is possible, then we have two possible
x plus or minus, and that's not
function.
Fun fact: if we had x plus or minus the thing, it would not be a function; it would be a relation.
I mean,
because it's not bijective.
Yeah.
So yeah, we have to pick one, and because we know x is always less than 1, in our formula y is always going to be less than 1, so we have to pick minus. Okay.
All right, let's go.
How are we sure that when we pick minus, it is 0? It's less than 0.
Well, here we have.
If you look at the thing, you've got x is smaller than 0, therefore x is negative, and you've got a squared number divided by a number, therefore it's always negative.
Well, not really, since like here it says x is less than 0, but in our new formula y is going to be less than 0 because we swapped around x and y. So the y has to be less than 0.
But even if you
for this to be less than 0 is for x to be subtracted by a thing bigger than x, and the square root of x squared is equal to x, and this plus 4 is going to be something at least bigger than x.
At least bigger than 0.
Yeah, like this whole thing is going to be at least bigger than 0, and this part alone is going to be at least bigger than x.
This smaller
So now,
than 0.
y is always 0. It's negative. Y is always negative.
Well, here we said that x is less than 0. And we calculate the inverse, so we swap around x and y. And therefore y has to be less than 0.
Yeah.
Okay. We gotta hurry. So find the largest interval I such that the r cosine of the cosine of a is equal to a minus 2 pi for all a is part of the interval I. Okay, what is the range of arc cos?
No, wait. Don't even. Close that. Remember when you do the circle. Come back to the circle. We know that, okay, I guess you erased it.
Circle.
Right. We know that cos is positive on the cos is equivalent to the x-axis.
Yeah, this one.
Right. So cos is positive in those two, exactly.
Well,
so we want.
That's what we thought last time, but arc sine does not have this as a thing.
Wait, really?
Yeah, it's different. Do we have to memorize these?
I don't know. Let's see. Arc cos range.
Is it on the formula sheet or no?
This is not on the formula sheet.
You have to memorize them.
Okay. The domain is from -1 to 1, and the range is from 0 to pi. So the arc cosine has a range from 0 to pi.
And they ask us to find an interval for which it works for values -2 pi?
Yeah, so the value of this is equal to the value
Right,
of
but
this
listen, even if the arc cos is the range that you want, there's also the cos that's actually the cos itself in there.
Yeah, because the cosine of A, won't that just be...
Cosine of A will always be within 1 and -1, therefore it's always going to work.
Theoretically, yeah. Then this could just be any number.
Right, but we want an interval where for all A, all alpha, alpha -2 pi is the same result for cos, basically.
We then just say that alpha is equal to all numbers?
No, because that's wrong. Because if you look at the circle again,
The domain is
Like
between...
2 pi is the whole circle.
Yeah.
Then isn't it the whole thing?
Exactly. That's what I said. So alpha is equal to... well, it doesn't say anything about the regularity of alpha, so this should just be equal to... what is that? Not 0 quite real, so all the real numbers.
I mean...
I don't think it works with imaginary numbers, but with all real numbers, why not?
I mean, yes.
I don't know.
But like, I don't get the point of the question then.
yeah, I don't get this. What's happening?
Like,
so
I know,
cosine of
answer,
a... Like, we know for a fact that cosine a is equal to cosine a plus or minus k times 2 pi, right?
Because it's cyclical.
Yeah. Like,
it always loop. And if you have 2 pi, that's literally a circle apart. So you're going to come back to the same value.
Imagine, say this is like pi over 4. And then we want to go from here, we go 2 pi further. Then we get back here. This is just like 2,
so the value is the same.
1/4 pi.
Yeah, so isn't it technically just alpha equals alpha?
Yeah,
like
well, we need to find an interval I. So that
alpha is different, but the cost of alpha is the same.
So we need to find an interval I. I mean,
right.
Wouldn't we then just say I is the open interval of minus infinity to infinity?
Basically.
So this is the open interval, right? Yeah.
Yeah, that is.
Okay, cool.
Because like, for any alpha you take at any point, if you subtract 2 pi or add 2 pi, the cost of alpha will be the same.
R cos alpha is alpha, right?
Wait.
No, cos alpha is alpha in the range of between 0 and...
We had the right idea, but what we said is wrong.
Sorry, what?
Because we're looking at arc cos of theta is equal to theta, or alpha, my bad, minus pi over 2, or minus 2 pi.
Yeah.
We're not looking at arc cos theta is equal to arc cos theta minus 2 pi. That's what I
No, you're right. Okay, but then isn't it just 2 more pi than the previous range we had?
Well, from minus infinity to infinity plus 2 pi is the same, so...
No, that's wrong. Look. You want arc cos of cos alpha to be alpha minus 2 pi.
Yeah.
The thing, though, is that arc cos of cos alpha will be restrained in the range of arc cos.
Oh, yeah, I see what you mean. Okay, wait, the range of
No,
arc cos
that means that alpha cannot be 3 pi's, 4 pi's away. Because if it's 4 pi away, yes, the value of cos alpha will be the same. But arc cos cos alpha won't be 2 pi apart.
Yeah. Okay, so
it has to be between 0 and pi, right?
Yeah, so it's between 0 and pi. So the only way where the value between 0 and pi is equal to alpha minus 2 pi is when we take that value and subtract 2 pi from it. Because then when we fill it in, like all this will do is it will restrict it to the value of...
In terms of range, that would be more adding 2 pi, though, in terms of domain.
Yeah, okay.
Like you're increasing
by 2
pi
the domain of 0 to pi will become the domain, the inclusive domain.
Would it be pi to...
2 pi to... Wait.
Wouldn't it be pi to 2 pi? Oh wait, no, sorry. 2 pi to 3 pi.
It is 0 to pi, so it's 2 pi and 3 pi, yeah.
Right, yeah, okay, that makes...
when you fill in any of these numbers, they will get subtracted by 2 pi, because it needs to be in the range of 0 to pi.
Yeah, that's good,
Okay.
I was so confused by like what the question wanted.
Yeah, my bad.
It's alright.
The answer should not contain any trigonometric function.
Why?
Thank you.
Why the range became closed? The range became closed. Now 2 pi, 3 pi, it's closed.
Yeah,
it was
you
open.
can fill in 2 pi, and that's okay.
It is restrained to 2 pi. You can't have...
You can have 2 pi.
If you fill in 2 pi in cosine of
can't have
cosine,
maths.
you will get 0.
So it is possible.
Wait, then yeah, wouldn't it be a bracket?
Hmm?
If 2 pi is included in the thing, wouldn't it be a bracket and not a square bracket?
It is a bracket.
Yeah, but no, like, is including the value, is that an opening bracket or a closing bracket?
I think that's open bracket.
This includes 2 pi and 3 pi.
Okay, so
if it's
including both of them. Excuse me, I thought they were the other way around.
More now.
No, wait. If it includes, then it's closed. Trust me.
Okay, then we're good.
Yeah.
It's meant to be like the.
You know what I would do at this point?
Trust me,
I would say 2 pi smaller or equal to
I would say just say I is the range from 2 pi to 3 pi
included.
So
beautiful.
Okay, but anyway, assignment 3. So we need to find the
we need to find arctan of sine.
Arctan of 4 and then sine of that. Well, that's not too hard. We can draw a triangle. We have the arcsine of 4 over 1. And the sine here is going to be square root of 16 or 17.
Wait, wouldn't sine be hypotenuse and opposite, not opposite and adjacent?
Yeah. So it's going to be sine is opposite.
Oh, right.
4 over square root of 17.
The sine of the arctan. My bad. Yes. Sorry.
However, is 4 over square root 17 within the range of this? Because the arctangent has a domain or has a range of what exactly? I think negative 2 pi to, or what is it? Negative pi over 2 to pi over 2. This is not within that range. Right.
No.
Yeah, this is outside of any range it would give. So let's instead say let's turn this into x.
We just use the formula.
Yeah.
We know
so
that
square root of 1 plus x squared.
Like rather than using the triangle, couldn't we use the formula that they taught us? That's
that's this formula. So we can instead of this fill in x, and say okay, the sine is x over.
Yeah, that's not the formula.
Hmm?
Oh wait, it is the God limit. You're right. Ah.
No worries. So if we get this instead of 4, we should fill in 4 minus pi. Yeah, because that is definitely within the limit that we are allowed to have.
Why didn't you just write 4 and you write x?
Hmm?
You just write x now. Why don't you write 4?
Because we do not want to fill in 4. We want to fill in a value that can get processed by the thing. So this is just the general formula, and we can later, if we find 4 to be fit, we can fill in 4 into this formula. That will give the same answer. However, 4 will not be, like arctan will not give a value with a range of, how do I say this? Basically, 4 is not within the range of either of these functions. So we have to subtract pi to get the answer.
So 4 minus pi.
Yeah, so if we have this thing, I think for x we should fill in 4 minus pi over 4 minus pi squared.
How is it not just 4 over square root 17?
Because I don't think 4 over square root 17 is within the range of these functions. Because because either like the arctangent or the other one has a range of negative cosine over or negative pi over 2 to pi over 2.
Wait, no, it would be within.
No, yeah, I think it is.
Would it be?
Because square root, we know that square root of 16 is 4. So 4 over
Yeah, so it's
square
gonna
root
be less
17
than
must
1,
be smaller than 1.
I think it is.
Okay, so
I mean, I don't see any other way of doing it.
Wait, so that was 4 over square root of
17.
Yeah. Okay, so yeah, that's 4 over 17. We'll see. This is probably correct, yeah. Now that I think about it. Excusez-moi for the confusion. And
Why do you say those words in French all the time?
I don't know. I like the word bonjour and the word excusez-moi, and that's all I know.
Fair enough. Fair enough.
Okay, so we have assignment 4. Suppose y is a function for which the following holds.
Wait, and again, I think it should be square root 17, not actually 17 here.
Oh, yeah. That's correct as well.
Wait, we had 4 minus pi, and now we have 4 over square root of 17. Like how did we calculate?
We cancelled all of what we were doing and came back to the original plan.
Yeah, just ignore the pi stuff.
Yeah, excuse me.
That's alright.
I think that might only like apply for sine of arcsine and stuff like that.
Something, yeah.
I don't know. I'll look it up later. Suppose y is a function for which the following holds. Okay. Okay, so what we know now is we know that there on this graph there exists a point, namely x is equal to 1, y is equal to 2. We also know that y of x to the cubed minus y of x equals to 6x squared. Let's take the implicit derivative of this. That looks like a good way to start.
Couldn't we just rearrange to isolate y of x?
Not really, because you would get y of x is equal to 6x squared, or no, not really. No, never mind.
Oh.
You would have something in
No,
terms
but
of...
wait, would it? No, okay, no, you're right. Sorry, my bad. Oh,
no worries.
God damn it.
We've been busy with calculus for like more than 7.5 hours almost. No, a little bit less, but still, it's a lot.
Yeah.
So let's take the implicit
How do you
derivative.
differentiate y of x?
This is, let's see, that is...
Well, actually, y of x is basically just f of x, but with another name.
Yeah.
So it's y, basically, with another name.
Exactly.
Oh, okay.
Minus y thing, and then we get 12x here.
My God, we're lacking the dy dx.
Fuck your dy dx.
Dy dx is a superior method.
Now I'm thinking is in this are.
I mean, we just want to basically, we just want to fill y and x, and then bam, solved.
Yeah, but our our x here is 1. Okay, yeah. So our x here is 1, so this becomes 12. Our normal y is equal to 2, so this becomes 4. So this becomes 12 as well. So we have...
Are you sure about that, though? This was...
3 times 2 times 2, 12.
I am... Right.
Brain power.
Let the bass kick off.
Yeah, because we're filling in, like, this is y of x, and we know y of 1 is equal to 2, and we want to know y extent of 1. So our x in this entire formula will always be 1.
Right, but y of x is going to be 2. Right, okay, yes, sorry, my bad.
We filled a 2 here, 1 here.
Oh my God, why am I so tired?
Yeah, like, wait, let me get my notation, like, straight then, because that can also be part of it. Because I'm using, like, of x at some places, and not of x at other places.
Oh, man. Okay, that's more understandable.
Yeah, sorry.
Yeah.
Yeah, I mean, y of x and y are technically interchangeable in this case.
Yeah, indeed. But yeah. Okay, so now this becomes 11 y prime of x. So therefore y prime of x is going to be 12 over 11. 12 over 11.
And I'll fill in 1.
Yeah, and like this is already, like the moment we started filling shit in, this all became like y squared of 1.
Oh really? Okay.
Yeah, because like the moment we started saying our x is 1, then this became y prime of 1.
Oh.
Okay, so our answer here is this. Okay, find if possible the that's not fun. Assignment 5. Find if possible limit of x goes to infinity of this whole thing. So this is going to be an infinity over infinity minus some other types of infinity. We can either start with the square root trick, or we can...
What is the whole question? I can see the whole question.
Find, if possible, the limit of this thing. Also, infinity and minus infinity are possible.
I think the square root trick would work here.
Yeah, we could also divide... No, wait, you couldn't just divide by x.
No, I can't.
We can also just do L'Hopital.
We could do L'Hopital.
But that would be hella messy.
Right. I think just the square root trick would
We'll do the
work.
square root trick. Why not? It's been a while. X squared minus the square root of x to the power of 4. I swear to God, I am so in love with LaTeX. It just all looks so pretty.
LaTeX is nice. But my skill, I'm way too slow using it.
Learning LaTeX was one of the best skills uni taught me. I don't care.
Who told you? Who told you?
Hmm?
Uni in general.
Yeah, uni in general. Like,
Who told you?
I just basically I started using it, and then like literally all you need to know for LaTeX is the list of most basic symbols. So we have a list here, a reference of everything that you need for CO, and everything you need for calculus is just fractions, square roots, integrals, and stuff. You can just Google that as you go, and then it's really not that hard writing stuff.
Yeah, it's just getting used to it. Like I don't use it too often, so I'm pretty damn slow. But like when I want to make something pretty, I use it because it's nice.
Yeah, I do all my math homework in it, except for when I don't, and then I do it in my notepad. But even then, I still, let's see.
That's the thing. I'm calculating on paper as well. So like.
Yeah, like even then, I sometimes still. No, I didn't do it in any of these, but even then, I sometimes still use the LaTeX representation.
That was Morse code.
Yeah, that was Morse code. It was for a hacking challenge.
Oh, nice.
Yeah. So okay, if I do this one times the reciprocal.
Right.
Yeah, this is 100% something we have to solve using this.
X to the power 4 minus x to the power 4.
And then this becomes x times this whole thing.
Yeah.
These two can get cancelled out against each other, become the squares of each other. So this becomes x to the power 4 minus this whole thing. Okay.
You have to make sure that the x to the power of 3x to the power 3 is negative.
Hmm?
3x to the power of 3 should become negative because it's part of the bracket.
Yeah, I sometimes delete the negative sign and then I forget that. So
yeah, that's why I was like, because if it happens, like that's gonna happen so bad.
It is. So these two cancel out against each other. We have an x here that we can cancel out against each other. So this becomes x squared. So then this should look a lot prettier already.
It's very nice. Wait, shouldn't it be x to the power 3 though?
Why? Because we took away this x in the bottom.
Oh wait, no, you're right. No, yeah, that makes sense.
Yeah. Also, this here should be a negative sign. I forgot to change that one. Okay, so far we haven't really gotten much further than we were before.
Huh.
Let's actually try dividing by x squared everywhere. That seemed like it would work.
Yeah. Let's try that.
Yeah, so we divide by x squared here, this becomes this. We divide by x squared here, this becomes 1. And here I'm going to say, I'm going to divide an x to the power 4 outside of the brackets here. So this will become 1 plus 3x to the power minus 1. Okay, so we have yet to like divide
this one
out. So this is theoretically it's really bad of me. I shouldn't be using an equal sign here. But I'm not boggers.
What? I
But basically,
think if you divide it.
when I take this square root of 4 out and make it become a square root of x, we need to think about the signs. But because x is going towards infinity...
yeah, we don't care.
Yeah, we don't care about signs, so we can just get rid of this.
Oh, right. And you can just take... Alright.
Yeah, because
How should we
if it was negative infinity, then the negative sign would have carried over, and this would have become a negative sign.
Oh, which one will become negative sign?
This one, because this x to the power of 4 will become negative x squared instead of positive.
If it was minus infinity.
Yeah, if we were filling in a negative number.
Right. And because it's 3x to the minus 1, it's gonna go
yeah,
towards
this is gonna
0.
go away, and the rest we can just...
It's minus 3 over 2, basically.
Yeah, basically. So
By the way, guys, just spoiler, we could do that in the beginning.
Yeah, probably, but I wanted to see if this would work.
Minus 3 over... Yep, we could have seen that straight away. Well.
Wait, how with I know it... Not really, would we?
Yeah.
The biggest factor we could...
Wait, no, wait,
the
wait.
biggest factor we could divide out here with only an x.
Yeah.
Otherwise we would get like divided by 1 over x, which would become divided by 0, and we would have another indeterminate form.
Yeah, no, that wouldn't work.
Okay.
I mean, okay, it's all right. We got the answer. We got the answer. Let's actually see, continue if we can finish in time.
Wait, so you said that it would be negative if it was going to minus infinity?
Yeah, because what we're practically doing is... let me actually copy this line real quick.
What we're doing is that we're taking x to the power 4 as a factor out of your square root.
Indeed. So let me copy these lines. So we have. Let me wait until this reloads. Here. So we have this line. What we're doing there is we are actually getting x to the 4 out of there. 1 plus 3 times x to the power of minus 1. So this is what we're doing. Wait for it to update.
Yeah, right.
Yeah, then we are splitting it off into two things. Namely this square root and this square root.
We split because it's a multiplication. You can take the things different square roots.
Yeah. However, the square root of x to the power of 4
is x to the power of 2.
Hmm?
Oh yeah, right. It could be negative, but we know that x is going toward infinity.
Yeah. So in this case, it would just be x squared.
But if it was going x toward negative infinity, it would be negative x squared.
Well.
Wait, what?
No. Okay. Wait. Nope. Backing out of this, I said something dumb. My bad.
Okay, so the reason why we're curious about this now is this would not work, because even if this was even if it was minus infinity, we wouldn't have to worry about it. However, if it was an x squared, like this, like if this was the original function, then this could have been negative negative x.
What?
Okay,
Yeah.
So what we did is let me actually
when you've got x squared. All right. So what's the square root of 25?
Plus or
5 and minus 5.
Right. Okay. And then we couldn't know if it's 5 or minus 5, or in this case, x or minus x. But actually, it does not matter because it's x to the power 4. So we're looking at 25 squared, in which case the square root of 25 squared, well, it is 25, but 25 is still the minus 5 or 5 to the power of 2, but it doesn't matter because 25 is positive in that case.
Like
if it was x to the power of 2,
yeah, like
then
I've changed up our function. Now it is x to the power of 2. So now if we wanted to get this out of here, this would actually be like if this was if x was going to negative infinity or negative 3 or negative 7, whatever, this will become negative x.
Right, because we know that it's in the negatives, basically.
Yeah.
But here, because I mean, even if you didn't know, because it's x to the power 4, but if it was x to the power of 2, we would know it's going towards positive numbers.
Yeah.
Yeah. Okay. So for x4, it's always positive.
Yeah, because x to the power of 4 is like the thing we're trying to pull out. The x squared is always positive.
Right, x squared is positive because regardless of what x is, x squared will be.
No matter what x is, x squared is positive, but if we were trying to pull out an x out of the thing, then it could have been negative as well. Find, if possible, the limit of x goes to 2 from the right of this whole thing. Well, if we fill it in, we get 4 minus 4, that's 0, over 4 minus 8 plus 4, that's also 0. Cool.
Yeah, so...
So wait, let me see, assignment... Ja? Al ik klaar met deze doet? Er maximaal 10, 20 minuutjes.
Question, guys, doesn't it pain you that they wrote 4 minus 4x plus x squared and not x squared minus 4x plus 4?
Yeah.
This pains me so bad. Like, why, guys? Why? Just why?
Yeah, differentiation, I don't know.
The fraction of x squared minus 2x over x squared minus 4x plus 4. The proper fraction. So let me scroll down a bit.
Can't we just factor out?
Yeah, I was gonna say, like, if I know for a fact that this is equal to x over x minus 2, is this equal to anything proper though? No, I don't think so.
I mean, this is x minus 2 squared, basically.
Is it? Oh yeah, it is.
Yeah.
You make a valid argument. Yes. So this is x minus 2 squared.
Dude, I love it.
Dude,
like, I mean, you know.
I was doing math for like so long. So then we can factor out one of these. Cool, we're still left with the same problem.
Wait, y power to the 2. Okay, that's fine. Yeah.
I mean, we're left with the same problem, but it's a nicer
It's a lot
problem.
nicer problem.
Of course.
It's no longer 0 over 0. It's a value over 0.
Well, now, sick. Now we cannot use L'Hopital. Sick.
Maybe we should have used L'Hopital from the start then.
But like, when we think about this, right?
I mean, it looks so much cancelable though. Like,
yeah, I think you're meant to do it like this.
What happens if we just divide everything by x though? Because then we get 1 here, 1 here, and this becomes divided by x.
It's 1.
Well, okay, this doesn't help.
Wait a
going to
second.
infinity, this doesn't help at all. This is going to turn it into 1 over 1 minus 1.
I mean, we're going towards -2.
No, we're going to 2.
Yeah, we're going 2 from the right.
However, if we look at the function...
yeah, just graph it, man.
We are not allowed any graphing calculator, but if we logically think about this, like, let's see, imagine we have this function, 1 over 2 divided by x. So imagine if instead of 2 we had 2.5, what would happen here? So imagine x equals 2.5, we would have 1 divided by 1 minus 2 divided by 2.5. 2 divided by 2.5, that's like a...
I mean, we can do try and error like that, but you know.
Yeah, what would the other method be though? Like,
is this not just infinity?
I mean, yeah, it is.
It is. It's just a constant divided by something that approaches 0. That's infinity.
But the
Yeah,
thing is,
it's just infinity.
Yeah.
I'm not 100% confident about that though.
No, I also. How is this infinity?
Well, because x is approaching 2 from the negative, right? So it's like infinitesimally smaller than 2.
Oh wait, no, wait though. Wait. We're approaching. Wait, no, we're approaching 2. Oh my god, I confused 2 from the negative side.
Wait, is it negative infinity or infinity?
It
might be negative, right?
It's
because it's going to be smaller, like just
right. Yes,
under
it's
0.
gonna be 2. Wait, 2 over 1.9 is gonna be smaller than 1. Wait, it's gonna be bigger than 1.
What?
Yes, 2 over 1.9 is gonna be bigger than 1. Therefore, it's gonna be 1 minus something bigger than 1. Therefore, it's gonna be a negative
1
number.
minus -0.
Yes, it's negative
Right,
infinity.
it's negative infinity.
Yeah.
Yeah, dude, this is helping me so
Oh,
much.
it is negative infinity. It approaches from the right.
No, because look, if you think about it, x is
right,
gonna be
but like it's a minus approaching from the right.
What?
no. Wait.
It's
I think that's where you're
one minus
confusing.
a fraction of the. My God.
Is this not a
Wait.
minus?
Let me explain. Because
All right.
look, x is gonna be, it's approaching 2 minus, right? That means it's just under 2. So it's like really close. But it's
Yeah.
minus 2, right?
Minus
So if-
2.
it's x minus 2 at the bottom, right? So it's
Yeah.
something really close to 2 minus 2, meaning it's going to be really close to 0, right?
But on the negative side.
On the negative side. And 1 over something really close to 0 is just infinity, right?
On the negative
'Cause
side.
the top will be a constant, so...
Yeah, it's going to be negative infinity. Okay.
Oh, so it goes. Yeah, I see.
Find the limit of ln of 1 plus 2x minus sine, 2 times sine of x over cos x minus 1. Well, this is going to be 1 minus 1, so that's 0. This is going to be ln of 1, which is 0 minus 2 times sine of 0 is 0. So it's going to be 0 over 0. Indeterminate form, L'Hopital!
Nice.
ln of, so first the original function, minus 2 times sine of x over cosine of x minus 1. Applying L'Hopital to top and bottom gives, let me scroll down a bit. Applying L'Hopital to top and bottom gives, well, this one becomes 2 over whatever this is. So 2 over this stuff. Minus, and this one becomes 2 cosine of x. And here the cosine of x is going to become a negative sine of x. What happens if we fill it in now? This is going to be 2 minus cosine of 0 is 1, right?
Yeah.
Yeah. So we're going to have 2 minus 2 over
0.
0.
Well, can we L'Hopital again?
Well,
to
yes,
loop?
but I'm first going to clear the fraction. So I'm going to multiply everything on top and bottom with 1 plus 2x. 1 plus 2x. 1 plus 2x. That way we don't have a fraction within a fraction. Okay, yeah, that's good. L'Hopital again.
I mean, I think.
So, let's see, here we have a product rule, and on the bottom we do as well. So let's say first we take this one to be the constant, and then we have to multiply that by 2, plus, then we take this one to be the constant and multiply by, well, cosine becomes negative sine, but we have a negative sign there already, so that's going to be positive sine of x, but then times 2 because that's also already there. Also, I'm going to group this 2 together with this 2 to become a 4, and put this 2 in front of here. Okay, so the top of the fraction is correct now. Hello? Yeah, okay, the top of the fraction is correct now. It's not pretty, but it's correct. Oh, we do have...
Right, yes, it is.
Yeah, okay,
I
I have an opening bracket too much, but it is correct. And then here, the bottom one, well, first we'll take sine of x to be the constant, or negative sine of x to be the constant, so that will become 2 times negative sine of x, plus, then we take negative sine of x to be the constant, and then the other one will become take the derivative of the other one, and that will just become 2. So we have, after doing some cleanup, we have oh no, okay, never mind. I thought you were going to cancel out.
Wait, should it become cos?
Good call. So let's see. First, wait. I did the same
There's
thing
one that's 2 sine of x, and the other one should be.
Yeah, no, I chose the same. I chose like the sine of x is constant twice. I shouldn't have done that.
Right, yeah, and the other one should be 1 plus 2x cos x.
Did I do my signs correctly though?
Ah, that's a good question.
Because, yeah, okay, so we have plus, and then we had negative sign, but negative sign became, wait, no, sine just becomes cosine, no negative signs involved there, so this should be a negative sign.
Right, right. And the sign above is a positive sign because we had a negative and that was a cos. All right, yeah.
Okay, so this should be correct. Then what happens if we fill in 0? Sine of 0 is 0, so this becomes 0 minus 1
1 plus
times
2x 1. So that's
So this is going to be negative 1.
no, wouldn't it be negative 3?
No, because 2x x is 0.
Oh right, my bad. Oof.
Okay, so we have negative 1, and the top is negative 4 plus 2 times 2 times 0, so it's just negative 4 over negative 1. So that's just 4.
Did that actually work?
It might have. I was worried about like our time, but we only have like 2 questions left.
I mean, damn, I guess we can just spam L'Hopital until we get...
Yeah, I mean, that's how it works. We have to find a linearization of the arctangent. Fuck off.
Oh my god, are you
Okay,
fucking kidding me?
assignment 8.
What was the answer for 7?
4.
4.
Because this will
Minus
become negative
4 over
and
minus 1.
This will fall away, and this
What's linearization again? I forgot.
Finding
they
the
gave us an equation.
finding the tangent line. The equation for a tangent line.
The L of x is equal to f of a plus f accent of a
times x minus a.
X minus a. So therefore, the linearization of this is equal to the arctangent of 1, or negative 1, plus 1.
The derivative of the arctangent
So
of
that's 1
negative 1.
divided by 1 plus x squared. So that's just going to be 1 over 2. Yeah, because it's 1 plus negative 1 squared, so that's 1 over 1 plus 1, 1 over 2.
Right.
And then we have x minus negative 1, so that's x plus 1.
X is our actual value.
Yeah.
Wait, no. Yeah.
Yeah, it is. So we have arctan of minus 1 plus a half times x plus 1.
Yep.
We don't know the arctangent of 1, right?
The arctan of 1.
P over
Wouldn't
4.
that be pi over 4? Yeah. Pi over 4.
P over 4.
Okay. Frac pi over 4. I swear to God,
I think
this
you
is gonna
have
kill me because
to...
I'm very bad at those.
Yeah.
Yeah, how'd you guys know that?
Luckily, grasple, like, I hope that they're just gonna, like, fix it.
Accept it?
Okay. Oh, and the last one is a...
That's negative pi over 4, I think. Because you got arctan of negative 1.
Estimate of an accuracy.
Wait. I think he's got a point though. It's we've got arctan minus 1, right?
Yep.
Yeah, so I think
So it's minus pi.
Minus pi 4, yeah. Minus
Makes
pi
sense.
4.
Okay, cool. I'm just trusting you guys blindly on this one.
Wait, how did you get half x plus 1?
Okay,
Where's
so,
the half?
So
That's the derivative of
arctan.
arctan.
Arctangent of x is equal to 1 over 1 plus x squared, and 1 over 1 plus minus 1 squared.
Oh,
is
yeah,
equal to 1
of
over
course. Okay, thanks.
Okay, assignment 9. So we have y is equal to ln of x. Let me actually put these in like the nice little signs. Then we have dy over dx is equal to ln.
Yeah, actually, that's the same equation, except this time x is different. Like, that's the same equation as linearization, but instead of having x staying x, x is the actual value of your x. So that's gonna be 19.00.
Well, we can
sorry,
just say
19.99.
We can just say dy is equal to the fraction of 1 over x times dx, and we know dx is equal to 0.01, I think. Yeah, and x is equal to 20. Therefore, dy is equal to frac 120 times 0.01 So let's
What's happening? What do we? How do we do this question?
No, I don't think this is it. I don't think this is it.
And why not?
No. All right, and then we multiply it with ln x. Sorry, we add it to ln x.
Well, we just plug it in.
Like we're using the linear approximation here.
No.
Yes, we are. Oh wait, no, I'm a dumbass. I'm sorry. Oh god damn it. I'm tired.
We're using the.
We're estimating the accuracy. We're not actually calculating inaccurately a value that's 0.01 apart.
Yeah. So basically, what we're doing is we're using the y or dy is equal to the derivative of y times dx. It's just that we have. Yeah, we have this one, dy. We fill in x for 20. We have dx is that one. So this is the answer.
Right. Yes, it works. It works.
Why we go this way for this question? Why we do it this way?
Well, this is the way.
It's okay. No, but actually, that's an application of the linear approximation. Basically, like, say you've got a value that's 19.99. You would approximate it using linear approximation using the formula we know, and the difference from the value of 20 would be the derivative of ln x times the difference between the actual values, which is 0.01, which is, in our case, 0.01 over 20. Do you see what I'm trying to explain?
How do we know we fill in dx 0.01?
Okay, I found. No, wait, that's not the right slide.
It's okay. God damn it! I understand it, but it's not simple to.
Not the derivative, but something else. Like how do you call this?
Which one? What?
Like the thing of dy is equal to f accent of y or f accent of x times dx. So like this. There is a proper name for this. For this one.
This is dy. Oh, I think this is just like derivative. This is derivative.
Was that not just? Wasn't it? Wasn't it the differential equation or something?
But this is the same thing, like dy over dx and f with this comma, like I don't know how to call it. This thing that.
I thought that was a differential equation.
Yeah, it could be something like that.
Exactly. Well, this is just differentiating.
Yeah, this is just differentiating. It's just that you have to know what they mean with the accuracy of. That's just like a dy and a dx. No, I'm curious because I know in which lecture it was.
So the accuracy of x is dx, I guess.
Yeah. So let's see. It was in the differentials. This is the differential.
Yeah.
Yeah. Okay. So like if we go to the slides, then the I will be talking about.
This was called no something changed, but the error.
Yeah.
The error.
Error, same thing. Like you can use.
I think this was the one lecture I skipped.
Yeah.
Yeah, but this is exactly what we're trying to do.
It's the other side of the linear approximation. You've got your linear approximation, and then you've got the actual approximation value. You know what I mean?
Yeah, you just have to see how accurate is it.
So the inaccuracy in
the
x or in y is dx.
Right.
So
is a
the inaccuracy in
derivative
y is equal to the function value at y times the inaccuracy in x.
Right.
And we
Wait, say that again?
So
say that again?
The inaccuracy in y is equal to the function value of the derivative times the inaccuracy in x. And you can like easily derive this, like no problem, because you know that the what they call the derivative of x is equal to dy dx. Like we've been using these interchangeably, but if you multiply both sides with dx, you just get this one. And like by the linear, by like the definition of like these things, this just means a very small change in y divided by a very small change in x is equal to the slope in that area. It's just that we've given them a little bit different names. I'm gonna check my answers because my parents have called me down for food 3 times already.
I knew it was for food. Yeah, it was in Dutch, but I was guessing it was for food.
Yeah.
To go for dinner.
Yeah. So hey, we had this one correct. 1 is correct. For 2. Oh shit, we had that one correct as well. Holy shit, let's go.
Nice.
Here we had 4 over 17 as well. That's correct as well. Sick. So I was wrong about that. Here we have 12 over 11. Yes, that's also correct. Dude, we're going hard so far. So what was this one?
So y over x is always just f.
Minus 3 over 2 was for 5 question. Minus 3 over 2.
Minus 3 over 2. And we... Oh yeah, okay. I was looking at this one, but that's just a page number. So it was minus 3 over 2. That's correct. We had that one good as well.
For 6.
You didn't stop the time, by the way.
Oh yeah, but it doesn't matter.
Like, I mean, we know it's under an hour, so it's good.
Yeah, exactly. So we good. Okay, so...
4.
Yeah, so here we have negative infinity, so we know that one.
Yeah, that's good. 7 is 4. We've got it. We've got it.
So that was... Where did we write that one down? Oh yeah, we didn't write that one down, but we knew it from this.
Yeah, it's 4.
Yeah, now the linearization is minus pi over 4 plus 1/2 x plus 1. That's correct.
That's correct.
And then this one is 0.01 times 1 divided by 20. We have a 10.
We have 100% correct, guys.
100%
4 years ago, but...
but like, okay, it is taking into account that we are 10 people.
Yeah, and we had Google.
Actually,
we're 5 now. We're 5.
Okay, even with, like, okay, yeah, sure. 5 people, and we took a couple looks at the slides in Google. But, like, even without that...
We would have gotten a 9.
Like,
so did we do exercise A correctly or not?
We had everything correctly. We had
everything correct.
First 10, man. It's my first 10. I feel so.
That's a big oof.
Well, it's too bad it's not the actual test.
Yeah.
And that was not marked what we just did.
Exactly. Now do this again, and then on the test.
Exactly.
Alright, well guys, I'm signing off. Thank you
Thanks,
all for joining me.
Thanks for the session.
Thanks, man.
Like we've been on this for 8 hours.
Yeah, the five men which survived are we survived.
Yeah.
I mean, I was in this at 10:30.
Yeah, I was from 11 here. Yeah.
Yeah, well, me too, so.
Yeah.
I was the first one connected. Woo! and I played a game of chess whilst waiting. Too bad. Listen, I was winning so hard, but then I ran out of time.
Oh. Anyways, I'm gonna stop the stream here. If you're from YouTube, have a nice day. And
have a nice day. Yeah.
Your exam.